देखेंगे हम ये इतना सेटअप करा है मैसेज कर दिया उसको ಸ್ಟ್ರೀಮಿಂಗ್ ಊರ ಕಡೆ ನಮ್ಮ ಕಡೆ ಸೋಷಿಯಲ್ ಮೀಡಿಯಾ ಸ್ಟ್ರೀಮಿಂಗ್.
We understand the importance of staying ahead in today's fast-paced world, and Gen AI tools are designed to give you that competitive edge.
ಮೂರು ಸ್ಟ್ರೀಮ್ ಆಗ್ತಿದೆ ಅಣ್ಣ.
ಅದು ಅಲ್ಲಿಂದ ಕೇಬಲ್ ಬೇಕು. ಅಲ್ಲಿ ಯಾರು ಕ್ಯಾಮ್ರಾಮನ್ ನೋಡೋ ಕೇಬಲ್ ಕೂಡ ಕೇಳೊಂದು HDMI.
ಈಗ ನಮ್ದು ಏನು ಮಾಡೋದು ಕೇಬಲ್ ಹಾಕೊಡ್ತಾರೆ ನೋಡಿ. ನಿಮ್ಗೆ ಏನೇನು ರಿಕ್ವೈರ್ಮೆಂಟ್ ಬೇಕಾಗಿ ಕ್ಯಾಮ್ರಾದಿಂದ ನಮ್ದು ಕೊಡೋಕ್ಕೆ
ಅಲ್ಲ ಒಂದು ಕೇಬಲ್ ಬಂದರೆ ಸಾಕು.
ಇದಲ್ಲ ಅಲ್ಲ ಸ್ವಿಚ್ಚರ್ಗೆ ಇಲ್ಲಿಂದ
ಇದು ಅದು ಕೊಡ್ತೀನಿ ಇದೆ.
ಅಲ್ಲ ನೀವು ಏನೇನು ಬೇಕಾದ್ರೆ
ಇದೇ ಆಗಲ್ಲ ಸರ್, ಇದು USB ಇಲ್ಲ ಇದಕ್ಕೆ. ಹಾಂ
ಹಲೋ ಹಲೋ ಹಾಂ ಬೆಳಿಗ್ಗೆ 10 ಮಿನಿಟ್
ಪೈಜೆ ಮಾಡೋ. ಯಾವ ಟಿ ವಿ ಕೊಟ್ಟಿದ್ದೀರಾ? ಅದೇ ಬಫರ್ ಮಾಡಿಲ್ವಾ ನಿಮಗೆ ಫಸ್ಟು ತೇಜಸ್ ಅವರು?
ಬೇರೊಂದು ರೋಹಿತಲ್ಲ ಅಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಸಿಸ್ಟಮ್ ಏನೇನು
ब्लैक मैजिक गेन है मान लो किरा तिथे केबल तो लाइन की तो जो बैक तो लाइन की तिथे केबल सोत की गेने जा अल्लिंदा बरताना केबल इधर
जी सर
उधर से आएगा केबल इधर.
ये सब केबल आपने मांगा है ना? केबल नहीं उधर से
भाई
कैमरा आउट करना है इधर से लेकर
ये नेल से
अगले वो क्या हां यहां कॉपी ये कर लिया सभी फोटोज कॉपी करके डिलीट करके दो ना कार्ड एम्प्टी करके देना ऐसी ठीक है. ಇದೇನು ಮಾಡೋದೀಗ ಹೇಳು ಏನು ಬೇಕಂತೆ ನಿಮ್ಮ ಪ್ರಕಾರ ಮತ್ತೆ ಒಂದು ಸ್ವಿಚ್ ಕನ್ವರ್ಟರ್ ಬೇಕು ನಾನು ಆರ್ಡ್ರ್ ಮಾಡ್ಬೋದು ಜೆಪ್ಟಲ್ಲಿ 2 ಕನ್ವರ್ಟರ್ ಆರ್ಡ್ರ್ ಮಾಡಿರಿ ಅದಕ್ಕೆ HDMI ಇರೋದು. ಹಾಯ್ ನಮಸ್ಕಾರ ಏನದು ಅರೌಂಡ್ 7:30 USB to HDMI ಇಲ್ಲ USB-C to HDMI ട്രാഫിക് ഉണ്ടായിരുന്നു ഇതാണ് ഇനിയിപ്പോൾ പുതിയ സെറ്റപ്പ്.
ಒಂದು ಸೀಟು ಡಾಕ್ ಬೇಕು.
ಟ್ರಾಫಿಕ್ ಸೀಟು HDMI ಅಲ್ವಾ?
ಡಾಕ್
ಇದೆ ಅಲ್ಲ ಸೀಟು ಡಾಕ್ ಇದೊಂದು ಬೇಕು.
USB ಎಲ್ಲ ಇರುತ್ತೆ.
ವೈಫೈ ಇರುತ್ತೆ അപ്പോൾ അവിടെ സെറ്റപ്പ് ചെയ്യും.
ಲಿಂಕ್ ಇಟ್ ಮಾಡಿ
അവിടെ പിന്നെ താഴെ ಸಿಗುತ್ತಣ್ಣ രണ്ടുപേരും അവിടെ ആയിരിക്കും.
ಇಲ್ಲ ಇರಿ ಒಂದು ನಿಮಿಷ ಇರಿ ಸರ್. ಒಂದು ನಿಮಿಷ ಇರಿ ಸರ್.
നിങ്ങൾ കഴിച്ചോ?
ನಿಮಿಷ ಅವ್ನು ಬರ್ತಾ ಹತ್ರ ಟೈಪ್ ಸಿ ಟು USB ಇದೆ. ಯಾಕೆ ಸುಮ್ಮನೆ
ನಮ್ಮ ಸಿಸ್ಟಮ್ ಕನೆಕ್ಟ್ ಮಾಡೋಕೆ ಒಂದು HDMI ಅಂತ ಬೇಕಲ್ಲ ಫೋಟೋ. ಅಲ್ಲ ಇದೆಲ್ಲ ಲ್ಯಾಂಡ್ ಇದೆ HDMI ಇದೆಯಾ? ಇದೆ ಗುರು.
इधर काले कंसोल अच्छी काले नहीं करा है बाजू से बैक ये बाहर है
64 के
लैपटॉप HDMI
ಇದೆ USB ಇದೆ
केबल है यार
ಲ್ಯಾಂಡ್ ಇದೆ ಒಂದು ಸಾಕ ಇದು
ಟೈಪ್ ಸಿ ಟು ಹೇಗೇನೆ ಜಲ್ದಿ
ಇಲ್ಲ ಇದೊಂದು ಇದೆಯಲ್ಲ ಸಿ ಇರೋ ತರಿಸೋದು
USB
ಸಿ ನೇ ಗುರು ಇದು ಅಲ್ಲ
HDMI ನಮ್ಮ ಟೈಪ್ ಸಿ ಟು USB ಅಯ್ಯ
USB-C ಇದು ಪೋರ್ಟ್ಗಳಿರೋದು. ಫಸ್ಟ್ ಒಂದು ನೋಡ್ದಲ್ಲ ಗುರು ಅದೊಂದು ಫಸ್ಟ್ ಒನ್ ಇದು USB-A ಕೊಟ್ಟಿರೋದು ಅದು ಸಿ ಇರೋದು ಓಪನ್ ಮಾಡು. USB-C ಟೈಪ್ ಇರೋದು ಇದು USB-A ಇದು USB-C ಟು ಇದು ಬೇಕಾಗಿದೆ ಅದೊಂದು ಇವಾಗ ಬರೋದಲ್ಲ ಅದೊಂದು 2 ತರಿಸಿರು
ಸರ್. ಒಂದು 3 USB ಟೈಪ್ ಸಿ ಟು ಅದು USB ಡಾಕ್ 3-4 ತರಿಸ್ಬಿಡಿ ಸರ್. ಒಂದು ಲ್ಯಾಪ್ಟಾಪ್ ಇರ್ತದಲ್ಲ
ಎಷ್ಟೈತೆ
ಒಂದು ಆಗಲ್ಲ
ಒಂದು ಸರ್ ನಿಮ್ಮ ಹತ್ರ ಹೋಗ್ಬಿಟ್ಟು ತರಿಸ್ತಾ ಇದ್ದೀನಿ ಕೇಳ್ದ
ಇವಾಗ ನಿಮ್ಮದು 3 ಕ್ಯಾಮ್ರಾ ಎಲ್ಲಿದೆ? 3 ಕ್ಯಾಮ್ರಾ ಇದೆ.
ಕ್ಯಾಮ್ರಾ ಕಟ್ಟಾಗಿ ಇಲ್ಲೇ ಇದೆ.
ಓಕೆ ಯಾರಿಗೆ ಕೊಡಬೇಕು ಸ್ವಿಚ್ಚರು?
ಸಿಸ್ಟಮ್ ಮತ್ತಿದ್ದು
ಅಲ್ಲಿಂದ ಇನ್ಪುಟ್ ಹೆಂಗೆ ಮಾಡ್ಕೊತೀರಾ? ರೆಕಾರ್ಡಿಂಗ್ ಅಲ್ಲ
ರೆಕಾರ್ಡಿಂಗ್ ಅಷ್ಟೇ ಸ್ಟ್ರೀಮಿಂಗ್ OSP ರೆಕಾರ್ಡಿಂಗ್ ಕ್ಯಾಮ್ರಾ
ഒരു മിനിറ്റ് 1 second ഒരു സെക്കൻഡ്
ಒಂದು ಯು ಎಸ್ ಬಿ ಅದು ಬಂದಬೇಕಾ ಅಲ್ಲ ಯು ಎಸ್ ಬಿ ಅದಕ್ಕೆ ತರ್ತಾರೆ ಇಲ್ಲ ಇದು ಯಾರು ಹಾಕಿದಾರಲ್ಲ
ಹಾಂ ವಾಟ್ ಸಂದೀಪ್
ಬಿಟ್ಟರೆ ತೌಜಾ ಎಚ್ಚೇರಿಗೇನು ये तो जब इतने से कैमरा से बाजू सेटअप करने जा जल्दी जा
ಆಗಲ್ಲ ಇಲ್ಲಿ ಆಗಲ್ಲ इधर नहीं हो रहा क्या
नहीं नहीं करेंगे जा जल्दी जा जल्दी जल्दी चेक केबल ಎರಡು ಮಾಡಿದ್ದೀರಾ ಸರಿ ಕೇಬಲ್ಗಳು ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ ಫಸ್ಟು ಜಲ್ದಿ ಆ ಕಡೆಯಿಂದ ಓಡಾಡ್ತೀರಾ ಆ ಕಡೆಯಿಂದ ಓಡಾಡ್ಬಿಡಿ ತೊಳಿ ಮತ್ತು ಯು ಎಸ್ ಬಿ ಹೇಗೆ ಜರ ಜಲ್ದಿ ಟೈಪ್ ಸಿ ಟು
ಚಾರ್ಜರ್ ಇದ್ದಿದೆಯಾ ಪೆನ್ ಇದೆಯಾ
ಸ್ವಿಚ್ ಪಡ್ಗಲ್ ಜಾಂದೆ ಸೋಟ್ ಟಾಕ್ರಿ ಜಲ್ದಿ ಏನೇ ಜಾ
ಕಾಣ ಆಯ್ತು
एक स्विच बोर्ड हो
ಬರೀ
ಟೈಪ್ ಸಿ ಟು ಯು ಎಸ್ ಬಿ ಅಯ್ಯಾ
ಸ್ವಲ್ಪ ಲೆಂತ್ ಇಲ್ಲ ಕೇಬಲ್
ಲೆಂತ್ ಇಲ್ಲ
ಹಂಗೆ ನಂಬರ್ ಕೊಟ್ಟಿರ್ತೀನಿ ಉಂಟಲ್ಲ
ಬರ್ತಲ್ಲ
நம்மளுக்கு போட்டுருக்குதா
ಓದಿಡ್ರ ಅವ್ರದ್ದು
ಬಿಡ್ತಲ್ಲ ಎಲ್ಲ ಲಾಸ್ಟ್ ಮೂಮೆಂಟಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ ಒಂದು ಲ್ಯಾಪ್ಟಾಪು ಒಂದು ಅಡಾಪ್ಟ್ರು ಒಂದು ಟೈಪ್ ಸೀಟು ಅದು ಯು ಎಸ್ ಬಿ
ಇದು ಕನ್ಸೋಲ್ಗೆ ಹೋಗುತ್ತಾನೆ ಇದು
ಎಲ್ಲ ಎಲ್ಲ ಇಲ್ಲಿಗೆ ಸ್ವಿಚ್ಚರ್ಗೆ
ಏ ಬ್ಯಾಗ್ ಅಲ್ಲ ಯಾಕೋ ಚಾರ್ಜರ್ ನಾನು ಏನು ಮಾಡಬೇಕು ಇಲ್ಲಿ ಇದು ಜಂಕ್ಷನ್ ಜಂಕ್ಷನ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಇದೆ ನೋಡು
ಡಿ ಸಿ ಪಟ್ಟಿದ್ದೇನಾ
ಡಿ ಸಿ ಪೊಲ್ಲ ಡಿ ಸಿ ಪೊನ್ನ ಬ್ಯಾಟ್ರಿ
ಕಟ್ಟುತ್ತೆ ಅದನ್ನು ಕೊಡು ಸರಿ இந்த பக்கம் வேடா முன்னாடி வேடா எங்கட நிற்கிறேன் நீ பார்த்துக்கோடா
ஃபோன் பண்ணிட்டா ஃபோன் பண்ணி பேசினேன் டேய் பார்த்து பண்ண அமௌண்ட் போடுறான்டா
ஃபோன் பண்ணி
ಇಲ್ಲಿ ಯಾರು ಮೂವಿಂಗ್ ಇರಲ್ಲ.
ತೆಗೆದುಕೊಳ್ಳಬೇಡಿ. ಹೂಡಿಕೆ ಬಗ್ಗೆ ಹೆಚ್ಚು ಜಾಗೃತಿ ವಹಿಸಿ. ಯಾವುದೇ ಅನುಮಾನಾಸ್ಪದ ಘಟನೆ ಕಂಡು ಬಂದಲ್ಲಿ ತಕ್ಷಣವೇ 1930ಗೆ ರಿಪೋರ್ಟ್ ಮಾಡಿ. ಈ ಸಂದೇಶವನ್ನು ಗೃಹ ಮಂತ್ರಾಲಯದಿಂದ ಜಾರಿ ಮಾಡಲಾಗಿದೆ.
मिलूगे नविंदा अजने को बैग एंड सर्च कर लो सीटू USB ते पिनो आई चेक कर हाँ ओके
Check. 1, 2, 2. Check. Ready? Check, check. 1, 2. Check.
Ladies and gentlemen, we will shortly begin the conference. Just checking, just checking. ठीक है? How do I switch it off from here? Damn it. बंद कर दो, बंद कर दो, बंद कर दो, बंद कर दो. gentlemen, we will shortly begin the conference. Please be seated. Also, I would like to seek your cooperation in completing this conference. So together, let's make MLDS a roaring success. But before that, I would request you all to kindly switch your mobile phones to silent mode and get ready to absorb everything that our speakers have to offer here. Thank you for the cooperation.
The spark, a relentless curiosity to break limits. Technology was once a tool. Now it drives transformation. It amplifies ambition. It reshapes the world. Visionaries didn't just dream, they built. Systems didn't just evolve, they revolutionized. Progress became inevitable. And here we are, standing on the edge of something even greater. The next breakthrough, the next revolution. Welcome to MLDS 2025.
Good morning, ladies and gentlemen, and all geeks in the house. A very warm welcome to the 7th edition of India's biggest generative AI conference in India, which is the Machine Learning Developers Summit 2025, organized by AIM Media House. My name is Moshmi Sinha, Associate Editor, AIM, also your host for today's sessions here at Audi 3. MLDS stands as India's biggest GenAI summit for developers, bringing together the top minds and practitioners in artificial intelligence. Over the next 2 days, we will explore groundbreaking innovations in AI, deep dive into real-world applications, and witness the transformative impact of AI on various industries. Thank you all for being here. We're excited to have an incredible lineup of speakers, and we can't wait to get started. We promise you a ringside view of the new trends and products that will dominate the scene this year. We also have parallel tracks running in Audi 1 with our keynote speakers and Audi 2 with tech talks and workshops. Please make it a point to join your favorite sessions whenever you can find time. Besides, we are also going to have a lot going on outside too. There'll be mentoring sessions, hackathons, awards, exhibitions, live coding, competitions, and lots more. Now, before we start the sessions, let me quickly make some announcements for you. We're excited to announce our fun and engaging series of activities, Code Craze, happening every day in Hall 1 at 1 p.m. Don't miss out on the chance to participate, have some fun, and win exciting goodies. We are also running some off-stage activities in the open learning area located in the lobby. Get ready to join our thrilling code sprints and grab your chance to win some fantastic goodies again. For everyone eagerly awaiting the 40 Under 40 Data Scientist Awards, here's a quick update. The ceremony is happening tomorrow at Hall 1, starting at 2:30 p.m. So make sure to join that. We hope this day will bring you a lot of learning and a lot of great connections. Also, a massive shout out to our incredible sponsors. A big thank you to Genpact and Mathco, the powerhouses making MLDS 2025 possible this year as title sponsors. Let's also extend our gratitude to our AI partner, Google Cloud. A special thanks to our platinum sponsor, EY. Our gold sponsors are Synchron and WEX. Last but not the least, we appreciate the support of our silver sponsors, Insight, Intel, and Tiger Analytics. This conference wouldn't be the same without your valuable contributions. Thank you all for being part of MLDS. Can we have a big round of applause for the sponsors? Also, don't miss out, our sponsors are showcasing their innovative products at the booth in the lobby. Be sure to stop by, check out their offerings, and you might even score some fantastic goodies. Enjoy exploring. Now, without any further delay, let's kick off today's sessions with a series of paper presentations. We kickstart MLDS 2025 with research that tackles the challenges of accurately categorizing customers for retailers to enable precise, targeted marketing strategies. This paper introduces an innovative method for analyzing purchase data and identifying key product categories leveraging LLMs. It details the data source, model architecture, and evaluation metrics used in the segmentation. Let's hear more on this from Nikita Katyal, Head of Analytics and AI at Central Retail Corporation in Thailand. With over 11 years of experience in data science and R&D, Nikita has worked with Target, Lowe's, Macro, an IIT Bangalore alumna. She excels in data modeling and analysis. So without wasting any more time, let's welcome Nikita Katyal on the stage.
Hello. Yeah, it's fine. Thank you for a good introduction about me. First of all, good morning, and I'm really honored to be first speaker of this room. And because I'm coming from Thailand, I must greet you coming in the front saying, Swadika, everyone. We will start this paper presentation that I have recently written over live stage customer segmentation in my current form. But before coming to that, let me know a little about me, myself. Who am I? So this is me. This is Nikita Katyal. I am graduated from IIT Bangalore. I have done my MTech from here itself. Then started my career with the Target as a data scientist and continued with the US retailer Lowe's. Later shifted to Thailand, Macro, one of the retailer in Thailand, and currently heading analytics and AI team in Central Retail Group, same in Thailand itself. So if you see the journey, I have been always part of different retailers, so I have been doing a lot of stuffs again and again. But as our journey of machine learning and AI is emerging, I'm also emerging all my projects again and again. So when we talk about segmentation, this name, I think, since last 12 years of my career came to me again, and I keep doing it in different manners, starting from very traditional machine learning, what I studied in my college, my education at IIT Bangalore, using my traditional style of clustering algorithms. Whenever I have anything related to this word, I will jump to my transaction data. Being the retail transaction data, we have a lot of historical sales, how the patterns of their customers, and for us, for everyone, I guess, knowing our customers is no longer a luxury, it's a necessity. If we are not hitting the right customer at the right time, we are missing out the opportunity in the market. There are many competitors waiting for the same. So hitting this problem right way, I realized in my journey, it's very important. And when starting as a junior data scientist and learning to be part of this journey, I always used to do with a very basic RFM model that everybody knows about, recency, frequency, and monetary model, where we see the patterns of our customer and do our segmentation based on how much they are spending, how much they are loyal to us. And this comes to be very good and reliable results. And being a data scientist, I'm always happy to do this. But today, when I'm not just a data scientist, I'm heading a team where I need to connect with other teams also. So always marketing team comes to me. Nikita, the work is awesome. We see a very good results. It looks good to me. These are the loyal and these are the upcoming customers to me. But what I do with that? Because we need to connect to our business to launch anything, to be utilized anything. Today, I do not do anything that is mostly techie if I'm not connecting it to my revenue. I look at revenue, then I start coding anything in my career. So to answer my marketing team, how I do, because I also had the analytics here, so I'll prepare a beautiful dashboard where I'm showing the segments of my customer, showing top customers, loyal customers, and the bottommost customers with their sales distribution, so that they will be knowing how they are showcasing and what are their contribution. And with this, we know like these are the top customers contributing this much sales, and what is the retention rate and how much they are shifting in their patterns. So what we want at the end, all my customers to the A segment contributing the maximum to my business. That is what my aim is. Still, the dashboards are good to look, they are good, very happy with me. But what next? If nothing is changing in this graph, nobody is moving, retention rate is there, conversion rate is there, but nothing is changing too much. Can we do something really special to my customer to have benefits over here and to showcase to my stakeholders? Yes, I can do targeted promotions. So what targeted promotion means? So if I'm sitting and I have my mobile phone in my pocket, I get a notification. Hey, today is a sale on many Poco Pens diaper, 10% off. Being a single person or a bachelor, I'll be like, what is this? Just stop the notification from this app. I'll close the notification right after. But being a mother of an infant, I'll be like, oh, it's a 10%, let's order 2 packs today. So targeting the right customer with right promotion is a challenge. We always have seen in my journey that broadcasting our top offers to my top customers, what is A segment, that is quite common because I want to retain my A segment to my company. So I will send all my top offers to my diamond customers to have the good conversion rate and good revenue. But that never happens because this broadcasting disturbs my customers, and disturbing my customers, not making me happy, I may lose them. So that is where we came up to our strategy when we have AI in place. How can I help with my AI for the marketing team little more to grab my customers? There where my paper live stage segmentation utilizing LLMs came into the picture last year. Because LLMs were growing, we were learning a lot about them. We realized, can we get to know me being any of this segment so that I know you, which life stage you are, so that I can send you the proper notification of my promotion today. I have a promotion in my hand, I have your transaction data, but I just know from the transaction history, simple RFM model, how much you are spending and what products you are buying, but not exactly will this offer fit to you or not. Because we had different life stages of the customers. Some customers are coming with their teenagers, some with infants, some are single, some are the couples, and some come with our old age members in their family. So they have the different purchase patterns with their categories and products. And when we have the products, we have the products metadata. With products metadata, yes, we have the LLMs in place. So LLMs can come in to understand what is this metadata, what they are stating to us, and can define me a beautiful life stage of my life. Because if I ask my customer to fill the survey, what is your age, how many of your family members, even we tried, the marketing team tried this one. Nobody was interested to fill that pamphlet, and it was of no use. So let's try from the transaction data itself. Sorry. So what was the challenge? Accurately classifying my customers, and in retail market, because I work for a retailer, before targeting any marketing promotion. I will not broadcast any of my promotion until I know which customer is suited for that. And because I already have the segments in place, my diamond A cluster, my gold cluster that is B, and my bronze that is C, so I can use, if I today want to just target my diamond customers and want to retain and gain more revenue because they are the revenue creator for us. So I will put my understanding of LLMs of their life stage only for the top A segment to know who all are at which life stage to target with my promotion very well. Solution, yes, it's an AI word, so we use LLMs. Analyzing product metadata. Product metadata with, I mean, product title, all the attributes, and if description we have, that is the one. And using our segmentation on this data. So the data preparation was the key over here, how to scrape the data collected all over to ingest into our pipelines. And how we did this. So we did this with annotating the data. So we are in the OpenAI world where we can do some prompt engineering and get the results what we want. But it comes with a cost. And asking for a cost from a company approving that legal documents, it takes time because it takes security, to governance in place, and then you need to estimate the budget. And I think in that time, I could have done the project itself. So we started, how we started this project, a cost-effective project, we took 100 samples from each product category. These 100 samples of the product, so collected the product data for all the products, but took the 100 top samples from each product category in order to generate tags. And tags are the life stage tags. The life stage tags are about, are you the family with an infant? Are you a family with a mix of a teenager and an infant? Do you have an old age member at your home? Do you have, or you just have a wife at home and you're single, or a couple? So that is also a special segment for us to target. So this is what the data collection helped, and annotating, getting these 100 samples, what we did, we used the GPT-4 and with the prompt tuning to generate some tags for us. And these tags were generated, but we want an expert to look at because we were having such small samples. Rather than asking our business stakeholders to create the tags for us, utilizing the product. So I have a product metadata. I want a tag for a product. I could have asked my stakeholders who know the products well to generate such tags for me, but it's so tedious, it could have taken a lot of time. So what we did, we generated from the GPT-4, generated sample tags and given to them to review it, because I wanted my training data to be the perfect one for the next training. So this was a quickest process rather than asking them to write and generate the tags for me. And this helped me to generate all the sample tags. And later, to make it work, what we did was fine-tuning small language models. In this case, we used Mistral 7B model. So for fine-tuning, we took the sample data and also the reason behind why you have tagged this product to particularly life stage. So that explanation along with the tag was an input for the fine-tuning of Mistral model. After tuning my model and doing a lot of prompt engineering, I got the result, and my result was for all 45K products that I have in my system. So all the products had the products tags generated along with the reasoning why you have given this product this particular tag. But yes, whenever we have experience, when we have output from LLMs, we need to post-process also to clean our data. Yes, then we had the post-processing script to clean all the metadata and to generate the final tags for my 45K products. Wow, now my tags are ready. It was a tedious and the toughest job in this work. How we did this. Here it is, the GPT-4 model. Unlabeled data, that was a sample set, 100 samples per category. GPT-4 model was used with the prompt, sample prompt there, to get me a class, infant, and along with the reasoning, why, to input my small language model. And later this data output will be used here to train my Mistral 7B and to generate my final output. That was the whole technical LLM stuff we did in this paper. This was done. But now what? This looked like this. We created the sample data into our database. So not to be utilized just for the segmentation, we can also utilize this data, if you see, to better categorize my products. So sometimes if we see, we have categories, And it is like manually categorizing. New product came in, and I have to, being a marketing team, I have to put it into some category. I will put it. But being a person, a manual task is there. But utilizing this system, you need not to do anything manual. You can ask my system which is the nearest match, which category looks good to them, and we can create a tag, and that tag can be used for the better categorization. And sometimes we also faced, we had this 45K products, but some products were not properly categorized in my system. So we did this exercise to recheck my categorization, whether this particular item, when I say many Poco Pants, does it goes to the baby and it should go to the diaper category or not. So this metadata was quite useful, but our aim was not this. Our aim was the segmentation and targeted promotions. So let's come over to that. What to do with these tags? Yeah, so we had the transaction data. So we utilized earlier the transaction data only how much they are spending, what they are spending, what is their frequency, recency, and the monetary value. But we here, because we have the metadata for our products, now we need to map it to the product data. Now, not the product data, product tags data, because the tags are generated and we have a unique set of few tags. Now the transaction data was mapped with each tag, not to the product. I started this journey to tag this transaction data with products also, but if you see 45K products in my columns, it will be huge and model will be confused to segment. That's why we very shortened this to the product tags itself, just few tags, and we mapped the transaction data here. Once we have the tags ready, now what? We realized this segment, others. This was quite huge because in our retail, I'm a retailer where we sell a lot of generic products like fruits, vegetables. We can't identify what is your life stage if you are just buying a fruit from me. So a lot of tags came to be the other. That is not a particular life stage identifier for me. So I had to take the second highest tag from here, because for us, I have a huge grocery at my store, so many customers just buy and most of their baskets consist of others category. So I had to take the second highest tag generated for this customer to understand that what is their life stage. But to even second highest, we realized it doesn't work as simple as that. Say, for example, today I have a birthday party for my friends or a baby shower party for my friend home. I'll buy a diaper pack from my store, but that doesn't mean I have a baby at home. So we have to have some threshold that I'm buying this frequently. So kept some thresholding to judge which customer belong to what, and later segmented, and this segmentation worked over my previous segmentation. So ABC segments over that, the segments like customers with baby, customer with teenager, so that we can target each segment based on first on the RFM model, later on to their life stage. So slowly we started targeting one segment at a time to analyze my market well. Are we working well and are we gaining anything of this exercise? Because it took a lot of efforts to do it. Yes, we gained. We gained very good KPIs and we showcased very proudly over our dashboards. It went quite well and we are still running it for our targeted promotions. What's next? It's done, but it's not never be done. So we have written the research paper over it. But as you have seen, there were like lots of others tag. That means when we put the thresholding over it, we had a lot of customers that lies in my other category, that I couldn't find any particular life stage for them. And then I have to do something for them. Till now, this research paper states until then, but what we are working on currently is incorporating semi-supervised learning using pseudo-labeling. So what we will be doing, we will be using this training data, what we have already prepared and tested by targeted marketing. So tested, if it is working for them, that means we have done a good job. So we have a set of customers that lie in each segment of their life stage. We will use this data for classifying my leftover other segment and utilize those high accuracy and high probability customers to again into the training set to keep on increasing and covering my others customers to put it in some segment. And for playing around a little bit more on the thresholding to check more whether it's working well for my segments or not. And it always works with the marketing team if they agree to help me with the targeting promotions. And I will better identify my customers to improve my accuracy day by day more. Being a data scientist, I realized a project never ends. It keeps on increasing. Your satisfaction cannot be filled until never actually. So you keep on increasing, keep on learning. Technology will be here and we will be going forward a lot. So on time. This is me, Nikita, with my contact information. Would be happy to connect with you and so glad to see this room full. Never thought of this. Khabun khai, everyone. For sure. Anyone, please, love to have.
So I have like a couple of questions.
Yes.
I have a couple of questions. First one was with regards to the tags that you mentioned about, in which case you used, of course, GPT-4 and Mistral, right? So tagging seems to be like a one-time activity for 45K SKUs. You just need to tag it once, and in any case, you needed to verify with the humans, right?
Yes.
So question is like, why do we even need to use any LLM for that?
Why?
So that is first question. And the second question is about after you do the customer segmentation and all that, right? And you identify the customer into a particular life segment. Are you complying with all the privacy laws and all that are coming in, especially Europe and all that? Is it allowed? I'm not aware of it. Just asking whether it's okay.
So to answer the first question.
Thank you.
Why we did this and how it will be utilized, why have to fine tune a model. So I have a market, a retail market. We keep on changing and revising our stock based on our competitors. So every month we have the competitor data in place that they have launched something, they have changed the prices, they have changed this. You need to put it. So this cycle, when we ingested this cycle, kept it in place for retraining. It is to entertain any change, anything happening in future, so that we keep not to hitting the GPT-4 again and again and asking the manual work again. Because once the training data is ready, we are now ready to go ahead with our smaller model already trained. I will not do anything even if you change the complete stock of the store or you generate a new store in the place. So because it's generative and stock changing is a very high problem with us, that is why we have gone through that. And to the next privacy question. So because if you see, I have not asked anyone anything. I have not peeked in your life anywhere. I just checked your transaction history. Even if I broadcast random target promotions to you, will you say anything to me? Will you put any case on a retailer? No. Even if you do not have. So it's just a product, what you have purchased. I'm just trying to utilize the data, what you have given to me, not utilizing any personal information from your end. So for privacy was something that was taken care of.
So
yes,
I'm really sorry. We are on a tight schedule here.
Sorry.
So
we'll connect after
any more
that.
questions, you'll be able to connect with her outside the hall. Thank you so much, Nikita.
Thank you.
So quickly moving on to our next paper, which is titled A Context-Aware Multi-Agentic Multimodal LLM Architecture for Digital Marketing. Now, Pixie is a framework designed to improve digital marketing through a context-aware multi-agent LLM. It supports real-time and offline marketing using multimodal LLMs for enhanced readability and performance. To present this paper, we have Vivek Vishwas Vichare, Head of Data Science and Analytics at Pixis. An IIT Bombay alumni with a master's degree from the University of Michigan, Vivek has over 16 years of extensive experience in AI, data sciences, machine learning, business strategy, and consulting. Please put your hands together for Vivek Vishwas Vichare.
Hello. Yeah. Good morning, everyone. Thank you for joining today's session. I'm Vivek, and I lead data sciences at Pixis. Pixis is one-stop marketing automation platform where we provide tools to digital marketers which are more AI native in order to improve their time efficiency and also improve their ROI on their marketing spends. Today, we are going to present our work on developing AI agents for digital marketing. It's a team effort. My entire team is here who have worked on this. But before getting into agents, just wanted to give you guys some context on how digital marketing works, just a brief context. So in today's world, digital marketing involves running campaigns, running ads across multiple platforms. The campaigns themselves are for different products and services, different objectives. Digital marketer has to identify optimal audiences, and then a lot of his time gets spent on optimizing the spends through strategic bid strategies, budget strategies. And he has to continuously monitor the performance as well so that then it can help improve the ROI. All this can become very overwhelming for the digital marketer, and what it leads to is less time for him and a lot of data at his lot of data that he's exposed to, but less time to analyze. So what it leads eventually is some inefficiencies and lower ROI. In recent times, what people, especially in digital marketing folks, have done is they have built specialized tools for each of these different tasks like targeting or bid optimization, budget optimization, media planning. The challenge with these tools, and of course, Pixis also has a lot of such ML machine learning models for the digital marketer. Challenge with these tools is that they are very specialized, they are siloed, and eventually digital marketer has to gather recommendations, insights from these tools and yet have to make the decision. So decision making still leads to certain delays in time. In last 2 years, LLMs have been used to solve some part of it that, hey, you can combine all the insights and LLM can probably synthesize it and provide outputs. LLMs have also been used for some of the very specific tasks like content creation, which has quite exploded in today's world when it comes to generative AI. Of course, there are some challenges over here. Mainly so far, and I mean, it's an evolving field, so far it has challenges with numerical computations. There are sometimes hallucinations, especially in a digital marketing when there are so many moving pieces. The reasoning has to be quite complex, and that's where LLMs have, at least on our experiments, have kind of shown limited success. So in recent 1 year or so, we have seen that the next stage of LLMs is using agents. Agents are essentially models, LLM models, which are equipped with data, which are equipped with some of these tools, and which are also equipped with, they can do multi-step planning. We have seen such agents used in different industries. So our work in Pixis has been to kind of develop Pixie, our agent that we are calling, which can help the digital marketer to automate his tasks.
Let's talk about the objectives of Pixie. The objectives are threefold. Pixie aims to be cross-functional. So Pixie currently supports multiple functionalities across marketing domain, like performance analysis, bid budget optimization, and so on. It also enhances these functionalities by making them work together. The framework is also very flexible. It can work with multiple data platforms and across multiple data types. And Pixie also tends to be really reliable because it generates contextually relevant recommendations, which are also very well structured and numerically precise. Now, there are three key components of Pixie. There are agents, which are large language models. There is a primary orchestration agent that coordinates the entire workflow. And then there are task-specific agents. These agents are equipped with tools, which are our proprietary statistical models, which are responsible for doing certain marketing tasks that an agent might not be able to do it by themselves. And the data for these tasks comes from knowledge infrastructure that consists of a data warehouse and a knowledge graph. Data warehouse is where we store our performance metrics, and knowledge graph stores relationships between brands, industries, and marketing keywords, which is needed to give more context to the agents about the use case.
Yes. So before we talk about Pixie in detail, let's also talk about the other architectures which we tried during our experiments. We tried 3 architectures all in all, in increasing order of complexity, of which Pixie is of course the third one. In the first architecture, we tried a single agent workflow where access of all the Pixie models were given to an LLM. And this single agent was asked to do everything from deciding budgets, bids, targeting, and things like that. Now, this is a scenario where, of course, you could see that this agent feels a little bit overloaded. And to help this agent, in the second architecture, we sort of gave it 2 more collaborative agents, and we sort of separated 2 tasks. We separated out analyzing performance of the campaigns, and then we also separated out reconciling the recommendations from different tools. And then there was a central recommender agent. This is more of a collaborative framework because all the agents sees all the communication, all the state graphs, and things like that. And still, recommendation in itself is involves a spectrum of recommendations or action types: bid, budget, creative, audiences. So in the third architecture, which is Pixie, we sort of made it even more specialized. So this is a hierarchical structure in which first we have a primary agent whose role mostly is to orchestrate between different agents. So user communicates with this primary agents, ask this agent that I have this query, I want this kind of recommendation. Understanding the query, agent sort of directs and calls relevant sub-agents. So here we can see that we have a review agent, task-specific agents, and reconciliation agent. Task-specific agents is just an abstract agent. Essentially, we have like 5 agents which are directly connected to primary agent, and primary agent communicates with that. Moving forward, yeah, we can. Yes, so yeah, I talked a little bit about primary agent already. Next, let's talk somewhat about analyzer agent. So this agent, mostly what it does is it analyzes the performance of the campaigns. It will fetch in all the metrics data, understands user queries, and it will do some sort of, you can say, RCA, that okay, this metric is going down, this metric is doing well, and then based on those metrics going up and down, it sort of recommends that okay, maybe today I need to take these sort of actions, and do we even need long-term recommendations or not? So we generally classify our recommendations into 2 types, tactical and strategical. Tacticals are generally short-term actions like changing bid budget, things like that. Strategical are long-term, like changing the structure of the campaign, changing bid strategy entirely, pausing a campaign, things like that. So yeah, those are tactical and strategical recommendation. Next, we'll talk about different agents in more detail.
So next agent that we have is Audience Explorer agent. Now this agent serves all the requests that are related to custom creation of audiences. Some example use cases can be that user wants audiences for any specific brand, any specific product, events or personas. So this agent kind of handles all such questions. In terms of data in terms of data, this agent pulls information from our knowledge base, which is graph database, along with supporting databases. Now, our implementation for graph data is in Neo4j, where we have interconnected data for brands, their metadata, and audiences for different platforms. Now, also, I mean, other than this, we have PG Vector that helps us with embeddings and some other like SQLDB for helping with other information. Now, tool-wise, we have quite a lot of tools here that help us, that help this agent in terms of scoring, figuring out the right flow that needs to be executed to get to the outputs. Execution steps, again, like most of the requests will be specific to some kind of audiences, so there we need to consider that flow, like proper execution steps are being followed, and pulling data from the databases. In terms of flow of the agent, it's little different from a typical agent. Here we try to make the question more detailed by figuring out the entities that are being asked in the question. We tend to figure out what are those entities from our knowledge base, append some context so that the agent understand what is being exactly asked by the user. And we also append some possible steps that can be taken by the agent to figure out the final output. This helps agent in terms of ensuring that it has enough context about what is being what's needed, and proper execution steps are being followed.
Yeah, so I will be talking about the creative agent. So in any ad campaign, there are multiple ads running, and in each ad, some sort of content is associated with it, whether it is image, video, or text. So we will be talking about image only here. So this agent scores the image on the basis of two aspects. First is performance metrics of past ad campaigns, and the second aspect is based on the visual quality of the image. And when the recommendations are generated based on these two aspects by the agent, it summarizes all these recommendations and sends it back to the primary agent. Now the scoring based on the visual quality here by the agent is the multimodal aspect of this agent, where we send the image as an input, and it scores based on the two elements, visual element of the image and the textual element of the image. Next, we will talk about the feedback agents. There are two feedback agents. First is the reconciler agent. Basically, it does is that it identifies any potential gap or conflict in the final recommendations that are generated by all the agents separately, and then it instructs the primary agents to regenerate the recommendations based on the feedback that was provided. The second is the reviewer agent, where it identifies any vague or non-specific recommendations, and then it instructs back the primary agent to basically include some specific metrics of the campaign assets in the final recommendations.
So once we had developed this kind of framework, we had to evaluate how the outcomes are. In order to do the evaluation, what we did was we did research on, did research on how a digital marketer daily workflow is. What are the different tasks that he does on a daily basis? And we mapped those tasks into questions which in an experimental setting and digital marketer can ask the agent, and then we mainly evaluated on questions, their follow-up questions, and we created this questionnaire for so far we have tested it for 4 diverse clients across their spends, across different platforms, across different ad types, campaign objectives. Once we got the responses of the agent, how we evaluated was, it was a twofold mechanism. One was expert evaluation, where the marketers who had actually provided these questions, they themselves evaluated the evaluated the responses, mainly on 5 to 6 key metrics that we again identified after discussing with the marketers, as well as there has been some literature on how typically agents are evaluated. So it's mainly about coherence, conciseness, how explainable is the recommendation, is the reasoning accurate, and so forth. There was another, because this process is not scalable, because we'll have to have more and more marketers where we'll have to put it out. In order to gather secondary response, we also kind of mimicked that process into LLM as a judge, where we provided these prompts on how, after discussion with marketers on, hey, how did you evaluate whether this was accurate or not? And we prompted the LLM to be the judge. And then further, we studied whether LLM as a judge is correlating with the expert evaluation. So what we observed is that one, when we have our Pixie agent architecture, obviously what we observed in the data that it provides better performance and in terms of explainability, reasoning accuracy. However, of course, it will come at increased latency and computational cost. We also observed there is good correlation between LLMs as judge and humans, which means that you can, scale this and do a lot more lab experiments before we can actually go out and test more and more human marketers. I think the challenging part comes here when it's not when there is a single question and answer, but challenge comes when there are a lot of follow-up questions based on one particular task that marketer is performing. In general, what we observed that the answers were reliable, but when the follow-up questions themselves were very composite. For example, what if marketer asked to now completely change the campaign objective and then provide recommendations? Those are the areas where we found that the agentic workflow was not working as expected. And it was, the responses were still generalized, but they were not specific. And that's kind of, one of the area that we have to work on as well. These are some of the results. So what we have done is we analyzed each agent. These are mostly based on our human expert evaluations that we had done. We had asked them to score on a scale of 0, 1, 2. 0 meaning they do not align with whatever recommendations they have provided. 2, that they completely align. 1 is partial alignment. As you can see with the hierarchical agent, the scores are kind of quite good. Of course, there is a lot that we can improve. This is work in progress. This is done with 4 brands, and LLM as a judge performed as well on 4 brands, which we want to now expand to more clients.
Okay, and to quickly cover the future directions, first of all, we see value in increasing complexity. So we wanted to cover marketing domain with more agents, more tools, hyper-specialized agents. And this will, of course, lead to increased number of recommendations. And if we increase number of recommendations, this will lead to more conflicts. So we will need to improve on the reconciliation logic so that these conflicts can be resolved. And also, last but not least, we wanted to improve our validation framework by including more evaluators and gathering more data points to make sure that whatever improvements we're bringing into Pixie, they actually make sense, they bring up accuracy, and they bring up usefulness of the tool. Thanks, everyone.
Any questions? Yes.
You showed about multiple agents talking to each other, right?
Mm-hmm.
You showed about multiple agents talking to each other. So just want to know the framework behind the talking to each other. Is it like LangGraph or QAI, Pydantic?
Yes, we use LangGraph.
LangGraph. Yeah. So do you want to show something on that side of the house, because how these agents are talking together, connected together, and all that?
Yeah. So like we have in appendix some of the snapshots from the conversations that goes. So if you look at a sample, first user starts with a very generic question that can you recommend optimal actions for this optimizer using basis its performance. So in the backend, agents are linked at we know which optimizer. Optimizer is essentially a group of campaigns that we want to optimize. Then first primary agent understand user is looking for performance analysis. It sends this query to analyzer agent. Analyzer agent bases that processes. Previous slide for
Sorry.
just a minute, yeah. Yeah, analyzer agent does the performance analysis. This is the output on the right hand side, which we can see with different metrics. We have just masked out the details. And then at the end, it also recommends what sort of actions are needed, strategic, tactical, creative recommendations. And in the next flow, after understanding the output of analyzer agent, primary agent now calls tactical recommender agent because analyzer agent had recommended that we need this sort of recommendations. Then similarly, tactical recommendation is generated its output. So and so will go, and then finally we'll reach at reconciliation agent, where primary agent will ask the reconciliation agent to evaluate the reports prepared by different assistant. Are there any conflicts? Are we making any significant changes? Reconciliation agent does that, and then if it doesn't find, it says to primary agent that everything looks good to me. Then primary agent will go to the reviewer agent. Reviewer agent will essentially check for if recommendations are well explained or not, specific to different campaigns or not. If reviewer is also satisfied, it will inform the primary agent that I am satisfied, and then finally primary agent will forward those outputs.
That essentially means two things to me. First thing is how you will evaluate this entire flow. Humans cannot evaluate. If I am in the bad mood, I will say 0 to everything. I don't know. Like human behavior is important, right? So that comes into picture. Second thing, you already use ChatGPT here, I guess. I think maybe it's 01 and something.
So it's 4.0.
Maybe the top notch. Who will be judge after that? Because you already use the topmost model to design your framework. After that, from where you'll get the Supreme Court judge to analyze whether everything is doing well, right? So what's your take on that?
So we had to bring in humans. At the end, we generated outputs for 4 different brands across different questions. And we asked them to label, like, are these answers concise, accurate,
Seriously, it is working? Like humans evaluate all these things and then give you...
Each in respective field. So in marketing, you have people who work on creatives, you have people who work on planning, on bids, on budgets, on everything. So basically those tools are a reflection of the organizational structure.
Yes.
So you can pin down those tools to concrete people who can evaluate.
Yeah, the analogy is very similar. Like, you are evaluating healthcare agents with the help of doctors and nurses. Over here, the experts are marketers. The marketers are evaluating on the basis of how functionally accurate these outputs are, or recommendations are. If the marketer believes that, hey, I need to increase budget by, let's say, 10% for this particular campaign. Is it aligning when it comes to what agent and tools have provided? And I think that's how the entire paradigm of, even machine learning is, that, you have certain, over here, you don't have a priori labeled data, but the labeled data comes from, it's more of an evaluation where marketers will evaluate that, hey, I got this, is it correct or not?
Thank you, but I'm afraid about the scaling part, seriously, because humans cannot scale to a level which we are looking for, right? So
I would say yes and no, but I think that's the reason we are also investing on LLM as a judge, where we can again mimic how the human experts are evaluating it. See, at the end of the day, what we have realized is that, LLMs, when you are training them for specific tasks, and over here, LLM, I am training it just to be as a judge, then of course, its throughput is much better when, as opposed to having, giving everything to them, and that's where they hallucinate and things like that. So that's the way we look at it.
all right, yeah, thank you.
Thank you.
Okay, please give a big hand to Vivek and the team.
Yeah.
Thank you so much.
Yeah, it's a team effort. Our ML ops head and all the data scientists have equally contributed to this work. Thank you, everyone.
Thank you, guys. I have 2 quick announcements to make. Yeah, you can give it to people at the back end. So I have 2 requests to make, rather. So when a session is in progress, I request you all to please be seated and not move around too much. The second one is, I've been told we cannot bring food items, tea, coffee to the hall. So kindly stick to that. Moving on to our next paper presentation. Our next research details the creation of an innovative biomedical chatbot aimed at improving patient question answering. It employs a mixture of expert model and combines them via a router. Our speaker, Gayatri Nadella, is an accomplished AI leader with over 13 years of experience in generative AI, machine learning, and data science. Currently working at Cognizant, she drives innovative AI solutions in NLP, computer vision, and Gen AI. Gayatri has also published impactful work in renowned journals and is a recognized thought leader in AI. Please welcome Gayatri Nadella on the stage.
Thank you for the great introduction. Good morning, everyone. I hope you all are doing well. Yeah. Today I'm here to discuss my work on leveraging GenAI in healthcare. Before I start, let me narrate my personal experience, which I had recently. So, a couple of days ago, I was trying to book a doctor's appointment with one of the renowned doctors we have in the city. So I waited for so many days to get the appointment fixed with the doctor. So even after getting an appointment, I got certain time slot to visit on certain day. I visited the doctor on the time slot given to me, but I'm surprised to see there is a long queue. And I could not get a conversation done in the time slot given. I waited for so many hours even after booking an appointment pretty earlier to get a conversation with the doctor. So finally, I got my turn to talk to the doctor. You know what? I hardly got few seconds to talk to the doctor and narrate my health symptoms because the doctor was already overwhelmed by talking to so many patients available over there, and I felt the conversation was so much rushed. After I came out of the doctor's room, I felt very regretful and thought I had to discuss so many things. I did not even discuss what all home remedies I have tried to the doctor, did not even narrate so many symptoms I was going through all these days, and I came out just in few seconds. That is when I felt, let me go to Google to search more and get extended advices. I even spoke to so many friends, family members. I even watched social media influencers talking about the same problem. But you know what? All of this caused a lot of confusion and anxiety in me. It did not lead to any conclusion or did not help me to get a better advice from all of these sources. So what is causing this trouble? Currently, in India, we have a very low doctor-to-patient ratio, which is 1:830, I would say. And it is more worse in other countries. We all know this. This is a major problem. And the information available in all of these sources like Google, YouTube, is so much confusing and causing a lot of anxiety in patients who are going through several medical symptoms. So this frustration has led me to think through idea of developing an innovative generative AI assistant that is backed up by a mixture of experts and intelligent retrieval system. So let me go back. What all existing approaches we have in the market right now? As you all know, I have gone through offline booking, so you might have also faced similar scenario in your case as well. Online booking, appointment booking is also similar, wherein you get chance to talk to only few seconds to the doctor and narrate your health condition, right? So the cost is also pretty much high, and you cannot get as soon as you want the appointment to be fixed. So online sources, I have already spoken from my experience, what all confusion it has created, how much misleading it is, and what all health risks it can cause if I adhere to those advices given in the online media, right? So the last option left with is traditional chatbots. Traditional chatbots are usually trained on rule-based data where they cannot understand complex scenarios and cannot remember your context for a longer duration of time. Hence, they cannot give you proper, tailored and personalized advices which you are seeking for. So, our solution, the very intelligent MOE-based, IRS-based system, is leveraging two major LLMs, the OpenBioLLM, MedLLM, which is widely trained on reliable data sources, and a mixture of expert system is formed, merging these two LLMs, and it is backed up by a RAG system, which is hugely trained on reliable and authentic medical database, and it is also trained on clinical Q&A data set designed by medical practitioners. So the first LLM which we designed is OpenBioLLM, which is a Llama 3 OpenBioLLM, 8 billion parameter model. This was chosen as our base model, which is fine-tuned on several records of doctor and patient conversation. I would say around 257K records of conversations are trained on this model. And coming to the second model, the MedLLM, we have taken authentic clinical Q&A information, close to 16.4K records of information from clinical Q&A databases from Hugging Face, and clean and pre-processed them, and made sure our MedLLM is trained on this clinical Q&A data. Coming to the RAG LLM, which is also a Llama 3 8 billion parameter model, which is backed by the VectorDB, which had a list of medicine and drug information and people's review on top of those drugs, which is scraped from authentic source of information like WebMD and this has been, the embeddings of these medicines are pushed onto vector database, wherein RAG can retrieve those medicine information and formulate an answer along with the mixture of expert system. So our entire solution is further fine-tuned and quantized so that we can achieve optimal accuracies in real time. So after a lot of experiments, we have adhered to a certain list of parameters and their values. You can see them on the screen. Learning rate of 0.01, a batch size of 2, LoRa layers of 8, and iterations of around 50K, and epochs are 4, and we have made sure the fine-tuning of these LLM 1 and 2, which is OpenBioLLM, MedLLM, is done on simple, deliberately fine-tuned on most viable option instead of sticking to high-end hardware. So we have to compress them in order to push them onto cloud systems in real-time inferencing, right? That is when we have quantized them using Q5 KM using Llama CPP, so that we can seize in real. Okay, so the OpenBioLLM, MedLLM, which we have chosen, are merged using MergeKit framework, so that it is used to, the MergeKit is used to prompt engineer and towards this model. It is understood by the 1, 2, or so we have designed a very lightweight UI, user-friendly UI using Streamlit for our prototype, and later on we went to Next.js for our production deployment. So you can look at some of the results which we have achieved throughout the process. So let me talk about some doctor-patient conversations. So the strengths of this model is to give you home-based remedies and basic care advices so that the user can quickly get into, curing those symptoms whichever he or she is going through. So LLM2 is strongly trained on medical Q&A data sets, the medical jargon, symptoms, and diseases data set designed by the medical PEL, and it can guide you through symptoms of those diseases so that the user can correlate to what he or she is going through, right? So LLM3 is very much excelled in providing medical advices. Basically, we have made sure only over-the-counter medical advices are given by the RAG, right? Because any AI over-the-counter medical advices wherein prescription is not required. So MOE will combine the strengths of both of this model, and it can route the appropriate responses end user. We have achieved very good metrics over our journey. Perplexity score of 1.23 for LLM, and LLM are here, context precision. Till now, viable AI assistant, which is accessible and whenever you want, which is accessible whenever you want, and can give you personalized medical advices. Apart from this application, it can be extended further in the area of medical research and education as well. So this to the doctors, which can help them to understand drug interactions and disease symptoms of several patients and can help them in their research data as well. It can also be further used as a second opinion advisory tool. It is quite normal. We as humans talk to one doctor and feel that, oh, I'm not satisfied with this particular opinion of the doctor. Let me go and talk to another doctor what he says so that I'll be more assured of what symptoms or diagnosis, what symptoms I'm going through and what diagnosis the doctor has advised, right? So obviously they can come back to this assistant and get a second, very good second advice, which is very much authentic because all the source data is reliable and most trustworthy. It can also be integrated with telemedicine platforms where people can talk to these assistants first before reaching to the actual doctors so that they can get a better picture of the health condition they are going through, right? So it can also be integrated with wearable devices where personalized notifications can be obtained, the diet plans or fitness advices or the people's health records can be monitored and shown over the wearable devices. So it has many other applications. So these are the three major applications I have listed. So I'm very much delighted to close this session today. And I'm open for the questions if you have any.
General LLM like GPT 4 and above. So those are all trained on all medical data.
Yes.
So in general, if I ask a question, any medical question to it or any other domain question, it is answering me that. And second thing is, there are some medically trained models like MedPalm and John Snow Labs. So any particular reason apart from the cost to not use specialized LLM or GPT higher end to develop this chatbot, and particularly you have decided to fine tune it?
Going with generalized models will not give you customized medical advices. So our main aim to go closer to doctor's appointment system, right? So any generic system will not help you with giving you a medical advice that are available on the OTC medication context, as well as it cannot analyze your huge and complex medical records to tell you what is the disease you are going through with the symptoms you are listing down, right? So that is why it is not ideal to stick to generic model. Rather than it is better to train your fine-tune with the actual authentic sources of data, because this is a very niche area and it will put the people's health into risk, right? So it is ideal to fine-tune it with the authentic sources of information rather than sticking to general AI assistants, I would say.
So, like I'm also working in medical domain. So we have explored this. I mean, there are options like MedPalm is there and John Snow Lab is there. So have you also explored those models and compared this with the fine-tuned one?
Yes, yes, we did try with existing models, and we found the answers were not very much contextually relevant to the user queries that we are getting through the chatbot, AI assistant, I would say.
Thank you.
Yeah, I have one question about. So I have one question about how did you fine tune this particular model, right? Over here. Yeah. So the question is about whenever you try to talk about the like in conversations that you're having with a doctor. Now let's assume that a mid-aged person, when he's having a conversation, maybe related to the same disease itself, or whenever you talk about a teenager when he's having the same conversation with a doctor, right? So the like in plan of action and then if everything will be quite different.
Right.
So how did you handle these scenarios? So when fine-tuning your models? So would you be passing the metadata as well along with the conversations, or like, and what was the plan of action for this?
It's obvious, yes, yes, definitely. Entire uh, data of the patient will be queried first so that a personalized response will be given to the user according to their age, health condition, etc.
Okay, so that was also considered when fine-tuning these models as well?
Yes,
Okay.
yes.
Okay, so the next question that I have is, so whatever the evaluation metrics that you were showing, right? So those were mostly with respect to using an LLM as a judge, right?
Mm.
So have these responses been evaluated by human evaluators, more specifically
Yes,
doctors? Or
obviously,
clinicians?
this AI assistant is thoroughly audited and validated by medical practitioners in the end. In case AI assistants do not replace any human, right? They can, accelerate their efficiency by helping them so that the doctors can concentrate on more complex and niche areas and handle critical patients. So it is to reduce their overwhelming work so that they can further validate these kind of AI assistants as well as concentrate on critical scenarios.
Okay, okay. So just one last question. So, like, did you get
Any other OTC based medicine, if it has to prescribe anything beyond the OTC medications or anything beyond the home remedies, it will definitely ask you to go and talk to the doctor and get a prescription from them.
Okay.
It will not advise on its own if it is very critical.
Got it.
Sir, can we give somebody else a chance, and you could connect with her later because there are other people also waiting. We can take just one last question. I'm sorry.
Yeah.
Yeah.
I just want to understand your thoughts on hallucination in the medical domain, because I'm just thinking about the adoption of Gen AI solutions in the medical domain. So if you can elaborate a bit on that.
Yeah, that's why we have adhered to those metrics in order to even cut down hallucinations. So if you look at those metrics, can show you how hallucinating the solution is in actual scenario.
I was talking more about the general medical domain itself. So, for example, there could be multiple solutions. So, for example, doctors, etc. Right? But we are talking about Gen AI solutions which have a limitation of hallucination, maybe in some form or another, right? So, just thinking about what is that impact on the whole domain itself. So, your thoughts on that?
That's why it is ideal to go with reliable source of information and fine tune your large language models, and also run through so many experiments and achieve better metrics so that the hallucination can be curbed out.
Cool. Thank you.
Hi, Gayatri.
Okay.
So I just here.
Thank you.
Hello.
I'm really sorry, we are running short of time, but okay, all right. One last team. Can we take one last question? Okay.
Observation about having a patient going to a doctor to see and saying that you didn't have few seconds. Then I think it's important to remember, doctor does not have an entity who's walking. Now, if he has a patient who's coming with a hernia, perhaps it'll take him 5 minutes to diagnose and say you got a hernia, you need an operation.
Yeah.
But that is not the same situation when you get a patient coming with a breast cancer.
Right.
You can't tell you got cancer, you're going to get treated.
Right.
It'll take him at least 45 minutes to 1 hour to actually explain and to have the empathy with him.
Right.
So I think one has to be very careful when you make a statement like that each patient, say that you go and see a doctor and are waiting for 2 hours.
Yeah.
There are reasons for it. The patient doesn't know who's walking in.
True.
So I think one has to be very careful when you make a thing that, oh, I've been waiting 2 hours. People don't understand that aspect of it.
Right,
Just to
right,
make
right. We respect that doctors are already overwhelmed and so much overloaded in treating our patients because of lesser ratio. The idea is that we have lesser ratio and they are overwhelmed. I really understand that. They know doctors are really capable enough to understand how much time on each patient they have to spend, and based on the criticality of the patient. I truly respect that, understand that. Thank you.
Yeah, thank you so much, Gayatri. That was a great first half with some interesting and deeply insightful presentations. We will now break for lunch and see you all right after it for some more exciting papers and talks with our esteemed presenters. I request you all to proceed to the lobby area for lunch, and don't forget to join us back at 1 p.m. for the next talk. Thank you all.
understands the world the way you do. Our AI spots threats 7 times faster, understands speech sentiment, helps prevent vision loss, predicts weather 10 days out in 2 minutes, translates thousands of pages in seconds, detects lead pipes to keep drinking water clean, eliminates paperwork so care is more human, generates from text, visuals, audio, and video, creates entire worlds from your imagination, creates this thing and that thing, a new thing, the new way to cloud.
Mathco began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and the tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of Mathco. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligned with a larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale Mathco from where we are to 10 times our size. 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Synchron is a leading global consulting firm for digital transformation and technology enhancements. We specialize in the financial services and technology innovation sectors. We work hard to become the trusted innovation and transformation partner of choice to our clients. Synchron's progressive technologies and optimization strategies span end-to-end artificial intelligence, consulting, digital, cloud and DevOps, data, and software engineering, servicing an array of noteworthy, top-tier firms. Our coordinated, cross-regional teams have deep domain experience in high-tech, capital markets, investment banking, wealth management, retail and commercial banking, asset management, exchanges, insurance, and payments, as well as cutting-edge technologies. Our 14,000-plus global employees, spanning 55 offices across 20 countries, are passionate about innovation and meeting new challenges.
Our team at Synchron is committed to pushing the boundaries of AI technology and delivering state-of-the-art solutions. We understand the importance of staying ahead in today's fast-paced world, and GenAI tools are designed to give you that competitive edge. The future is here, and GenAI is leading the way. and embrace the power of generative AI with Synchron Nexus tools.
Artificial intelligence.
AI.
Coexisting. AI.
Good afternoon, everyone. Welcome back after lunch. There's a slight delay in our speaker's arrival. We'll just start in another 5 minutes. Kindly settle down, please. Yeah, thank you.
Our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger gene. The Tiger gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner. Relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
Even before the world could start talking about AI and Gen AI, for the last 15 years, we have invested in AI with the pioneers in AI. We have built some world-class solutions around AI.
Wipro has been at the cutting edge of data science and AI for a while now. Wipro and I get to work across various and diverse industries, everything from agriculture to pharmaceuticals to healthcare to oil and gas.
So we are helping many Mang level customers in their transformation journey. So we have strategic consultants, we have domain experts, we have data scientists. So basically we do customer hand-holding right from the inception to post-deployment stage.
We have more than 400 plus use cases which are live. We embed AI into the end-to-end software development lifecycle.
Okay,
as well as we are working with our clients to infuse AI into the operations as well, the application management services, infra management services by bringing in the generative AI to enable an end-to-end transformation, autonomous.
I have a small announcement to make. So if any of you are carrying a visiting card in the name of Bhargav R, that's a wrong card you've picked up from the Synchron booth. So can you please go to the help desk and return it? We are looking for a card that has the name Bhargav R on it. Yeah, thank you.
Give me an okay when I should start. Yeah.
That we have, we have a great creche over here, and my daughter goes to that creche. At the end of the day, we get to spend time together with the strays, and we can spend some time with them and can feed them. I feel this is something which is
good afternoon once again. It's good to see a packed session. I request you all to kindly settle down. Our speaker is here. We are about to begin the second half of the paper presentation. Kindly keep your phones on silent and not to move around when the speaker is, kind of presenting the presentation. Thank you for your cooperation. This is the 7th edition of India's biggest Gen AI conference, the Machine Learning Developers Summit, organized by AAM Media House. My name is Prabhu M. I'm the senior editor at AAM. I'm also the host for your rest of the session here at Audi 3. We have some exciting presentations lined up. We'll start with the next one. In our first post-lunch session, we are going to explore a remarkable journey of young and dynamic team at ISRO as they pioneer artificial intelligence solutions for both space and terrestrial applications. The team delves into the unique challenges in deploying AI systems in orbit, creating robust models that functions under extreme conditions. They ensure reliable decision-making under stringent resource constraint. Let's hear more from Nitish Kumar, a leading scientist at ISRO, who has made significant contributions to AI and space technology. He has received Innovative Young Scientist Award from ISRO and the Innovative Project Award from INAE, the Indian National Academy of Engineering. Nitish holds a patent for an explainable AI algorithm and has led 17 AI projects at ISRO, collaborating with NASA and Caltech. He has also been instrumental in creating ISRO's internal AI agent and in launching the ISRO Space Agent. Put your hands together for Nitish Kumar, please.
Hello, I hope everybody can hear me. Sorry for the delay. Very great introduction. I have to live up to the expectations in the presentation now. So yeah, we'll be talking some interesting stuff, and I think the next these 3 days you're going to listen a lot. Perhaps this will be something slightly different from what you listen in other presentations. So this was on our annual report last year. We reached the moon, Shiv Shakti point, right? One of the hallmarks. Let me dive right into it. Okay, so I am Nitish Kumar, and already there has been a very great introduction. So I'll be talking about some of the AI applications that we try to do. Obviously, for obvious reasons, I cannot explain all the details of the missions that we do, right? I'm not the official spokesperson for ISRO. However, what I wanted to share was some of the experiences that we had and some of the indigenous Indian AI that we developed and the challenges, and it's very interesting how we solve certain problems. So it's kind of going to be a story, kind of like short stories. Okay. So we basically do a lot of things for the government, including, communication services, weather, cartography, education, and healthcare, disaster management, and we also do some spin-offs. So there is a lot of things that ISRO does at different levels, and there is a lot of appetite for automation. In space, automation, is very, very prized. It saves a lot of money. It improves the quality of the mission, the amount of science you can do in space. So for us, AI is very relevant. Now let's look at some of the areas, where AI can be applied at ISRO. So obviously, launch operations can be highly automated. They already are automated, by the way. And I think every generation has its own definition of AI. So there were AI scientists, even a generation before us, who were thinking, and rightly so, that they were working on AI at ISRO. So the definition of AI is changing a lot. So what we call as machine learning and data-driven AI is something that has taken off after the big data revolution that has happened, right? Before that, also, people were working on AI. So we do a lot of AI in launch operations, in spacecraft health monitoring. This I'll discuss in detail. We have a lot of interplanetary missions where we apply partially some AI. And obviously, Gaganyaan mission, the human spaceflight mission, has a lot of appetite for AI because we are putting a human, and a lot of operations can be assisted, can be automated with AI. Okay. Some of the things that we have already done with AI, and which I have done actually, some of the things is here. One of them is inspection systems, and I will discuss one case study there. And checkout basically is checking out a spacecraft or a space system before it is actually launched, right? And it's very complex. So we are trying to automate that. Earth observation is somewhere we have done a lot of automation, which is basically satellite imagery to data intelligence, basically input to the government. Let's say for agriculture, we want to understand something. We have a lot of cartography data, a lot of Earth observation data, and we convert that into insights, right? Something to look forward to in next coming years, swarm satellites, which means a group of satellites operating together as for one goal, a swarm of satellites. Docking experiment, I think recently we were successfully docked the first set of satellites, SpaceX, humanoids. So yeah, I think you get the picture. So let me talk about AI, and let us talk about how we at ISRO look at AI. So we first of all question what is intelligence. Very, very difficult question, not in our domain, right? And also intelligence is very relative, right? You feel more intelligent when someone not so intelligent is beside you, right? So very difficult to define intelligence, kind of relative. Also, what are the steps in which we can break down intelligence, right? Any automatic agent or autonomous agent, right, has to do these three things. So first of all, it has to sense something. Then it has to process that something, think about it, and take some action. So these are like essential steps. Now, very interesting is the story of AI development so far is actually along these lines. So you would have seen in 2011, 12. So I'm working in AI, by the way, when nobody was working in AI since 2013, 14, right? And we thrown out of a lot of meetings for something that was very futuristic at that time. Now, of course, it's very relevant now. So we started with computer vision and some initial data, data handling, you can say, kind of very intelligent data handling. So that was perception, getting sensor data, vision data, or any other kind of data, and just understanding that data to a certain bit. Also, computer vision itself is a cognition process. It itself is an intelligent process. So it also has certain, cognition and action also. Like classification of an image can be the final answer is action. But in general, it's more perceptive. And that's why computer vision is also more reflexive. You don't get a lot of explainability. It's not very expressive. Like if you look at CNNs and so many DNNs, right? These are not very expressive. So I would say that this is more like perception and then cognition. So cognition, we started with like data analytics was the very small step towards some analysis of the perceived data, right? And then today we have like semantic, which is basically all the LLMs, like they don't understand things at the bit level. They understand things at the semantic level. Like you do a RAG, you do a semantic search. LLM produces tokens with a semantic understanding. So this is like and now there are a lot of talks about conceptual understanding, like whether an LLM can think the way we think in terms of concepts, right? So what is a concept? Like I am able to speak to you because you guys already know a lot of concepts that I'm just triggering through my words. Like those who don't know the concept will not understand what I'm saying. That might be quite a lot of people here in that domain. But anyway, and then multimodal, right? Multimodal is again when you are able to handle all sorts of perception in different forms and combine them together into some analysis or decision. And then obviously action. Now, I think we are very good at perception now today. And the limit of this is sensors. Like Tesla can become much better if we have much better sensors. Because human body has amazing sensors, by the way. So most of the fight is still here, I feel. And then cognition. Cognition, we have done a lot of development in the last 2 years, especially after 2016, attention is all you need paper. And then in action, last year there was a lot of talk about language action models, if you guys have heard. There's a lot of talk about that mobile phones, you need not press any key. But somehow, it has not gone so far. But Gen AI is kind of very expressive. It takes certain actions, it gives you output. It is doing something, it can do something, right? So I'm placing it there, and robotics is definitely the next future, if you ask me, is going to be robotics. Because I have a lot to talk, we are done with the basics. Let me take you to the first case study that I wanted to show you guys. This is more about perception level, right, that I talked about. So this is something that flies in space. So this is a solar cell, which is welded in our lab, and then it produces energy for the satellites. This is very, very critical because it has to survive in the space conditions for 15 years. And we hope for like 22 years at least. So our tech due diligence on this, our inspection process on this is very, very strict. So if you apply any normal, even today's latest algorithms, if you apply, you can get like 99.99% or something, and that is not acceptable to ISRO. So for me, it was very difficult to go to these meetings and present this and be like, we can do one mistake in 1,000, and they were like, just get out. You cannot do that, right? Because we put like thousands of cells on one satellite, nearly 14,000, 15,000 cells on larger satellites. So that's not a good number. They were not happy with it. So they gave me a number, by the way. It was 1 in 10,000, you can do a mistake. That's 99.99. So I had to live with that, and it was around 2017, and AI was not at the level it is today. So yeah, so just wanted to share this experience, horrible experience at the beginning. And then from there, we thought, okay, what we can do. So which approach to use for classification. So one thing I want to tell everybody, and one of the reasons I came here is talk to all the developers is, in software development, I feel India has produced great amount of software, great developers, but we did not produce great softwares, right? In AI, I wish that India does not do the same mistake. I don't want all of you to become just AI developers. I want you to develop AI, okay? So that is the call for which, I want to give this whole talk. And this was the moment, actually, that we think what we can do. We can study a lot, and, all these methods don't work. So this was actually a boon in disguise, because it started out, getting our brain activated. So we thought, okay, we have to do something which is more human understandable, reduced abstention rate, better training measures. So this was something that we had to achieve. So let me tell you how we achieved it. Pretty simple at the end, but it took kind of 2.5 years to get here. Every day for 2.5 years, okay? And so one of the modules that we use is the latest YOLO thing, right? But this is not critical. Like, we just use it so that people can see where the crack is, only for that. This is something we developed on our own. I guess this is a pointer. Okay, anyway, this URSC symbol is something that we have developed and patented. And we have LSys2 module, which is trained over all the images. So basically, LSys2 is a CNN. This is our explainable algorithm that runs here. And it uses the CNN, by the way. And this is the object detection module. And we get an ensemble-based decision, in which these two modules are only used for decision making. And our accuracy has reached, like till now, we have not have a fault, by the way. And it's been 8 years. I think that was clappable. So how did we do it? Very interesting story. And I'm going to tell you more about the thinking part, right? This is SHAP, by the way, like people who know, right? And SHAP gives you a state of the model, right? And SHAP was coming out, still developing at that time, kind of. Actually, this idea came from a philosophy book of Parmenides, which I was reading at 3 a.m. in the night. And that is one of the points I want to tell the people, that AI solutions don't lie in AI books. Okay, I got the idea from Parmenides' philosophy, and there was a line that which is not cannot be, right? Which means basically if something does not exist, that is a unique state. You cannot think of it. And that is similar concept in Vedic philosophy also, that when you do dhyan, it is actually not presence of something, it is actually absence of everything else. So that is a singularity. So zero state, absence of anything is a singularity. So that was something that comes from philosophy. And then we use that here, so that if we don't have a crack, right? If you are able to create a good background in SHAP, you actually have the model looking for something and not finding it. So it is like similar to someone saying, look there, and you are not able to look at that thing, right? And you just keep on shifting your eyes, not able to lock on to that thing, right? And we use that. We use that idea that if there is absence of something, that is a singularity. And the entropy, we came out with our own unique value, which we call as XCV right now. So what that does is, it is highest when there is absence of any feature. This Google has not done, Meta did not do, right? And they have like billions of images. And we did this with around 10,000 images. So what we do is we not only listen to what the model has said, right? And model can go wrong sometimes. Despite being trained, you can do as much as you want. But we don't rely on the model output anymore. We also look at what is the XCV value, which is kind of an entropy value. And it is very high if the cell is okay. So we have 100% accuracy if the cell is okay. So that means if I say that some cell is okay and it can fly, that will never be wrong, right? And that was what was required. So we came out with this. It solved a lot of problems. And I put this just to show that the path was very difficult, right? It was not great and smooth. And it also solved all the problems that we have. Model reliability enhanced. Also, one amazing thing that we have done is, when you train a model, generally you don't know how well it is trained, right? You have certain parameters, overtraining, overfitting, and knee curve and all that, but still it is not great. So let me show you. This is the outcome of that concept. When you start with the model and it is not trained, both the classes are mixed. You can see the normal and fractured, or and as you train, they kind of get separated. And as you train further, the kind of class distinction is very high. And you also know what is the threshold. This again, nobody has developed. Meta, Google, nobody so far. So with this concept, you are sure what is the threshold value for you and whether you should train your model further or not. Very explainable, very visual, very simple. So it can be used in a lot of areas. I have less time, so I'll just skip forward. We are using it, by the way, medical. We have tested over X-ray images, and it's working great there also. Second thing. Let me tell you a bit about the story. We have 57 satellites orbiting us right now, and there are people who monitor the satellite telemetry coming day in, day out. It's like round the clock over the years. So we thought of automating it. Again, it's very difficult. There's so much data coming in. There are so many things involved, right? And a satellite may have around 15,000 to 20,000 sensors. So it's very difficult. And the task given to us was forecast anomalies early. And you can't just send a wrong signal to ISRO scientists at 2 a.m. in the night, saying that, sir, it was a false alarm, right? So you have to be very, very accurate. We have to be very, very accurate. When we say something is about to go off, then we pray that, okay, this should go off, right? Otherwise, I'm going to have a very hard next day, right? But anyway, cutting the long story short, we came out with something called as Mlds architecture. So in this, we worked with IIT Kanpur. Now, already, and I think this was one of the very significant advancement for us, was we were able to detect 20 to 30 timestamps in advance. Our timestamp is around 1/16th of a second. So it's not great, like 2-3 minutes earlier, but still it is our anomaly predictor gives anomalies before any expert can. So the expert actually gives where is the red line, right? And Mlds has given at the orange line. So we have beaten the human expert who is sitting there and analyzing in real time, right? So this can save thousands of crores, because if you are able to save one satellite, you can save 500 crores. Yeah, so this was Mlds. This was, again, developed with IIT Kanpur. It has a lot of applications. You can just go around and, it can be used in a lot of places. And what we do here is actually, we see whether the predictions are consistent, which means if somebody tells you a story about investment, right, that you're going to get this much money, and next year he's telling you some other story, and next year he's telling you some other story, probably you'll not trust that guy, right? So kind of that logic we have used here, where if there is predictions are not consistent, we set up an alert, and it has worked so far. So this is something else we did. It has huge potential, again, in Gaganyaan, in healthcare, a lot of manufacturing, anticipatory management. So this is, again, something that was developed by us. This was something in 2023, by the way. So very early. We developed agents were still not in vogue at that time, and we developed something called GYAN. And the logo is the best we could do in design, right? So we are not great at designing these kind of logos. So this is something that we are using in ISRO, which is very essential because we cannot ping data outside, and ISRO has a lot of particular lexicon. We operate with a particular language. Our data is confidential. So we needed something like this, and people are using it, and kind of it is getting better with time. And this was picked up by Bihar government. When they saw GYAN, they wanted something like this for Bihar students, and then we are doing a project in 27,000 schools, I guess, in Bihar with the same GYAN modified for education. So that was very exciting, doing something at the national level. Yeah, again, this is something that we have recently done, and Professor Orayo is a great person, particularly in terms of AI evaluation. He evaluated ChatGPT-4, and he was at ISRO, and we interacted with him. Yeah, so I don't want to go into details, and this is still not complete work. We are still developing, but I request people who are interested, AI evaluation is going to be a very big sector. Because you can put AI, but you should have clear metrics of how to evaluate AI. And for that, you need to have new measurements, which are not in any book or not in any Python libraries yet. So I think we need to start doing this. So we have just started. We don't wait for everybody to develop. And this is our evaluation on generality and capability. So these are two measures for intelligence, measuring intelligence. And GPT-4 is straight up and other things so this is 6 months old, by the way. These tests are 6 months old. But we are developing our own metrics even for this. So yeah, message that all these things that we have done, by the way, this is all done by 2 people. And the other one is younger than me. So basically, it's really difficult to innovate, right? So you have to get into a difficult situation. If you're at work and if you're in comfortable position, everything is going great, probably you're not going to innovate anything. It should be hard, somewhere that you have to break your head. This is my experience, maybe wrong. One thing I realized is all models are wrong, but some are useful. So you have to start with the negative thought. People say, be very positive. I'm saying, be negative. Start with the thought, everything is useless. But some things might be more useful than others, right? Like Animal Farm. So those who have read might get the reference. So all models are wrong. Don't start with great expectation, but try to do something useful, is what I felt. And when you do something useful, you have actually done tech innovation. And then this guy, which may be the developer guy, is not required anymore. So if you don't have a good manager, my idea is to become one, right, yourself. Because next is you need someone who can take that useful thing and make it a valuable thing, which is different than being useful. This is what I felt. Because I have great seniors who supported me and understood the value of that. And they used it in a way where it was valuable for the organization, not only useful. So this leads to economic disruption also. DeepSeek. By the way, I have a joke on DeepSeek, but my time is up. So anyway, let me just share it. Do you not find it funny that they named it DeepSeek? Being a Chinese company. Why did they name it DeepSeek? I will tell you, my theory is probably they were going for Seek Deep. But it sounded very Indian, like Kuldeep or Mandeep. But I think this is very relevant, right? China has done something useful, and they have come out with a model which is economically disruptive, and they have everybody's eyeballs right now, right? So this step is very important, and this step is just, the next social change, which means your manager, if you're not a good person, if not an up-to-date person, right, which is very high probability in India, right? So I'm lethal, by the way, when I speak. So he will change after the economic disruption has happened, and your company will already have lost a lot of early mover advantage, right? So if you look at the development, Steve Jobs was an engineer, right? A lot of engineers, when they become managers, they are very good at that. So basically, I'm motivating everybody here to come to the second step, because I'm sure most of you are at the first step, right? And this will follow, because society generally follows economics. When you study sociology, you realize it is a study about what are the different forces on the person and what he cannot do, basically, right? So this is Bertrand Russell, my favorite philosopher, and there are some other people, right? So the secret of change is to focus all your energy, not to fighting the old, but building onto the something new. I think that is pretty straightforward. Yeah. So we are already trying to build some great Indian AI, which I cannot say today what we are actually building, but maybe in a couple of months you'll hear the news. And I would love to collaborate with anyone, talk to anyone who is interested in that. We are trying to tie up with industries. We are trying to have young people interact with us. Okay. So thank you all for listening, and I hope it was worth the time. Thank you so much.
Getting thrown out to having a full packed house here. Interesting to throw some questions at him. We are running out of time. We'll keep the questions outside. also presenting a complex topic in a fun way. I think it was, particularly after the lunch session, it was more engaging. Thank you. This group mein aaya tha, can we take questions? Kindly settle down, please. We'll have the next session soon. All right, next up, we have a research paper that explores AI twins, lifelike digital avatars, enabling real-time interactions through advanced AI driven by speech synthesis, expressions, and contextual understanding. It compares two implementations, a closed-source system utilizing tools like Synthesia and 11 Lab for high-quality video and audio, and an open-source alternative with NVIDIA Riva and Nematron LLM and others. Our speakers, Shivojit Hure, Senior AI Engineer at EXL, and Tarun Kumar Mishra, GenAI Product Manager at EXL. They have their expertise in GenAI, LLMs, NLP, and computer vision. Please put your hands together for Shivojit and Tarun.
Hello. Hello, am I audible? A very warm good afternoon, everyone. So, I would just say, can you imagine a sibling, not an identical twin, but someone who understands you, thinks like you, and can even work for you when it's required? So, this is not the sibling from the same mother, but it is from our technological mother, you can say, and that's artificial intelligence. And this twin won't be just a reflection, but an adaptive counterpart designed to complement and enhance our capabilities. So today, me and my colleague Subhajit would walk you through how AI Twin is going to act as a catalyst in shaping the industries, driving the innovation, and in a way you can say it will be a digital twin which will be perpetually evolving and will always be there when you need it. So in today's agenda, I'll walk you through the basic or the introduction of AI Twin and some of the key features of AI twin that we have tried to design. And then it will be followed by an intriguing video of our CEO, Rohit Kapoor, interacting with his own digital replica. Then I'll hand it over to Suvajit to walk you through the technical nitties and gritties of the solution and what holds in future for that. So AI twin, what's the essence? So the essence is it's just a digital entity which not only mirrors your thought processes, but also optimizes your decision making and can autonomously work for you in the complex situation. So today, whether it's customer service or finance or insurance sector, this AI twin will act something which will disrupt the industry. And this will bring closer how do we see machines and the human interaction. Now, if you talk about this AI twin, there are three things which makes it unique. One thing is the contextual understanding. So if you want to have tailored responses based on particular scenarios and the personas, so that's what it can do for you. Second is the autonomous decision making. So if you have something or an agent which can have this capability of independently making rational decisions without any human intervention, that will be cool, isn't that? Then we have the lifelong journey. So we have this continuous adaptation, and also it will gain knowledge from the experiences that we'll have going forward. And that will make it unique and also more robust, reliable, and resilient. If we talk about the notable features of this, we can broadly categorize into 4 different things. One is the autonomy, that you can see it's self-learning and self-optimizing through the loops. Second, it will have real-time analytics, and also it can predict whatever you want it to. Third is the memory augmentation. And I think this is one of the key features that will help this to deliver great things. Because currently what we face issue is the storage or the context for a particular agent. Now with this storage and adaptive knowledge that we will have, this will enhance the decision making. And lastly is the interactivity. So this can seamlessly collaborate with humans as well as any AI machines. So this will be a great differentiator for this AI twin. Now, before I hand it over to Suvajit to walk you through the technicalities of this solution, what we have built, this is our CEO, Rohit Kapoor, interacting with his own digital twin. He's attending the senior offsite leadership in Bahamas, and the digital twin is interacting with him sitting somewhere in the office. So I'd like to play this video for you, and then I'll hand it over to Suvajit to take you through the technical functionalities.
EC. The management team at EXL is truly exceptional. Each member brings unique strengths and experiences that contribute to our overall success. Vivek Jetli, with his strategic intellect, drives our vision forward. Vikas Pala excels in execution, ensuring we deliver on our commitments. Anita Mahan is pivotal in crafting innovative strategies, particularly in healthcare. Keeny's dedication to our mission is evident in everything we do. Andy consistently brings fresh ideas to the table, while Vishal's enthusiasm inspires the entire team. Maurizio infuses energy into our operations, and Ajay's acumen keeps us sharp in the market. Baljinder's innovative spirit pushes us to explore new frontiers, and Pam's wisdom guides us through complex challenges. Together, this team is unstoppable. I am incredibly proud of each one of them. Together, we have made bold choices and outpaced the industry always.
Wonderful. I'm proud of this team too. Okay, what should I tell Baljinder Singh? Because he always gives me a tough time and he keeps asking for more and more investments.
Baljinder's innovation is crucial for our growth, but it's important to balance investments with expected returns. You might want to have an open conversation with him about the strategic priorities and how we can align our investments with our overall.
So hi everyone, hope you enjoyed the demo of the live AI twin of Rohit Kapoor. As you can see, this is completely real time and it interacts. So how did we achieve this? So let me introduce myself. I'm Shubhajit, Senior AI Engineer at EXL, who is the primary developer of this AI twin. How did we do this? Let's look at the workflow. So the main goal of this is that the user, in this case Rohit, or me, or you, will talk to the camera we are going to be captured by the camera, the audio will be captured. The AI twin will understand it, they will process it, they will consult some knowledge base, and then respond back in the exact tone, voice, and with the exact knowledge that is required by the AI twin of Rohit Kapoor. So how did we do this? So the first step and the last step. The first step is the user will interact with the app and speak to the camera. And the last is the audio and the audio input and the video will be used to create a lip sync model. What happens in between to make this AI twin possible? So first of all, the audio needs to be extracted. It needs to be converted to text, and it has to be like, let's say I'm talking here on the stage, and if I was talking to the twin, it has to be my audio. It should not contain like things like surrounding audio if someone is speaking here. And then once it's converted into text, this needs to be passed on to a large language model, which will then process that information. It will understand it. It is prompt engineered in such a way or fine-tuned in some cases that it will understand and be able to respond it. And it should also contain the information that it will that it will query from a vector database and then respond back to the user as per the need, as per the query. So that's basically what's happening in short. First, the user will interact. The listener, which is constantly running, will detect and extract the speech in real time. This will be converted into text using speech-to-text models. There are several of them. We'll talk about the ones that we have used, and we have given options. Then there's an agentic framework that with the large language models that will utilize RAG to answer your query. This will then be converted back to speech, and the twin is going to speak. So in the video that you saw, the voice was cloned from Rohit Kapoor. It was not completely exact clone because we used a model which is faster so that it works in real time, but it was cloned. But you can also generate it without cloning the voice of that person. And then this audio and a pre-recorded video of the person who we are cloning is going to be passed to a lip sync model. We'll talk about which one. And this video is then going to be streamed to the user in real time, frame by frame. So that's basically how the workflow works. Now let's look at in detail how this works. So first, as I mentioned, the listener. It sounds very easy, like I'm talking, my audio is getting extracted and gets passed on. But there are some complications. Let's say I'm talking to the twin, and I ask it a question. I pause for 4 seconds, then I ask it something again. And for example, if the twin's latency is 2 seconds, it will start responding back to me in 2 seconds. But if I ask it another question after 4 seconds, it should stop, it should listen to me again, exactly what I'm saying, and then respond back to both of my questions. And this should happen in real time. It should constantly monitor, it should filter out the noise, and it should understand the English words coming from me. So, the one hand, the listener is continuously running, asynchronously, monitoring everything and removing, and then there's the extractor. So as the user speaks to the microphone, be it with gaps, without gaps, be it there is some background noise, the extractor will isolate only the English voice from it, and it will pass on to the next step that I mentioned in the workflow. This will go to the end. The AI twin will speak back to me, but there is one aspect of this listener which is, as I said, the listener is constantly running, which will immediately send a signal to the twin to stop talking if I interrupt. So I should be able to interrupt the twin, and then basically it will listen back to me. The entire text is then going to be sent to the LLM instead of the first or the second one, and it will then respond back. So that's basically how the first part of the workflow works here. Let's go to the next one. So the agentic framework. What are we doing here? So you might have heard about all the frameworks that are available right now, like LangGraph, then AutoGen and all. At the point of this, at the point when we developed this, we used a very simple framework of OpenAI Swarm. The goal is that whenever the user asks a question, if let's say instead of Rohit Kapoor's twin, this was, let's say, insurance agent, a customer support agent, handling insurance queries, which is one of the main markets that we are working in. Then the router of OpenAI Swarm should be able to route it to exactly the agent which will be able to answer that particular question. Let's say I'm asking about something like I want to raise a claim, or there's some issue, with my claim, or I want to know about the policies. These are all separate agents where it will be routed to, and it will understand that, and then it will respond back to the user. But before it responds back, it should also consult a vector database. It will do a similarity check in the vector database. It will get some information which it needs. For example, the video that I showed, we can share the slides. There's a link above that which contains like the full video. So the video that we showed was a snippet. If you see the full video, Rohit is asking about the financial data, the stock price of EXL and things like that. So for that, it needs to consult a vector database that gets updated after a certain frequency so that it can answer those questions instead of giving wrong responses. So the RAG aspect is also there. And then the curated response from the LLM is generated and then passed on to the text-to-audio model. The text-to-audio model will convert it into audio, either with voice cloning or without voice cloning, and go to the next step. In terms of RAG, what we have used a graph database Neo4j because based on specifically for this twin that we created for which contains information about EXL in general as well as financial data of the past 25 years. We have used the graph database because it based on our testing it was working much better compared to the other vector databases. So this is the next part of the main part of the twin, which is basically answering your questions. So at this point, we have our audio with or without voice cloning. That needs to be passed on the twin. What happens next? So basically, this audio, along with the video, as I mentioned, will be passed on to a model, lip sync model. We have used both open source as well as closed source options based on certain factors. We'll talk about soon about what are the pros and cons of each. When it comes to the open source model, we have used two options, Wave2Lip and SatTalker. So what these will do is, based on the audio, specifically the English audio, it is going to lip sync the pre-recorded video of the person. Let's say if I'm recording myself, I have a pre-recorded 10-second video of myself. I pass the audio generated in the previous step along with the video to Wave2Lip or SatTalker. It will lip sync and make it look like as if I am saying that. So the video is getting lip synced. The audio is already generated, which gets merged with the video, and this gets streamed frame by frame back to the user. And this happens all in real time, and the latency depends on like the hardware, and we'll also talk about that, like the difference in latency between the open source and closed source frameworks. So all in all, this is basically the gist of how it works. We'll talk about the closed source solution, which we also have. Now, when it comes to the open source solution versus the closed source that I'm going to talk right now, for open source solutions, we have to deploy it with a certain number of GPUs, and we have to handle the concurrency. There will be multiple people talking to the twin at the same time about different things. So the cost is relatively much higher. And to deploy it on our end because we're doing it at a small scale. Whereas when it comes to the closed source solutions, we do not have full control over the entire agentic framework, but it is much cheaper. So we have both options, and based on the business use case, we can choose which one we need to use. Talking about the closed source solutions, we have NVIDIA's ACE, we have Hagen, Synthesia, and Sibley. Synthesia is offline, while as the remaining three are live twins. The agentic framework is pretty much the same, except that we do not have full control over it. We are using it via 11 Labs. So 11 Labs has a conversational agent, which basically acts like an agentic framework along with the cloned voice. And together with this, we are then responding back to the user. We're connecting all of these together. We're doing the engineering for this closed source solutions, and we're building the twin with it. Talking about the engineering, the backend, we created the backend APIs with Fast API, the frontend with Next.js, and we deployed it on Google Cloud's App Engine, which is serverless. So it can keep running, and if we set the minimum instances as 0, if no one's using it, our practical cost is 0. But there will be a cold start. So depending on them, you can choose the minimum number of instances, 0, 1, 1. So that's basically the entire thing, open source versus closed source. Let's take a look at some of the metrics. We have the detailed metrics in the paper, but we'll look at some of the things. So we tested 10 twins, including the one with Rohit, one with EXL's financial data, and some more. We tested 20 different open source solutions, and we closed down on Wave2Lip and SatTalker for the AI twin. We tested 4 closed source solutions, and we have tested 500 minutes of AI twin, talking to different person in our company to test it before going live. So the closed source solution has a less than 1 second latency in most cases. Sometimes it can be slower, but generally less than 1 second. The open source solution depends entirely on what hardware we are using, like how many GPUs we are using. It will depend on that. Generally, if the RAG database that we are using is smaller. And if we are, if for web2lib, if we are using just web2lib instead of web2lib plus GAN, then the latency is generally less than 1 second. Topic adherence and perceptual rating. So how often does the twin talk about the topic and not stray away from the topic? So for example, if you see the original video through the link of Rohit Kapoor talking, it was mostly smooth, but there was one blooper in between where at one point he asked a question, and the twin responded back saying that I am Rohit Kapoor, CEO of EXL. So it did not respond exactly to that question at that point. But once he asked it again, it was able to answer it correctly. So sometimes that happens, and so we have measured the topic adherence, the perceptual rating of how realistic and accurate it seems to a person through manual metrics. And these are some of the RAG metrics which we calculated with the Ragas framework. So this is some of the metrics that we are showing here. Some more detail are there in the paper. Yeah. So let's talk about some of the business use cases that we are targeting next. So in customer service, we're looking at 24/7 virtual assistants. That's like the very first thing that comes to mind when it comes to AI twins. We can do that even without voice cloning. We can use NVIDIA's NVIDIA Riva for that, so it does not require voice cloning. And we have AI twins of customers to train support executives. So this is the exact opposite. So instead of just having customer support executives as twins, we can create twins of actual customers. So it will go through the customer data. When the LLM gets, the LLM will either get fine-tuned or prompt engineered based on the requirement. So, and the responses will be similar to how customers respond. Sometimes they'll be asking queries which are difficult to answer, sometimes not so much. And the AI twin will speak exactly like that. And this will help to train customer support executives who are new to the company to get trained on how to handle these queries. Then we have AI replica of celebrities for upselling during interaction. I think many of you have seen the ad of Shah Rukh Khan's ad, twin of him. So similarly, we can create that for, because generally people are more likely to buy something if their favorite celebrity is advertising it. And the cost of doing that with an AI twin is less than actually having to pay the celebrity to pay for their time. Instead, you can just pay a royalty for using their twin. So that's cheaper. Now coming to finance and banking. When it comes, we can create an AI twin of the top executives of the company to basically give the company performance announcements and how the company performed and all. We can create AI twins of financial experts, onboarding and KYC, lot of things that we can use. It's basically used anywhere where replacing the user in some form, not fully, is viable. Similarly, for retail and e-commerce, we can create virtual fashion models, AI avatars as personalized stylists, which can be both ways. It could be an actual person giving you instructions about how to style better, or it could be a twin of you where you could see yourself wearing a different suit with a different hairstyle and see how it works, how it looks. Then lastly, we come to insurance and healthcare. We already talked about insurance customer support. Then we can create AI avatars to guide customers for buying insurance and for guiding them through the claims process. So instead of going on your phone and dialing 1, 2, 3 and whatever options that come in, you can talk to a real life twin, which is more interactive, and customer experience will be better. As a result, customer will give better reviews of your company. And lastly, we can create AI twins of specialist doctors for training junior staff. Doing so like at a large scale where you can talk to a twin of a doctor as a patient is a little bit risky, but we can do the reverse where specialist doctors, twins are created which can be trained junior medical staff. And we can also create AI avatars of doctors for pre-consultation, not consultation, but pre-consultation. So that's about it. These are some of the business use cases, some of which we are targeting, some of which are possible. And with that, we come to the end of the slide, and let me just move to this one. So this is our team. We at EXL have developed this, me, Tarun, and Soumya and Viproshi. So with that, thank you, and yeah, that's.
Thank you, Subhajit. Thank you, Tarun. We open up for questions if you have any. Can you pass on the mic, please? Can somebody pass on the mic, please?
Yeah, so you mentioned about that agents being routed to different LLMs, right?
Yeah.
So I have a couple of questions there. So in your case, so on what basis those agents are being routed? And what all LLMs you taken into consideration on what basis actually?
Yeah, so when it comes to OpenAI Swarm, unlike LangGraph or Autogen, it is very straightforward and simple. If you have seen mixture of experts model in the past, where it basically has a router and it routes it to the right LLM or combination of LLMs. Similarly, OpenAI Swarm's agentic framework is pretty simple. The router is basically instructed. Let's say if I take the example of customer service for insurance, it is basically pre-instructed to understand the user query and determine what category it is. It will create a list of categories. So, for example, if the customer is asking that I want to file a claim for, let's say, for my motorbike, or let's say I want to file a claim for health insurance, then at the back end, we have two different agents, one specifically instructed and or fine-tuned for health insurance, one specifically instructed and prompt engineered and or fine-tuned for motorbike insurance. And the router is going to decide based on those instructions where it needs to go by categorizing it into that appropriate category. So that's basically how it works.
I had a question.
Hi, I have a question.
Yeah, okay, I'll go first. You mentioned the use of model wave to lip, but that's not commercially available. So how do you?
Right. So it's not commercially available, but we are in touch with the web to lip team to make it commercially available. So by default, like we cannot directly use it. We can directly do with SAT-Talker, which is why we have two options when it comes to open source for SAT-Talker. But for web to lip, we're in touch with the team to make it available. Yeah.
Cool. Thanks.
We'll take one more question
Hi,
here.
Please. Yeah. Hi. I guess you must have heard of OmniHuman
Yes.
from ByteDance, right? So compared to Web to Lip, how do you see OmniHuman?
So here, as you can see, this was happening live, right? So Web2Lip is like generally fast and with like decent amount of GPU power, it is able to run live, and we have modified it to make it frame by frame to interact with the user. I have not extensively used OmniGen, but based on what I saw, it requires extensive GPU power, and it would be difficult to make it live. The quality of the videos generated offline without live is quite good with OmniGen. It can do all those hand movements and everything, but to make it live is a little bit difficult. We would be exploring it like if it is possible with less GPU power. If it is possible with less GPU power, then we would be using it, because the idea is to balance between the cost behind having those lot of GPU power and how much we are actually getting back from the business. So based on that, we have chosen Web2Lip. And like if we talk about some other models, like let's say tomorrow some other model comes in and it turns out to be that the quality is good, but it requires less GPU power, we would be replacing it with that instantly. So we have it separately as a microservice like that. Yeah.
Hello.
We'll take one last question.
Hello. Actually, for like superimposing video on the like audio on the video, like have you used MoviePy because it's very slow? How have you?
Initially, I was testing MoviePy for both the input and the output, and it was quite slow, as you mentioned. So basically, for when it comes to superimposing, if you're talking about the twin, the end part of it, that is done automatically by Web2Lip model. So I do not need to separately do it. Yeah.
Okay, and one more small question, about the pose. Like, are you inducing some other machine learning model to induce the pose?
So when it comes to our open source model, it focuses only on the lip syncs, right? So it focuses, whereas when it comes to the closed source model with Hagen, it focuses also on the pose to some extent. It can do some of these hand movements and body movements. So yeah, that's all.
That's all.
Hello. Excuse me, just last one.
We'll have the question outside the
just
session.
one small thing. Yeah?
We'll just, yeah, okay, please go ahead.
See, sorry to interrupt. See, I am talking more from a user point of view, okay? I am basically an investor, and I worked for many years in Wall Street. So I am trying to use, okay? I'm trying to use AI for automating the whole, I mean, I use quantitative modeling and all, okay? So I'm trying to do this. Now, you are trying to do that, like your financial advice and all. See, the main problem is how are you able to control the hallucination? There are two things. One is, I mean, you are telling, like, let's say you give me a model, like I buy a product from you. How do I make sure, or how will you, because we are using stochastic data, right? They are all Brownian motion kind of thing. And in that kind of data, like to ensure that you get the right kind of, let's say, like I want to do some financial research, right? I have to be 100% sure that the accuracy or rather the prediction, right? Because a lot of times we are using prediction or mathematical expectation, those kind of thing. So how are you ensuring that what is the level of hallucination we are talking here? You understand?
Yeah, so there will always be some degree of hallucination. So if we talk about what we have currently developed till now, if I talk about specifically about the AI twin, which is trained on general EXL information and financial information, we have trained it on very specific data, and we have extensively tested it manually to see where it makes a mistake, where it's likely to hallucinate or give wrong numbers. So if I ask it about, let's say, the CAGR of the past 3 years or something like that, it will basically, where it gives the wrong number and all, we are specifically testing that thoroughly, step by step, to some extent manually. And then we are further improving the model. In some cases, we have by prompt engineering, it gets solved. In some cases, you can fine tune it further if needed, or you can modify modify the vector database from where it gets the information to make it slightly better. And we have given the prompt in such a way that if it is not sure of the answer, it is not going to answer. But there will always be some hallucination. But the goal is to reduce that as much as possible. And if it is not sure, or if the question is not that understandable, it will either not answer or ask the user back. So that's what we are doing.
Thank you, Sujit. Yeah. I hope this answers. I think there are a lot of people who have questions. I would request you to take it outside the hall. We have the next session which is lined up. Thank you. Thank you.
Should I open?
Yeah, you can hand it over there. There are two announcements. Pragati Chopde Johnson Controls. If you are here in this hall, there's a family member waiting for you at the reception. Kindly reach out. Thank you. There are activities starting at the Code Craze stall at 2:30. This is your chance to win some goodies. Don't forget to check out the stall in the lobby area. Thank you. Our next session explores how deep learning, particularly CNNs and advanced architecture, is transforming medical imaging. Drawing on research from IIT Hyderabad, it covers applications in detecting diseases through X-rays, MRIs, and CT scans, enhancing diagnostic accuracy. Our speaker, Priya Bhatia, is the lead data scientist at Turing. Recognized for her academic excellence and commitment to social impact, she was awarded the scholarship by the Reliance Foundation. She wears many hats. Priya runs a popular YouTube channel with her name, Priya Bhatia, where she creates accessible content on data science, algorithms, and career development. Plus, she is the founder of techforallwithpriya.com, an educational platform. Please put your hands together for Priya Bhatia.
Hello, hi everyone. A very good afternoon to all. I hope no one is feeling sleepy over here. I can understand after lunch, I can see that many people feel sleepy, huh? So let's start the session. But before deep diving into the today's agenda of deep learning in medical imaging, I just want to ask one question from everyone. And I really want everyone to respond over here. Let's try to make this session more interactive, okay? So just let me know how many of you used AI today? How many of you used AI today? That's my question. Very few people have raised the hand. Is it like that? So why I can just see 10% of the audience is just raising the hand. Can you just again raise the hand? How many of you just use AI today? Okay, can you just let me know, sir, where you have used today?
So one is Google Maps.
Okay. Okay, superb, superb. Perfect. And next question is, how many of you recently had a CT scan or MRI scan? Anyone? Recently? In the past few months? Maybe?
In the family.
In the family. Okay. So today what we will discuss over here, we will try to combine these two use cases together, and we will try to see that how AI is being used nowadays in medical imaging tasks. So let's get started. I really want everyone to observe these three images: input, automatic segmentation, and manual segmentation. Anyone who can give me a brief analysis what you have observed in these 3 images? Anyone who wants to raise their hand and speak up over here? Yeah, please go ahead. Okay, so that sir has analyzed that few green dots are missing over here. Any other observation? Okay, great. Great. Any other observation? Anyone? Okay. Can you just speak up again that last line?
I think automatic segmentation seems to be doing better than manual. If you look at the top right one, I think manual segmentation is showing a little bit bigger green color on the top, where the actual input is matching automatic segmentation more.
Okay, so that's the visual representation with which we have observed these things, right? Anyone is doctor in this room? No. Anyone? No. So we all are not doctors, right? I'm assuming we all are engineers, but still we can observe over here. See, this is the input, which is the, if you can observe over here, this is the lever area, and this green things which you are observing over here, it's kind of a tumor, okay? And the process of detecting this green cells over here is what we called as, any guesses? Yes, please. Segmentation. So this process is what we called as image segmentation. So if you will carefully observe over here, the kind of results which we are getting in the automatic segmentation, when we are saying automatic, it is done by our deep learning model, okay? Automating our task. Manual segmentation is something which is done by experts, radiologists, right? So if you can observe over here, the kind of results that we are getting is very, very close to each other, right? That's the power of deep learning models that we have, deep learning architectures that we have. And that's why nowadays you will observe in almost all the kind of diseases, the automatic segmentation plays a very important, significant role, right? So you can see over here the applications in disease detection, diagnosis, image segmentation, quantitative analysis with precise and objective measurement, and high operational throughput. I'll try to explain each and every point step by step, but I hope that this image gives you a better idea that what I'm trying to convey over here. Now, what are those deep learning architectures which really helps us to get that done, automatic segmentation? So we have convolutional neural networks, CNN-based architectures, which basically helps us for image classification and segmentation task. Followed by, we will be having this capsule networks called as SegCaps. I think CNNs are very famous. I hope everyone have heard convolutional neural network. Yes? How many of you have heard SegCaps? It's quite rare. Capsule networks. Only 1, 2, 3, 4, quite less, right? So today's task after this session definitely will be, because I have a limited time, to explore this SegCaps. It is also a very powerful architecture which basically helps us to do the image segmentation task, and this is as powerful as CNNs. And that was my research area when I was pursuing my master's in AI from IIT Hyderabad. So what we have figured it out that the performance that SegCaps have given to us, it's comparative as comparable to CNNs as well. I will showcase you the results as well at the later stage. And at the very end, we have hybrid models where we are trying to combine these CNNs and SegCaps. I just give you a brief insight over here. SegCaps are non-convolutional neural networks. So whatever operations we have in CNNs, that is not there in SegCaps. Actually, it performs dynamic routing-based algorithm. I can understand these words are black box for many people. That's why I'm not going in that much advance over here. But I just want to give you a brief idea that these are the known CNN-based models, and the above one definitely is a CNN-based model. So the very famous medical imaging segmentation model is UNet++ and UNet, which is basically used to perform a lot of segmentation-based tasks. So here are the case studies and applications, and I'm pretty sure that you must have observed these case studies nowadays. One is skin cancer detection. How these, whatever be the case studies we have, maybe skin cancer, brain tumor, automated lung inflammation quantification, which was my research area, all of the case studies, if you will observe in the medical imaging, works on similar workflow, which I'll demonstrate you just after this slide. But any idea, anyone, that how these detection, segmentation, quantification usually happens? What could be the life cycle? Anyone, any guesses? What's the first step? Let's talk about the first step. Do we have a label data? In the medical imaging sector, do we have a label data? When I'm saying label data, for example, let's say brain tumor detection is the case study we are focusing on currently. So if, let's say, I will be having an original annotation, with respect to that annotation, do I have a manual segmented annotation as well by the experts, by the doctors? We do have, right? So what we are doing over here is, we are trying to train the models on top of that. Now what the models are doing, when I'm saying models, models like UNet++, SegCaps, UNet. So what those models are doing, they are trying to observe the patterns, just like the way we as a human being learns, right? If I'll call some kid and explain to him or her that what is cat, so how will you explain? Anyone? So do you explain some points? Step 1, step 2, step 3, step 4. Then what's a good idea? Show them lot of images, right? Everyone agrees with me? Okay? So we will try to showcase them lot of images. Automatically that kid will analyze the patterns, and then obviously they will be able to demonstrate a decision that, hey, it's a cat. Same thing happens for a model as well. It's like training a model, meaning that we are trying to find the patterns, which basically helps us to understand that, hey, there is a tumor available in that specific testing data. Make sense? So if you will be able to observe over here, now these are the images of my research work, which I am showcasing you over here. So the task was, so let me just give you a brief insight what we were doing over here. So that was the time of COVID, where we were having the COVID-based data, and the people who were suffering from COVID, they have that ground glass and consolidation. Can you see this white area over here and over here? This is what we call as ground glass. And if that white area is quite heavy, it means that that person should have, admitted to the ICU. Means that person is very serious, right? So we need to demonstrate, we need to find that automated segmentation to be done, so that my model will be able to analyze that, hey, this is the ground glass available over here. That's the task. So how basically the pipeline will work, and the same pipeline will work for all the medical image-based data, by the way. You will be having an annotated inflammation mask. Inflammation means infected mask we will be having. Annotations means that it is done by the radiologist, okay? So we will always have that original mapping available over here, so that our model will learn the correct patterns. Once we do that, we'll try to do the shrinkage using the active contour. It's again a mathematical concept, which is basically tries to shrink the portion of this white area, so that we will be easily, or our model will be easily able to focus on that white area of glass door. After that, we will start our model training. Once the model training will be done, then we will come to the outcome. But here you can see, this is the original annotation, where you can see this is the area, which is the infected area. This is the segmented by the expert. When I'm saying expert, in this case, in the medical imaging, I'm always talking about the doctors, okay? So this is the area which is shown by the experts, that this is the infected area. And when we updated the shrunk mask by active contours, this is the area which we figured it out. So we did data pre-processing, and for model training, we have used this shrunk mask, not the original mask, because when you get the original images, they are quite huge. This portion is quite huge. You can see the infected portion. We need to shrunk it first, and then we have to train for the model training part. Now, what's next? So till so far, what we have covered up. Any original data we cannot pre-process directly. We need to do the pre-processing first, maybe via active contour. There are multiple algorithms for that, and we shrunk that. Once we do that, now there are the next steps where we have to find the region of interest, ROI. It's quite famous. I'll showcase you with picture. This is the CT scan we have. We have to focus on the region of interest to find the infected portion. So I'm focusing on this lung side, and this is my model which gives the result. This is the inflamed lung region, which we are calling it as glass orient consolidation. I hope it makes sense. So if you will be able to observe over here, what we are doing, we have an input CT scan. We are trying to generate the region of interest. On the other hand, we have the annotated inflamed mask. We are doing a pre-processing via, very good, shrunk active contour. And after that, we are doing inflammation segmentation. Here, we are applying the different algorithms that we will have discussed, the architectures. Finally, we are doing the quantification. I'll talk about this thing, how we are quantifying that inflamed region. Then we have some input clinical parameters, like the demographics of the patients. And finally, with the help of these two data points that we will be having, we are predicting that whether that patient requires the mechanical ventilation or not. The same case study you can apply for all the applications that we will be having in almost all the deep learning in medical imaging domain. So here you can see the quantification part. If you will be able to observe over here, when I'm saying quantification, the simple literal meaning is that we are trying to find the volume of this inflamed region divided by, obviously, the complete lung region volume, and that will help us to find the numeric number, which we called as all R's, full form is automated lesion to lung ratio. And with the help of this parameter, we will try to apply the machine learning model. You can apply any of the classification model over here. Maybe you can go with logistic regression, random forest, decision tree, whatever you feel is giving the better performance, better metric that basically helps us to analyze that whether we will have to basically ventilate that patient or not at the end of the day. By the way, all this analysis will be done with the help of the doctors. When I was pursuing my master's, and the data was taken from original patients from Jaipur hospital. So that was the whole idea about this specific case study. Now, if you have any sort of questions, you can ask. Thank you so much. I hope that it was insightful. Okay. So here, if you will be able to observe over here, there are multiple, by the way, CNN models we have. It's not alone. But every kind of CNN model works on the same case study or case theory. Well, how is that? Basically, it will try to apply the filters. Now, we do have different kind of filters depending upon what pattern you want to detect. And on top of the input layer, so when we are saying images, whether it is of MRI scan, CT scan, when we insert those images, internally, those images will be treated like a pixel. So when you say 256 cross 256, there's a pixel tabular format. On top of this, filter will be overlapped, mathematical computation will happen, and it will try to give you a final result, which includes, again, a pixel matrix, which will be able to see the patterns available in the given data. And that's how you will be able to get that
what is the window size?
Segmentation.
That window size, you adopted 2 by 2
okay.
or 5
So
by 5?
when we are dealing with the image-based data, it's a 3D-based data, okay? 3D means we are dealing with the 3 layers. Now, the problem or the issue with when we are talking about these medical image-based data, I was talking about this fact initially as well. What do you think are the problems when we're talking about the domain of medical imaging?
RGB is the problem. First, you are handling grayscale image, then you are extending to RGB, or how you handle here in this?
No, it's a grayscale.
Grayscale only.
Grayscale image. Now, what was the problem? What were the challenges? It's not easy like the way I have talked about. There were a lot of challenges, and even if there is someone who is working in the medical image-based data, they can understand. The very first issue when we are working with this domain, as mentioned by her, the label data is very, very less. And even doctors doesn't have the time to label it or to mark it, right? Radiologist doesn't have the time, but nowadays, because this AI-specific domain is quite booming, so obviously people are spending lot of time, lot of effort, lot of money doing the research about this specific domain. But still today, label data is something which still is not there. Second issue, anyone? Label data is an issue, that's correct.
Another one is a privacy concepts.
Very good. So, privacy concerns. Do you think that you will be easily able to access the patient's data? Today, if I really want to access any patient's data, so will the hospital's people will give me? Is that ethical? No. You need doctors to collaborate with them, and that is how you will be able to get the data set. Yes, we will be having open source data available on Kaggle, UCI repositories, but if you want to deal with the real-time data, obviously the results which you will be able to capture after training the model, whether your model is working fine or not, you have to work with the original data, which is the real-time data. Otherwise, how will you get the performance done? Right. I hope it makes sense. So this is the second important thing, which is quite difficult and challenging for people like us. Any other thing?
But for the privacy part that you talked about, if you don't give the patient details and just get the images, you don't really care about person's name, age, or whatever, right?
Exactly.
You only care about the images.
Exactly.
What is the harm in giving the data? I mean, if the patient's this thing is not.
What is the end goal?
I want to interfere, madam, legally
Yeah,
here.
please go ahead.
Because that DPDP or GDPR, whatever this says, privacy concerns about individual concern.
Yes.
So if ultimately anybody can prove that those images are belongs to X.
Exactly.
Without by masking X also, you can use it. Later onwards, X can raise a claim that
Exactly.
my images are used for commercial purpose and they have gained without my consent.
That is the one thing. And second thing is, you always have to understand our end goal is not just to segment the images. Our end goal was to check that whether this patient actually requires ventilation or not. Without being human intervention, I don't want radiologists to see that images. Also, there's a lot of work going on the interpretability part. We are not really sure till so far that whatever be the model results going on, is that very much apt? Doctor's replacement is, I don't think it will ever happen, but that will, with the help of these specific AI-based tools, obviously the time reduction will happen. And that is where this specific domain plays a very important role. Even the same thing happens for us as engineers. People usually get afraid that whether we will lose jobs because now GPT is there. There are a lot of LLM-based platforms are there, DeepSeek now coming up. What will happen about our jobs? All these platforms are basically for helping us. It's just that we should be aware that how can we use these platforms to help our task in a quite shorter manner, right? That's the whole idea. And yes, please go ahead.
One question, I mean, I know we talked about the label data, and I wanted to understand what's the kind of a label data that we are looking at to be able to train a similar kind of a model, number one. Number two, what are some of the latest industry trends which are there to be able to achieve the similar amount of accuracy with a lesser amount of computer vision data, label data?
So talking about your first question, when we are talking about label data, it means that one thing we will be having the original CT scans where this green mark will not be there. That is the meaning of original CT scans. Corresponding to every original CT scan, we will be having the segmented by expert. This is the segmentation result.
That's clear. All my question is how many number of such images you had to use?
It really depends. For me, it was about 1,000 of images, and we have trained on top of that. The only reason was, at my point of time when I was working is, I don't have that much label data available. That's what we have talked about few minutes back. When we're talking about the number of images, the more images you will be having, usually it is better until or unless your model is not overfitted. Then there are techniques to detect that as well, that whether our model is being overfitted or not. But definitely, this label data is something as much as you can collect in the initial part of your process in your case study, that would be a better idea. I hope it answers your question.
And any industry.
Madam, what are your false positive and false negative metrics for this your thesis? How much you have achieved?
Okay. So when we're talking about this medical imaging domain, there are two metrics that we usually work with. One is called as DICE score. Another one is called as IOU. You can maybe research later on. DICE score, DICE SCORE. Basically, when we're talking about this image segmentation based task, it usually tries to see that how much is the overlapping with respect to the segmented images in the segmented by expert part versus the automated segmentation part. It will try to see that how much is the intersection between these two images, and then it will give the result. By the way, my research paper was published at EMBC conference at IEEE. So at any point of time, you can Google it. This same name, automated lung inflammation, and IEEE Priya Bhatia, you will be able to get all the details, and you can download the research paper as well to see final metrics as well. I hope it answers all your questions. Thank you so much for your time and effort. Thanks a lot.
As announced earlier, there are some activities outside in the Code Craze stall. It's starting now. If you want to attend, kindly attend the session. There are some interesting goodies waiting for you. Yeah, please, thank you. We'll start the next session in another 5 minutes. Kindly settle down. We'll start the next session soon. All right, our next session is about AI agents, the biggest buzzword in the enterprise segment today. Our speakers will explore the concept of agents, delving into what they are and their potential application. Participants will learn about the agentic workflow, design patterns, complemented by real-world business solutions, case studies, and demonstrate their practical impact and value. Siddhant Goswami is an AI engineer turned entrepreneur with over a decade of experience in building innovative software products. He has trained 30,000 professionals across industries while leading India's largest Gen AI and entrepreneurship program. He has 2 successful exits to Unacademy, Scenes and TapChief, and built AI product used by over 1 million global users. He is also one of the global instructors to have partnered with Meta Global Team and on an international course called LLM for Developers. Let's hear more from Siddhant himself. Thank you. Welcome.
Can you guys hear me? Awesome, thanks. So today's topic about intro to AI agents, and first I'll give you some agenda, what we're gonna discuss, and then I'll discuss my own journey. Like I've been building AI agents from last 2 years now, and what are the things which I learned, and I compiled them, few insights. Also learned from Anthropic team. I had a call with them, and they also had a very interesting article about building effective AI agents. So some of that is also inspired from that, and in general experience of building agents. So this is me. I've been building products from last 6 years now. Had 3 products which scaled to 10 million plus. Last 2 years, 2 years back, started a training program called 100x Engineers. We have taught more than 30,000 students across different industries into Gen AI LLMs. Had 2 exits to an academy, and I'm recently putting a lot of things on my Twitter. So if you guys want to just stay up to date about AI agents, whatever I'm doing and putting out as a research, so you can maybe give it a follow. Yeah, I'll come this side. So this will be the agenda of what I have for today's session. What are the agents, when and when not to use agents, what are the frameworks, and how can we use, when to actually not use frameworks and when to go directly with building your agents from scratch, core building blocks, agents in practice. We have a couple of folks from our community who have built products as well as agentic applications and deployed on production. So some insights from there, and then the summaries and key takeaways. Why am I talking about the AI agents is because this is how I started my journey. I think almost 2 years back, May 14, 2023. This was the experiment we did with Varun Maya. This was the first research paper I basically worked on. It was based on Simulacra of human behaviors, which was one of the Stanford research. Was trying to understand if we put GPT, different GPT agents into one environment and we give them a goal or basically a task, can they perform some activities and can they simulate the human behavior or not? So this was a very interesting thesis which we explored initially, and we built one of the you can say an experiment on top of it. We trained 3 AI agents: Elon Musk, Steve Jobs, and Jeff Bezos, and we basically put them into one room. So this was kind of simulating a podcast between these 3 AI personalities and all the conversations which you hear. Can you play the video? Okay. So we have video for this.
Look who decided to show up. The king of closed ecosystems and rigid design. How's the fruit company doing these days, Steve?
It's doing just fine, Elon, and I see you're still trying to conquer the world one tunnel at a time.
Gentlemen, let's focus on the topic at hand, the impact of artificial intelligence on jobs. Artificial intelligence has the potential to automate many jobs, but it also has the potential to create new jobs and industries that we can't even imagine yet.
That's all fine and dandy. But let's be real here. Artificial intelligence is going to render a significant portion of the workforce obsolete.
I disagree, Elon. It's true that some jobs will become obsolete, but as technology advances, new jobs will emerge. And it's up to us to make sure that people have the skills to fill those jobs.
Artificial intelligence will require a different skill set, and we need to make sure that people are equipped with those skills.
Yeah, because it's that easy. Just snap your fingers and suddenly everyone is an artificial intelligence expert.
You'll never change, Elon. But in all seriousness, this is an important issue, and I'm glad we're having this discussion.
But seriously, I do believe that artificial intelligence can be a force for good if we proceed with caution and responsibility. After all, I'm not trying to create Skynet here.
No, you're just trying to get us all to Mars.
Artificial intelligence.
Cool. So the point was 4,000 tokens, so memory and the long-term memory for that. So all of this was like when there was actually no tooling around agents. And if you compare this with today, like there are tools with like Notebook LM and Character.ai, what they have done. So I think that is like one of the great, I would say like the innovation in the last 2 years and how far we have come in this industry. But this is how I personally started my journey, like worked on this project, realized, okay, there's a huge potential, like we can apply this to different business use case. And after that, I also like built a couple of products, shipped it to production because like research is good, but once you, without actually putting things in out production, you never get the feedback, right? And whether like actually you're building something useful for the world or not. So we did a couple of experiments. So this is where I was like teamed up with Varun. So we built first God in a Box, which is a very simple chat GPT wrapper. Like we put GPT inside the WhatsApp. So exactly like 2 years back. Crossed I think more than 1 million users across the world. And we were very surprised by looking at the initial use cases because people were just like typing everything into this prompt. And this was like, I think even way before when the agent was a term in the industry. And a lot of people used to consider God in a Box as an agent, right? Because like for them it was like, I can talk to this person and it can basically give me a response. Some people are actually talking to God in a Box as a therapist, and they basically had like all those kind of conversation. So we got like some interesting insights from that. Second experiment I built is the AutoCode Pro, which was a very early version. I think you can compare this with a Devin, but not very close to what Devin is doing right now. So we used to basically build a lot of these softwares over the weekend. So that was our timeline. Okay, if we have an idea, we have to ship in like 2 days. How can we improve our process? So we like trained and fine-tuned a large language model to basically build a very simple Chrome extension. And then we realized, okay, if we now write down any particular task, say I need to build a second brain using LLMs and RAG technique. So it will basically go and like write the JavaScript, put it into Chrome extension, and like actually give you a plugin which you can just push it to the Chrome. And so those were the initial things we did. And then we also built something called Alpha CTR, which was to solve the problem of content creators. As I'm not sure like how many of you are aware of that, when you put a video on the YouTube, the main, or you can say one of the very important part is the thumbnail, because that drives your CTR, the click-through rate. If your thumbnail is great, your videos will perform better because more people will click on this. So we thought, okay, how can we train AI that how to design like better performing thumbnails? So we took our own thumbnails, which has performed very well across different channels. So we fine-tuned this particular stable diffusion model across all the best performing thumbnails in our category, and then we said, okay, let's see how the AI is performing. So surprisingly, it performed very well. We got like very good results. Like even today, like we use a lot of these internal AI tools to actually like put up thumbnails on our videos, and surprisingly, all of these things were happening inside just I think one house. So we used to call that a hacker house. So we were just a bunch of engineers who were just figuring things out and was like playing around the technology. But we realized that the impact is like way huge than what we initially expected. All the products combined got like over 1 million users. We generated a couple of 100,000s of revenues through this, and all of this was just an experiment. And also like a lot of companies started reaching out to us, like Times of India reached out to us after looking at Alpha CTR. They said, if you can do this with your videos, can you do the same thing with our marketing campaigns? Because we also measure CTR. So we did like one project with them. So the entire thing like spanned into a AI agency. Like so Varun started the AI agency called AOS Labs, and I on the other hand like started 100x. This was the next thing which I thought, because I was like, yes, there is a huge demand in all the agents in like Gen AI space, but there's very less quality content out there, which maybe like if somebody like me back then when I was like learning everything, I was coming from a software developer background, not from the ML background. So for me, like to actually catch up with everything, I had to go and read a lot of research paper, like listen to a lot of talks, and then like maybe like figure out if this is working or not. So I thought like let's start from there. We start putting some content, some tutorials initially. So these are some of the things. The one video which you're seeing there, that's basically the implementation of chat dev, which was a very similar research paper that built AI agents for enterprises. So it was like a entire AI company where you have an AI CTO, AI CEO, AI product managers, and then this entire team of like AI agents are working together to basically solve a task or basically build a product. We also like did something interesting with Meta. So we wanted to like create more free education. We do like paid courses as well, but this was like completely free of cost. So we designed 2 curriculum for Meta Global. This is generative AI for marketers and LM for developers. Both of them are going to be completely free. And I think the first one is already live on the Meta Blueprint portal. We also hosted one of the India's biggest AI buildathon with partnered with OpenAI, Nexus Ventures. So the idea was because now we started like from a very small page or maybe like a small team. Right now, like I think we have like the combined community of more than 1.5 million people following us. So we thought, okay, there's a lot of people who have potential to build things out, and maybe like we can help them to provide a distribution platform. So this is how it started. There's like 1,500 people across the India built like some interesting stuff, and maybe like shared some of the insights from that as well. But yeah. Now coming back to the topic, and before introducing you the definition of AI agent, because most of the time what happens, like I can put a definition here right now and maybe tell you, okay, this is what is called AI agent, but I don't think like I can agree upon like a one single definition, because from the last 2 years since I've been building agents, every single year, every single quarter, the definition has evolved. Like what we used to, like for example, I gave you God in a box. Like a lot of people used to think that that was an AI agent, but now like it's just an LLM wrapper. So it just, I think the perspective is changing, and the entire industry is evolving like at a very rapid pace. So it's very hard to give a one single definition of what is an AI agent. So what I'm trying to explain through this slide is just give you a perspective of how things have evolved in the last couple of 2 years, and then like where things are stand today, and what can we consider an AI agent, and how can we build something on top of it. So this is the phase 1, the very beginning of large language model, and this is something which we had when ChatGPT just released their APIs. This was like back in December 2022. We had a text input, we had a large language model. It basically gives some text output. This was like very simple GPT model. In the phase 2, we saw something interesting where we saw LLMs with larger context windows. Now what does that mean is that now instead of like sending one single prompt or maybe like a couple of lines of prompt, you can like put the entire book. Anthropic was one of the first one, released 100,000 token windows, context windows. So what we saw like as a second order effect of this is now people have started using their company database. Maybe like I can upload my entire book and I can talk to it. I can upload my, so I used to like document a lot of things about myself. I do note taking a lot. So I uploaded my entire Notion doc to this AI agent, or actually the Anthropic's custom LLM, and then it basically started like answering all the things based on that. So that was like a first phase where I saw, okay, there is a rise in building something like an agentic workflow. Second biggest, I feel this is one of the biggest inflection point in terms of the agent and LLM evolution, is where we had tool use capabilities, which also allowed us to build something like retrieval augmented generation. Now these are the two jargons. I'll try to simplify those terms. So RAG is one of the very famous technique, which basically like helps LLM to access the external content, right? For example, like if I have all the database about my company, how can I give this to LLM so that LLM can answer, you can say, questions about like my particular journey or what 100x is doing. So we basically like we had this ability where you can like upload the documents, convert it into something called vector embeddings, which is now understood by LLMs. So you are not limited to just exactly what LLM knows. You can extend the knowledge base and basically like give more and more context to it. The second part here is the tool use, which is kind of giving, I like to understand this from this perspective, is like kind of giving LLMs hands and legs so that it can operate the external tools and external APIs. One of the very early experiment which I did is I just gave access LLM to my chat inbox, and also my Gmail. So what it used to do is to scan all the important emails based on my list, and it used to just notify me, okay, whenever I receive somebody, say if MLDS is like doing an event, okay, this is something important. Maybe you have attended the last event, and these are the summary, and if you want to do like that. So it was basically like kind of yeah, like giving LLMs like hands and legs. So these were the two major, you can say, inflection point in the evolution phase. And the fourth phase, which was basically quite recent, it's like multimodal workflow. Last year we saw like a huge rise in multimodal, where now LLMs can hear, they can speak, they can talk to you, and they can also like yeah, you can share your video. I'm not sure how many of you use Gemini AI Studio. Like you can just like share the entire screen and basically like understand everything. So all of these capabilities now has evolved the LLM, which is like way beyond than what we had in the initial phase, right? Which was this one. So one thing which I also want you to observe here is like the evolution has happened as something like we are kind of creating a being, right? And this is like what some people like to call AGI, right? Like initially it can just read and write text, then like it has some you can say extended memory, so now it can like use context windows, and now after that it has hands and legs, which has evolved, and after that like it can now have all the senses. It can like hear, listen, and it can basically talk back. So what we are trying to do, or basically trying to understand through, is like how like a baby has basically, you can say, like grown up from like a very early stage. And I think now we are sitting at phase number 5. I feel this is the current AI agent space, or the architecture, which you can maybe like say, where like we have an LLM layer in the middle, and this LLM can interact with the real world. It can basically like talk to your emails, interact with your softwares. It has memory layer. It can remember things about you. It can remember like the short-term things. So we have both short-term, long-term memory now. We have episodic memories as well, like which means like it can like exactly you can say remember a particular episode or the event in that part, and then you can extend this further with the help of retrieval augmented generation. You can add things on the vector database, and yeah, so these are the couple of components which now we have, and this is what I like to call as a, you can say, current state of the AI agent. Now what makes an agent, because that diagram looks a little bit scary, so I thought, okay, I'll just like write a couple of lines there. I would like to like again simplify things. If you give LLMs some tools which are capabilities to interact with real world, and also this is called perception. I've written down environment feedback, which is like how can it like understand from its environment. If you are connecting this with your email, can it actually understand what's the goal you are trying to set? If the goal is to actually maybe see all the new events coming in, can it actually like use the data and interact with the tools and basically like take the environment feedback? And finally, like this optional part, the human checkpoints. Most people call this right now human in the loop process, because I feel like right now we are not there yet, and this is like a very similar analogy as compared to what self-driving was like, I think from like 10 years before today, where like we had initially drive assistant, which means like you can put your car on the autopilot mode, but you still need to be like aware, okay, and you need to still you can say take the control back in your hand whenever you see there's a potential situation where you might need to say put some extra protection. So this is exactly what the stage of LLMs and AI agents are. Like we can't like completely rely autonomously on them, so we do need some human feedback. And these are self-directed. They can plan, they can execute multiple steps based on the feedbacks and the goal update. So that's more like a simple way of how you can define agents. This is a simple diagram. I thought like maybe I'll compress the previous ones because there's a lot of things which I spoke about. This is where the LLM is right now, where it has all the capabilities, where it can listen, hear, speak, and it basically has a memory and everything. But what is the difference between an LLM application versus an agentic application is that the agentic application today can interact with the environment, can take some action, get some feedback back, and take the human also in the loop. So it's like a very simple way of like understanding about how you can like design a particular agentic application. When and when not to use agents, because this is a common concern, right? Whenever I teach about agents, every single person has this idea, okay, I have like 5 different things which I can automate today, and I can use agents. And then I tell them, no, you can't do that, because this technology is in very early stage today, although like it looks very fancy and everybody wants to use it. But I've been like trying to build and like ship a lot of things in production, what happens is that everybody talks about like some fancy demos, and I've seen that on YouTube and basically across the social media, and all of them looks good. But the problem is like the moment you put everything in production, you see there's like so many problems. You don't have the entire control on how agent behaves, like what kind of action it takes, and where it exactly hallucinates. Also, these machines are non-deterministic, which means like you cannot always replicate the steps, right, as compared to the traditional software programming, where you know exactly this was the stack trace, and these were the 5 things which basically, or maybe the 5 lines of code where it is exactly broke. This is like more, you can say, non-deterministic in that sense. So it's very hard to actually scale this. So this is a personal recommendation. Like if you guys are starting building AI agents, start with the simplest solution. Most of the time, you will realize you might not even need to build an agent. A single LM call with the retrieval process can give you a lot of advantage. And this is something which I would like to again emphasize, because 90% of the problems which I have seen, and I've been working with enterprises, I've been working as a consultant as well, I've seen like they come with a plan that we need to build a very fancy multi-agent architecture, but at the end of the day, everybody needs to just give context to their LLMs, and in those cases, maybe like if they want to resolve a customer support ticket, or maybe they want to like make a sale, they can just do that, and LLM can access the information which is very specific to their company data. That is the 90% of the use cases which I have came across with. So all of those use case can be solved with a single LLM call with the retrieval. And then slowly add complexity. Now, I'm not saying that there are not, you can say, benefits of adding agents. These are some of the trade-offs which I have experienced. Agents often increase latency and cost, but can yield better task performance, especially when you do not have the exact understanding of what are the steps you're gonna need to take this task ahead. I can give you an example. This is more like a research project. Like for example, if you're writing and working on a research paper, you don't know exactly like if you're gonna look at the 5 different blogs, or maybe if you're gonna look at the archive, or maybe like other papers. It's like very open-ended. So in those cases, like agents have performed very well. OpenAI also like launched recently their deep research. The second part is like you can use workflows, and I would like to introduce workflows as an alternative to agentic solutions, because this is also one thing which I have realized that most of the time, if you can write down all the steps that these are the things which I need to automate, you can pretty much create a workflow out of it, and then you can like put LLM layer right now, because LLMs are more capable, and then you can have a more predictable set of outcomes as compared to like just relying on the agents. So these are like 2 top insights. As I mentioned, like many applications don't need particular agents. Let's talk about frameworks for now. How many of you have used agentic frameworks in this room? Okay, few people have used that. Anyone has deployed any application into production using agentic frameworks? Okay, I think I haven't seen any hand. I'll tell you why. I also tried this. I tried all of these agentic frameworks, and I've even like tried some new ones also. These were some which I recently tried, so I put it on the slides. I tried LangGraph, CrewAI, Autogen, Ribbit, Vellum. These 2 are the no-code friendly. So if you are like somebody who cannot write code, or maybe don't want to write code, you can check out Ribbit and Vellum. But top 3 were these like LangGraphs, CrewAI, and Autogen. One major learning from after using these frameworks is that they are very strong. They have been built by like, for example, I met the community who is basically actively involved in the Autogen, and they've been doing like a lot of interesting work around this agent. Problem is like that might not be the best use case, or maybe the best product for whatever problem you are trying to solve, because they are doing it for their own internal research purpose, and they've made it out, they've put this as an open source project. So it's great to basically learn from this, but to use this in production for your particular use case is where I have seen like where a lot of people like you can say struggle in. One of the major insight was, if you cannot understand what is written in the code base of all these 3 things, it's not a wise idea to actually use this in production. I started with that. I started like the first one, the Autogen, and I basically like without understanding anything, I put that into production and realized, okay, there's so many things which I now cannot understand, and maybe like I need to go back and read the code. Then I read the code, I realized, okay, there's like almost like 10,000 lines of code which is written here which I might not need, and the agent is going into loop. So a lot of those learnings from there is that these are some of the pros, right? It definitely accelerates the development. You don't need to write everything from scratch. It can handle some common tasks. For example, if you work with Crew AI, Crew AI gives you like a very simple framework. You can add a skill, you can add a goal, and then it can basically like employ multi-agent, and basically you can just start by writing, I think, like less than 10 lines of code. All of these things are great. The main problems is that because they have more and more abstractions, it gets harder to debug, and there are a lot of, as we mentioned, like potential hidden complexities, because the way these guys have solved the problems and they have built the particular agentic framework is maybe because they were solving something else. Say for example, like Microsoft was trying to solve their maybe say internal problems, and that's where the autogen came in, right? But you might not need that like capability maybe to solve your sales pipeline. Another main con is that you tend to over engineer a lot of stuff because you're already sitting on a huge code base, so you tend to like add more things, and sometimes you're not aware of, okay, how can you particularly optimize one particular component here, and that will just like create more and more problems for you. So what's the recommendation now? Start with a direct API call. Use frameworks only when you can understand the underlying code and you truly need the abstraction. I don't have the GitHub link right now with me, but maybe you guys can check my GitHub page. I have uploaded a lot of native Python-based scripts. You don't need any framework. You can use something called React, which was an initial research paper built on how you can like build AI agents. And it was like completely written in Python without using any single library. I think it's some 100 lines of code. So if you can just use that 100 lines of Python code, I can basically give you maybe some assurance that 90% of your cases, especially your personal cases, for example, in my case, it was kind of replacing my assistant, where it basically used to like check my emails, follow up with my calendar meetings and everything. All of those things, I'm able to do that with just 100 lines of Python code. So I realized that I don't need all these frameworks, but there were like you can say some use cases where like I might need Crew AI, I might need Autogen, but those are again very very specific use case, and I got to know after that, after like understanding what they have written and what they have built for. These are some of the core building blocks as we are discussing right now. The retrieval tools, memories, and if you basically understand the importance of all these building blocks, you would be able to take a call whether you want to build a workflow, whether you want to just add a single API call, or maybe you need something more advanced, more complex, like an AI agent. These are the building blocks. Now, I would like to actually give you one interesting insight from here, is that when I started like LM application, the first one was actually a very simple API call, which was a God in a box, which used to take some message data as an input from WhatsApp, and it basically used to send it to GPT 3.5, and GPT gives the response back and then gives the output back. And over time, we basically started adding more things there. So one of the main part was retrieval. This is where we added the memory, and we said, okay, now we have to build, say, Chrome extension or maybe like software developer tools. Instead of just sending everything to LLM, I can just see if this can read the documentation. Say if I'm building a particular app using JavaScript, Python, so can it actually go and check the doc? And if it can check the doc, the latest ones, because most of the problem is that LMs are trained on older data. They're not always up to date in terms of the docs and the libraries. But if you can connect that with the, you can say the real-time retrieval for fetching the latest information about the libraries and docs, you can basically get all the updated details, and then it would be able to perform like much better in terms of coding task. Again, like if you need something like interaction based, if you might want to say automate a particular pipeline for your marketing, for your sales, you can like start thinking about the APIs. Like what are the APIs you can connect here, and what are the input and output you can give it to the API. So and the last part is like the memory. This is something which is which comes after like spending some time and like building some application, that what are the things you need to keep in the memory for the LMs, because most of the time now we have seen that because context window has increased, so you might not need to store everything in the memory. So you can think of something like what computer architecture folks have done with the hardware design. We have RAM, so I would like to compare that system with this. Like the RAM is associated with the short-term memory here, which is a context window, and then we have like a ROM, which is the hard disk. That can be your external memory, where you can basically put all the context there, and whenever it needs to access that particular file, it can basically go and make a call. Although these calls will be a little expensive, which means it will take some time, and it not be like faster. But you can always like manage the two set of these memories, the context windows and the external memory, and like build pretty much any kind of like robust application. Uh, these were some implementation tips which I had. I think some of them I've already explained. One thing which I just want to highlight from this is the Anthropic's model context protocol. It was very interesting part when these guys introduced it. Before this, I used to use OpenAI's function calling, which was how you can like interact with third-party tools. So you can just like train OpenAI and give it, these are the API endpoints, and these are the functions you can call, these are the inputs you have, and these are the output you can expect, and you can basically pretty much connect anything. Anthropic's MCP basically gave this away with a particular UI set. Now even like people who are not, you can say, friendly with code, they can also like use this and connect different third-party tools. So if you haven't tried this out, maybe you can give it a shot. Let's talk about a few workflows. Now, these are some of the things which, if somebody is trying to build an AI agent / workflow, how you want to go about it. So I have, I think, 4 or 5 workflows right now with me. So I'll just quickly share all the main ones. What are the use cases and how does it work? This one is a very simple, the prompt chaining I was mentioning. You need to decompose the task into sequential subtasks, which means like, let's take an example here. We did this marketing copy recently where so one of our students built this agent, which, for example, you are running a D2C company. Maybe you are selling headphones and you want to write a marketing copy, maybe you want to like build an ad. What's the best way to do that? In our experience, is the best way is to actually get the customer reviews. What are the things they actually like about your product? Maybe say if you're selling headphones, what are the exact things they like about headphones? What are things which they do not like about headphones which are already there in the market today? And where can you get the most authentic reviews? We tried Amazon, but Amazon is like full with all the paid reviews. So we thought, okay, let's check Reddit. And we found that Reddit is like one of the most authentic one right now. So we basically like built an agent which can now take a particular niche as a category, and it basically understands about your business, and then it can fetch all the top Reddit threads about your products, and it will basically fetch the top questions. Okay, these are the 5 questions which everybody is asking about your product. Now let's use these questions and create a marketing script for you, so that like whenever you run your ad next time, it will be more relatable to your audience. So that's like one of the interesting use cases, and you can build the entire thing without writing, you can say, all the complex code. This is just like a one single prompt chaining workflow where you need to set some steps. Okay, step number 1, take the input as a category. Step number 2, use this input to find Reddit threads. Step number 3, fetch all the top questions. Step number 4, put this data into LM, and that's basically, you basically can like have this workflow. And you don't need to again add the agentic capabilities here. You just like write these sequence, and you can just like make one direct API call. So this is one of the diagram of how it will look like. You have a first LM call there, and then you can add a gate. So this adding a gate is like quite helpful here, because if you don't add this part and it has some exceptions or some errors, it'll just always like take the entire cycle before actually realizing that something went wrong. So adding like a gate check, what I would like to say is like the evaluation check in the first phase of the API call is like quite helpful as compared to adding this in the later stage. This is the second workflow, which is like, I'm calling it routing, a lot of different names here, but it's very similar to what we had at the prompt chaining, but the only major difference here is, I'll show the diagram first. Now instead of just directly calling all the APIs, we are making one LLM call router. And this router is nothing but, it's just an if else, or maybe like you can say switch case statement. You have a bunch of statements and conditions. For example, say I'm selling a product, or maybe I'm selling 3 products. So if a user is asking about, say, headphones, this LLM call will help me to understand if my company has like 3 products, what is this prompt talking about? If it is talking about headphone, let's send this to the LLM call 1, because LLM call 1 has all the data about the headphones. So the entire job of this router is to actually find what's the best particular prompt chain for your use case where the user is writing the prompt. And this, in my experience, have worked very well for most of the use cases, because especially in the customer support, including both, you can say the service ones as well as where you might need to decide whether this particular person needs a refund and maybe need like a human in the loop. So you can add one more layer here. You can say human in the loop, and you can just like give all the context to the router that maybe there will be 5 cases where you need to send this. In the 3 cases, if the user is only trying to ask about the information, you can use LLM. But maybe if the LLM or maybe the user is trying to understand or maybe like asking for the refund, then instead of sending to the LLM call, you just like send it to the human agent, and then human agent can take it forward from there. And this is what we have also seen in a lot of enterprises. By the way, the team which I like work with, and we basically like help them to hire people from us, they recently deployed a very simple workflow-based agent, which was the exact same architecture for Bangalore Police. So where Bangalore Police is basically now running a LM call router. If somebody calls right now to the emergency helpline, they'll basically understand what is the language you're speaking. So based on that, it'll basically detect, okay, if you're speaking Hindi, Kannada, Tamil, so you have the different chains for that. And every chain has different segments where like if you need a help immediately, that will basically directly read out your call to a human agent. If you need some information, it will read out the call to a particular LM, which has the context about your language and your region. So that is something which we have deployed in the production as well. This is the second workflow. This slightly more complicated. I would like to first show you the diagram again. Now, whatever we've been basically discussing in the previous calls, previous prompt chaining workflows is where, okay, I think I have almost like crossed my time, so I'll just quickly send you some examples. I think these are a few workflows I have. These are some of the applications which we basically had, and I'll show you what our students has made already. This is Sally AISTR, one of our students from the first year.
All of them being orchestrated through an custom orchestrator. Okay, so contextual layer, just to give you a brief, contextual layer basically helps properly indexing your objects and making it searchable. Retrieval mechanism basically helps fetching the right results efficiently, and the consumption layer helps in taking your input, processing it, and then giving you an output which is more insightful and in much more structured fashion. So let's deep dive into each one of them in our next slide, and I'll be speaking on it. I'll be also also discussing the challenges which we met on designing each one of them and how we mitigated it. So as you can see on the extreme left, we have multiple business functions, and each of those multiple business functions were having multiple databases, right? So some were having SQL, some were having Oracles, and other like that, and lots of databases, schemas, and your SQL objects, which includes procedures, functions, views, triggers, all those things. So these are all set of DDLs and the DML scripts. Nothing has to do with the data in it, right? So we want, because the aim is to define the legacy or backtrack it and find out what is the root cause or the root table which is supplying its data to the final UI layer. So we had a set of procedure scripts, functions, and all those things, and how we were provided was, it was one script per object type. That means one file which was containing like around 10 to 20,000 procedures, one file which was containing equal amount of functions, one file, views, like this thing. So the very first challenge what we met was that how do we reduce the size, how do we chunk it, right? So there were two strategies which we followed for chunking. First is simple, the size thing. So we'll try to keep this thing into 2 MB file size, but also making sure that the integrity of any of the SQL objects, or in such case Oracle objects, remains unimpacted. So it retains its integrity, right? So nothing is cut middle way. So in that case, what we were doing is that we made a use of, finally we are looping through it, size things, and bucketing it into a fixed size 2 MB file, or near about the same thing. But we have made use of the robust and scalable regular expressions, which will also make sure to find the logical ending of any SQL object, right? So if in case your 2 MB file size grows up and something is getting cut midway, it will not allow it thing. So it will allow that thing to go into a separate file. Now another challenge was, suppose if any of the file or any of the procedure is too huge, which was in our case, something around 150,000 tokens were there. exceeding any of the large language model context window as well. Okay, so that also we'll see. So when these lengthy things were there, we relaxed our rule number 1, saying that okay, if the size is more than, while maintaining the integrity, the size is more than 2 MB, let it grow in 3 or 4 MB size and let that be there. Can we zoom in into that, please? The first one. Right. So if you see on the top hand, right hand, left hand side, you have all these functions and there are lots of files. And these are the chunked ones which nearly 2 MB files or 2 KB file size over here, right? So everything has been reduced to that limit. If something is growing, it takes one file of itself, okay? Can we zoom out? Thank you. Next thing was that once we have done this thing, we have to encrypt the data. So because we have to maintain the data privacy, preserve the privacy of the data as well, one of the responsible AI pillars of maintaining the data security, we are encrypting it and storing it into one or the other layers in our Azure data lake. Okay, so when we are doing that thing, we are making sure that each and everything is marked as well, because there were these are pretty old written procedures, functions and everything, like 20-30 years old system, and many developers would have tried their hands. They have created their own copies of themselves, _test, _old, _datetime, _developer name, right? A lot of variations, complexities were there in over here. And they were also having somewhere hard-coded phone numbers, customer service email address, business functions name, the business functions key person names, all of them were there. So we used Azure language service over here, and we marked, anonymized all of those texts as well, right? So that is another activity which we have done. Next thing is that we wanted to fetch the metadata of it. So more of the metadata so as to support the the search accuracy. The searching thing gets more accurate as in, when you provide more and more of the metadata to it. What we did over here is that, can we zoom in once more on the same one? So what we did is that in each of these stored procedures, what we found it is that what all other procedures, functions, views, tables, all those mentions of the things, common table expressions, dynamic variables, all those things we are capturing as a separate objects over here. And then we are also tokenizing it so that, the processing becomes a bit faster. So all those things we have also taken it out over here. Zoom out, please. Backs. Right. So those things, text analytics helps with generating the metadata. Now comes the embedding and the indexing part. So we could have directly also indexed it because it was all the textual thing, semantic thing would be working very well. And we could have simply the stored procedure, text, body and everything, whatever we have created, we can simply index it also. But here, what we have tried to do is that we have done an additional layer of embedding, which is giving an uplift of around 6 to 7% accuracy search results. Okay, we are doing embedding using text-3 large language model, embedding model, okay, and also have compressed the size. That means the dimensions are just 256 compared to the default, which was around 1500 something. So we have compressed it because since it is all code-based, we wanted all the semantically similar tokens and all those things to appear in much closer to each other, and that's the thing what we followed over here. We decreased the the size, the dimensions of the embedding, and then we have indexed it. So that means now our index is having the textual things as well as the embedding, so that it is helping us support the hybrid search, right? So it will have the semantic search, simple search, and the hybrid search as well. This is how we have created our contextual layer, and why we are calling it specifically as one contextual layer. Reason being, now different business functions can have their own databases and all those things, and with just a small tweaks in the regular expressions or wherever we have used, we can simply use the same code base to create or enrich our existing contextual layer. So it becomes literally an enterprise-wide one contextual layer using this thing. Now the other half of it is the consumption layer, right? So consumption layer is where the people are, the end users will be sending in their prompts, and it will be processed and the results will get generated. Now another catch over here is that the challenge which we met is that, so if you see table name. So what happens is that you can provide just the table name, that I want a lineage of this particular table, or you can say I want the lineage of schema.table name, or you can also say I want the lineage of database.schema.table name. All of them essentially is just one thing. It is referencing to the one single thing, which is that table name, right? So for which we wanted to calculate the lineage. But this is also a challenge which we have to manage, and we have to make it consistent across all the things. That's where we are also doing a little bit of augmentation. But before augmentation, what the user sends, we are first doing the prompt validations. So another principle of responsible AI is that, profanity check and, any toxicity words and all those things. So small validation things also happens on the input prompts. Then it goes for the augmentation. Now, another thing is that, for example, if I want to calculate the lineage of table T, okay, we say, okay, find the lineage of table T. Now, what does that mean? I mean, wherever this particular table is getting its data from or into, right? It has nothing to do with where is this table is being used downstream in a form of a select query. That means it should be followed by insert into, or update, or select into. So these three keywords are something most important in finding the lineage or the source of data population for this particular table. So we have done the data or query or augmentation, where we have used Lucene query syntax with proximity search of 5-word tokens. Meaning what? In a 5-word token, here or there, if you are able to find this table and insert into, select into, or update kind of query, pick up those procedures or those places where it has been defined. So that means it is over here itself eliminating all those places where this table is just being used in the select query. So select everything holds no meaning for the lineage purpose, right? So that is something what we have taken care in the query augmentation. So once we have augmented it, we are sending the same Lucene text query to our Azure Search Index, where it does the job of query retrieval. Now, since there is a whole lot of contextual layer which we have created using metadata and embedding and all those things, it is getting us back the results. And Azure Search Index out of the box also provides the re-ranking. But over here, there are since we are using regular expressions, and I've said this thing that the data is constantly evolving, right? So we are not touching this portion. We are always touching contextual layer whenever new data comes or new data sets we receive. So when this happens, regular expressions tweaking also sometimes fails in capturing out all the redundant entities like underscore test, underscore old, underscore developer name or time frame or something like that. So we re-rank it once more over here and put down sub-power all those kinds of results, okay, which are more or less coming from those redundant procedures or the SQL objects, right? So that is the re-ranking, custom re-ranking, which we have applied at the retrieval stage. Then comes the prompt engineering. Before sending it to the LLM call the retrieved results from the search, we do the prompt engineering. Can we zoom in, please, on that? So this one. So our our prompt design strategy was just a 3-phase strategy, okay? Where first of all, we are saying identify all the contributing objects. That means all the contributing objects, tables, which are supplying its data to this particular table, okay? That means they are helping populate one or the other fields of this particular table. Be it if there are common table expressions, contains all those things. So do not name just the common table expressions or the aliases or the dynamic variables. Rather go and scrap further and get the real object name outside, right? So all those things are handled using that particular piece of thing. So next is, suppose this GenAI is giving you some results. So how do you verify it's right or wrong, right? So there is this accountability principle of responsible AI, where you need to know, okay, you have generated this result. How should I believe? So to ensure that trust or entrust the users, we are taking the help of these two prompts as well. Now, first is fetch the code snippet where you have found this whole thing happening. That means give me the set of that code snippet out of the large SQL objects where this particular table is getting inserted into, created into, or something like that, updated into, right? And also help me with the attributes. So simply saying that, okay, table Y is helping populate the data into table T is not enough, right? You need to know which all columns, like, because there is no one-on-one mapping that everything of this table goes into everything of that table, right? So over there, what all columns, what all attributes are basically helping you put into the things, give me that result set as well. Now these two helps do a lot of reconciliation thing on its own. It lifts the load from the developers or the end users, saying that okay, you need not to go and revalidate the things once more. You just go to the reconciliation part, the outcome into it, and just see whether your code snippet is having that thing or no, or your columns are properly coming or no, right? There could be a direct columns, direct attributes. There could be an calculated attributes as well. So everything comes up over here. I have also taken help of some regular expressions, very minimal. When I'll be explaining the next part, which is the the LLM model selections, I'll put a focus on why there was more of the examples and some things required in the form of regular expressions for the older generations of the LLMs which I have used. So this is how I have designed the prompt. Can we zoom out, please? So we have come here till here. The retrieval is happening. The prompts has been created. Now the next step is to send it to the model, right? So we started with the one model which was GPT-4 32K. The context window anyways is 32,000 tokens. But our data set, many of the procedures were more than like 80,000 or 90,000 or even going till 150K tokens. So we have to do a lot of context or the results from the previous thing. We have to hold it back and send it as a new context in the subsequent executions. And that was, somewhere it was also, not working that much well, because it will lose or it will have the redundant informations. Plus, GPT-4 32K required a lot of examples to be given. Almost all the kinds, okay, you go and find out insert into, you go and find out select into, you go and find out update. You also have to give what not to include, like do not include anything which comes as select everything, right? Select asterisk or something like that. So we have to give what you have to include, what you have to exclude. So everything you have to mention it very explicitly over there. We then switched to GPT-4o. Okay, now that helped solve this problem. So with the GPT-4o, we require very minimal, prompt instructions. Very minimal. I have not given it any examples. I have not given it anything, not regular expressions to get the contributing objects. It is doing everything on its own, and the accuracy is very high on this one using GPT-4o. Plus, it has a context window of around 128K tokens. So the largest of the procedure is just getting executed in maximum 2 or 3 iterations. So holding back the context is also solved over there, and it is also not taking like redundant informations or all those things has been avoided using GPT-4o model. Okay. Now next comes is once you send the results, it gives you back the results. What we have to do is that we have to do the output reformatting. Reformatting because it's all the textual things what the GenAI is sending, right? We have to reformat it into user consumable format. So we are consuming it, we are converting it into two formats. One is JSON and another is a data frame kind of thing, so that it could directly be exported into an Excel, and the hierarchies and the levels, parent and the child, or the contributing objects, and the reconciliation sheets also we can see one after the other directly over there. And using these two things, we are well able to generate the graph kind of visualization as well, which is a tree format thing. We are able to properly generate it. Now we have applied all of these things, making sure that there is a proper data governance, proper security thing is taken care, and proper deployment also happens, scalable deployment and robust deployment. So can we zoom in into that data governance and security? So with the data governance and security, what we are doing is that we have lots of intermittent results which we are saving, right? So it's a huge data set, we don't want to lose it, or we don't want to rerun it again and again. So we are saving it intermittently, and when we are saving it intermittently, we are making sure proper encryption, decryption, anonymization, all things are there. Plus there is a role-based access control that only the people who are using it with the proper service principal account and access and all those things, role-based things, are able to access it. The outcomes, the intermittent outcomes, the final outcomes, all those things. And then on the deployment side, we have used Azure Kubernetes containerized deployment, which is anyways isolated. So it is all kind of watertight case in case of any from any threats or something like that. So that thing also we have taken care very well over here throughout the solution, not just one part, equally distributed across everywhere. So user input have already taken care that validations also happen, filterings happen, the response which gets generated also gets validated before sending it or preparing the final responses. So that thing is there. Can we zoom out, please? This thing, now this whole code which is created is very much modularized, so that everything, whatever parts you are able to see up over here, everything is converted into a modular classes object fashion, right? So that, and it also follows these solid programming principles. If you all know, you would be knowing it. Solid stands for, the single responsibility, then Liskov substitution, and, inverse dependencies and all those things, right? So all of those things has been taken care, open for extension but closed for modifications, so that it can be adopted to new data set, new things which are coming up, but the old one remains as it is. So derived class, abstract class, base class, everything has been taken care of while the coding thing. So this is how we have basically developed our solution, following all the best practices on the responsible AI side, educate responsible AI implementations, governance implementation, security, and then Python programming best practices. Next is, with all of this, so these are some of the challenges which I was speaking about, that redundant objects were there, 20,000 parsing 20,000 things with deviations and complex things such as CTs and then dynamic queries and whatnot, all there. So handling those things, multiple embedding models we have tested, but because this is a coding based thing, so we require a very densely populated embeddings to happen, not a sparse one, because then it will not help us with proper retrieval accuracy and all those things. Custom re-ranking, as explained to you. Partial queries, the same thing. People might be sending simple table name, or they may be sending the schema or table name or database name. Setting the right, selecting the right GenAI model helped me a lot over here. And deployment is like optimized and is, scalable deployment, Kubernetes and all those things we have used. Now this all has helped me gain an accuracy of around 85 to 93%, right? So why 85 and 93? Because the object complexity is very much. So they are having around 20,000 objects. Not all of them are of equal size, right? There are very, very huge legacy SQL procedures, functions, and all those things which are like very, very complex, and whatnot you can imagine into that is available over there. Over there, we have been able to achieve a pretty well 85 to 90% accuracy. But there are a few smaller ones, very smaller ones, 10,000, 20,000 tokens, some medium ones which are around 50,000, 60,000 tokens. Over there, we have been able to achieve an accuracy of 93%. Now, this is all benchmarked against the manual lineage which on the parallel side, the data engineers and developers were doing. So this has been benchmarked against that thing. The major gain was on this one, the efficiency in time saving. So we have been able to save the developers' time, the modelers' time, the engineers' time by 96%. Whatever they have been doing for one single object, they will pick it up. They would be taking around 5 to 6 hours to trace back across these 20,000, 25,000 objects and come with the legacy, and then also revalidate it once again by a peer programming or something. They are now reduced to just max to max half an hour, including the validations, because this GenAI is helping them generate the results for a particular object in just like the biggest of them in just like 5 to 7 or 8 minutes, right? And you can give a club of them. That means you need not to do it one by one. You can say 10 objects, provide me the lineage of 10 objects. You give it and forget about it. Within 30 minutes, it will give you all the things. Only thing which the user has to do is randomly go and check it whether it is fine or not, which we have tested it and it's all good. Well within the limits. So this is how we have been able to generate the graph of it. So you will have the top level and then all the bottom levels. Now this has one more thing which is you can usually do is the impact analysis part of it, right? So what do we mean by impact analysis? If you remove one of the layers somewhere, your entire stack falls, right? So that means it will help you determine what are my upstreams and what are my downstreams which will get impacted if I remove or forget to migrate one of the important objects from old system to new system or something like that, right? So that is something which will be taken care. And these are all the Excel outcomes. I'm sure pretty blurred up, but then some reconciliations, some things over here. Now this is what we wanted to cover, and happy to have any questions. The floor is open for discussions. Yeah.
Thank you. Can somebody pass on the mic here, please? Second row.
Hi. So as you mentioned, I see you have used this OpenAI text embedding 3 large model for this embedding purpose, right? So what I want to know is by default it is I think 1536 or something, the vector dimension, and it can maximum go to
1536, right?
Yeah, 3072 is the maximum, but you have used 256 in order to make it a dense vector, right?
More dense, right?
Yeah. So have you seen any enhancement in the precision or recall of the retrieval?
Right. So we have seen that thing because when you have a sparse embeddings, what happens is that your search accuracy decreases because we are doing the hybrid search, and it definitely gives you affects your 2 to 3% of accuracy when you have the sparse thing, because in a code-based thing you require all the relevant or syntactically similar, semantically similar things to be as close as possible to each other. If you are having, like for example, take this example, insert into this table. If insert into is in one corner, this table is in another corner, embedding has lot of things, gaps or this sparse thing, it's not going to give you the right, bring down the right result to it. But if you have compress it, it is going to give you the right results, better results in fact.
Okay. So how did you arrive at this number, from 307 to all the way down to?
So I tried with multiple things. I even tried with PCA to further decrease it down, but that was not giving me that much uplift to the procedure, and that was a more computational intensive, because I'm first of all reducing it and then again doing PCA. That this whole thing costed me time and the resources.
So you've basically done a quantitative analysis as to
right. So a lot of decision making steps were there, so we went through that experimentation stage.
Thank you.
Accuracy over here means, suppose you are finding the lineage of a particular table, right? So that means this table is getting populated based upon what other tables. So accuracy over here is
the source table name is
all source table names, and backtrack to 7, 8, 5, 7 levels, whatever configurable configurations we have given. Right now we have given it 8 configurations, so it goes back 8 levels back if it is possible. Otherwise, if it has found the leaf node at around 4th level or 5th level or 6th level, it ends over there. It doesn't hallucinate or tries to generate the things.
Okay, thank you.
And accuracy was, again, I've told you, so we benchmarked it against the manual things what the data engineers were parallelly doing it. So how much tables they were able to find out, and how much table GenAI solution was able to find out. Plus, one more thing what we have noticed is that they have added more tables wrongly in their outcomes, but GenAI did not do that. Okay. So this was much more closer to the lineage thing.
Got it. Yeah.
Yes,
thank you.
No, knowledge graph I haven't used, because our aim was not to do the relationship finding and all those things. My aim was majorly to flatten up the things, because the data from different systems, the data is coming in, right? My objective was not to create the relationship between the tables or the schemas. My only objective was to flatten up everything, see it together, bird eye view, and find out, okay, how many things are located where, and do it in the fetch it into the retrieval thing.
So this tree diagram that you show here, how is it that this has been generated?
So this is getting generated from these Excel files only. So we have used a proper, this thing, custom visualization thing to generate the parent child, because in our outcome we have the parent, this is the target table, and the contributing objects. So contributing objects becomes the level down. This becomes the parent, contributing objects, this, contributing objects, like this.
We'll take one last question if anyone has.
That one I don't think so it's zoomable. These are static images. Tokenization. So tokenization in the sense, the embedding. So we have used the embedding, Azure embedding model. This Azure 3 large embeddings. That's the model name.
So,
So over there, it allows to change your dimensions. So that's where I was able. So by default, it provides 1536 as a dimension. Over there, it allowed me to change the dimension. I made it to 256. Sorry. Parallelly also we can do, but I also wanted to. That's the minimum limit over there, and we can also go very like thin also, but that's not going to help us. So it's like overfitting and no underfitting, same thing.
instead of doing these things directly, why can't you hire Azure services and there itself you deploy the databases and there itself you can use it, no?
So which service basically?
OpenAI.
Ha.
And you have used Azure services and you deployed your architecture for finding some solution. What I want to say is directly instead of OpenAI or Azure services, one service you take it and directly also you can do it, no?
So a lot of custom codings were done in middle, that there is.
Azure services also will support all these things,
I'm using completely the Azure stack only. So one or the other Azure stacks only or the services we are using.
So the OpenAI which is being mentioned is Azure's OpenAI. So we are actually developed the entire solution using Azure stack.
So it's all Azure,
Yeah.
Azure OpenAI deployment. Right, everything is Azure.
I have one question.
I'll end with this question, please. Yeah.
Yeah. So the vector DB or the embedding DB that is getting created at stage 1, it takes input as the DML and DDL queries, right? The input database.
It takes input those metadatas which we have created and the DDLs and the DMLs,
DML
right?
queries, right? And let's say you want to get the lineage of a data store, right? A data object. So let's say there's an inconsistency in the language. Basically, there are some missing queries for a lineage, the ground truth of a lineage, right? How will you?
That's the limitation. That's the limitation. So suppose if there is now, suppose in the input data set itself there is one missing part, then it's not going to go and generate it. So
it stops at some point.
It stops at some point, right? So it finds the leaf node. I am not able to find further track. It stops over there. It doesn't hallucinate. That's more important to know that it doesn't hallucinate or creates the things on its own.
Creates its own lineage.
So it doesn't do that. Yes, please.
Thank you. We'll move it outside session. We are running into the next session.
Yeah.
We
Thank
can
you very
keep
much.
the
Thanks
question and
all for
answer
attending the
outside hall.
session.
Thank you. Give them a
Thank
round
you.
of applause. Thank you. We'll move on to our next session, revolutionizing communications, AI's role in making the internet multilingual. In a world where majority of internet users speak language other than English, the potential for growth lies in inclusivity. This talk will explore how AI is bridging the gap for over a billion people, transforming content into native language at scale. We have with us co-founder of Devanagari, who will share insights on how neutral machine translations, voice bots, and foundational language models are reshaping industries. Devanagari, an AI-powered localization platform designed to make the internet accessible in vernacular languages. A recipient of multiple accolades, including the top 50 awards at TIECon Silicon Valley, Himanshu is a thought leader in AI and localization, driving businesses to personalize communication at scale. Let's hear more from Himanshu Sharma. A round of applause, please. Himanshu, you can get on the stage.
Good evening, everyone. How was your lunch? And how was your tea? Is it good? Can I go back? Yeah. So, how many people knows? How many Kannada speaker here? 1, 2, 3. How many Hindi speakers? Oh, I don't want to debate about that at all. So yesterday I went for a dinner and I ordered a dosha there. So somebody was ordering in Kannada. So the person who was treating him is very well, and he greeted very well. And one person who spoke "Mujhe dosa chahiye," so he just ignored him. So I thought, why not I should use English? And I said, I want a dosa. He added 50 rupees more on my bill. So that's welcome to Bangalore, and you are a startup founder. So could you find a strange thing in my slide here? Yeah. Yeah, it's upside right. Yeah. So this is think that billions of people who don't understand English is same thing feeling like this. It is there, but not making sense. So so we talk about today how we can revolutionize multilingual communication with AI, and how AI is transforming internet into multilingual platform so that people who don't understand English can access internet in their own languages. I start with question. So how many people have seen funny translations online? Can somebody give an instance if you remember? No? Any instance? Because yeah. It happens a many times, but it is only funny until and unless it is not yours. So for businesses, if something goes bad, it actually hampers their brand image. So let's move in. Yeah. So what is the global challenge, right? 80% of the people in the world don't speak English. 80% is a huge number, 6.5 billion almost. But almost major of the data everywhere is in English. So how do they access internet? There's a language gap. There's a solution which make funny translations, right? And there are missed opportunities for businesses who cannot reach the actual user. These are the big pains which we have seen. Do you anyone know how much internet content is in English in terms of percentage? Any idea? Oh, bingo, you are right, 60%. Okay, in India, how much content is in English? What percentage? Any idea? In English? In India? 80? More up. More up. It's 99.8%. It's in English. And it's a stat released by Government of India last year. Only 0.2% content is in local languages in India, which seems like, for example, if you're doing a critical information research and you found a web page in Chinese, how long do you stay with that? You just close it, right? So imagine a world where people don't understand English, they go to a web page finding things, but how long they will stay it? They'll not stay and move on. So they are now not being a particular part of it, as my photo said, things are there, but they are not able to use it. That's the bigger problem for Indian people. We think that English is a major language, and we have to speak English. So I just want to say that it's just a medium to converse with each other. It should not be a criteria of selecting in a job or selecting in any entrance exam anywhere. So I have a friend who is a director of ENY, and he was a Kannada medium. But he told me that how hard it was for him from switching from Kannada to English after his 12th to engineering. So how many people can does that? Very less. So our education stat says almost 50% of people drop out from schools in primary education because of finance and all those stuff. Means they live their whole life with only one language. And on internet, they don't find it well. So why it matters now? So internet penetration is on peak. Everyone is on internet. Our 1 billion people are on internet. This is a high time where we should give them things in their language. So it's not about India, it's about global thing where global markets are suffering because people are not getting things in understand the things and buy those things. And even the trust which comes from a brand, right? Somebody, Nelson Mandela said that if you talk to a person in the language he understands, it goes to his head. But if you talk to a man in his language, it goes to his heart, which is very true. We actually associate each other with our languages. We go watch cinema not in English but in Hindi or Tamil or Telugu, and we enjoy it. We read newspapers. So offline media is already there from 200 years. There is no need there. But digital media, we don't have internet content access in local languages. So we thought there are two ways to solve this. One is to create a lot of content around multiple languages, which take much more years. And we thought, why not we make a translation-based approach where whatever the content is there, we try to translate it into multiple languages, which we think was an easier part. So I more delve into how translation works. In 1950s, it was a word-to-word translation. We call it rule-based translation. It's not here. The slide is, I cannot include all the phases of that, but 1950s is like rule-based translation where we translate word by word. I am going to hospital, main hospital going, something like this, and word to word we do it. And then it comes with rule-based translation where early translation model works on actually grammar rules. You must have a dictionary. So linguists write dictionaries and write grammar rules and making them very, very rigid. So translation does not happen well in those cases. Then it comes a syntax-based statistical machine translation, which is before this version. It creates a tree and it find a combination of subject, verb, object, and try to create translations on those basis. But the syntax was very, very difficult because it created a tree and sometimes it does not make sense at all. And then evaluated to translation statistics called machine translation, which works on probability. So it learns about how both words can be switched with each other and how it can be represented. But it gives very inaccurate translation because it works on probability. You need to write lots of rules around that. And then in 2016-17, 2015, we came with neural machine translation, which we call NMT. That was actually based on deep learning, which works like a brain. We have lots of neurons, and it can automatically understand the context of words, how do you write it, and it can learn on data. So in neural machine translation, it works on millions of data lines, and not only data lines, it's not about monolingual data, it's about parallel data. So once we call, I'm going to hospital, it should be there that मैं hospital जा रहा हूँ. So these kind of sentences you should collect, make it in millions numbers, depend on industries or specific use cases what you have, and then you can train it. But training was very easy. You can build it very good models out of it. But the problem would be that it does not give context. So if I say mobile can be phone, and mobile can be walking. So it does not able to understand the context of it. So it can create a creative translation altogether. It can give you a sentence-based translation where how the sentence is working. It can give you a pretty good translation. But if you say in the above paragraph that Pradhan Mantri Modi was speaking something, and in the underline it, you say he is speaking something. So it won't be able to make relation between both of those things. So that was the limitation what neural machine translation had. And then comes LLM. Right, so we thought LLM came in, the language we'll solve the language problem, but came to know that 90%, 95% of data on LLM is in English, so it does not work for Indian languages at all. And still, it can give a context, but it tried to fit in the English dictionary what we have. So it tried to. So for example, I'm going to hospital is I is a subject, going is a verb, and object is hospital. Hindi में होता है मैं hospital जा रहा हूँ is a subject, object, and verb. So once we write it, these kind of things, so English predominate that and try to make Hindi like English. So the translation does not work in LLM as well. But it can give a context from above thing and below thing. So it can tell whether above person is Narendra Modi, so below person is also Narendra Modi. So what we did is we tried that why not we mix both NMT and LLM, where LLM can give us a context and we translate and do it. So once we tried Open AI and then afterwards Gemini, they do not work well at all on Indian languages per se translation, because translation is very specific for industries, for companies. So if I say prestige cooker, it cannot be Abhiman cooker, right? So it is a prestige. It remains in prestige as in Hindi or in any language. So name, place, things, we cannot change, we cannot translate the names. So but system have to understand and do a name entity recognition and do that stuff. And for that we started using glossaries, that how you want to retain it, because language is very subjective nature. So if I say something, you can like it. Maybe you have another nice words to say the same thing in different words. So very perception based. So how do you want to perceive? So for example, we work with some mutual fund. They cannot use can, they can use only could. Because they have a RBI guidelines that they cannot say that you can earn this much of money. They can only use could around it. So even a small thing can make changes. So language is very subjective to person who is reading and how it works. So brand cannot maintain those tones because they have different people working for marketing, for sales, for customer service, and all stuff, and everybody is speaking their language, not a brand tone. So this is very important. What is role of Devanagari in localization? We kind of created an ecosystem where we call it as a cognitive AI, which you can insert English, or you can insert any format like video, text, audios, and it have a document center which can understand your tone, and then can replicate it to multiple languages, and in an out operation where you just send us the data and we do it. We created a platform. Ecosystem means a platform which can translate your website and application real time, whether you have dynamic content, you have static content, it can catch it and can get the gist of it. So we have lots of customer who have no code solution for translating their application and website in 5 to 10 minutes, 40 languages. We do have document engine. India have lots of document to translate it. In legal, we have about from 1950s to 2025, government have raised RFPs to translate all the documents in multiple languages. So lots of documents are there. We can help. And recently we tried to do a voice bot, which is everybody is doing it. Why not us? So our focus was, why not we make a multilingual bot who can speak the language of a person, a native language. And that is how we are trying to solve. And so one of the example I want to show here, can you play this please? It's a video without audio. And it says an English word that our solution blend advanced tech with human expertise. This ensures they are not only effective, but also, yeah, I cannot read it. Empathetic and tailored to your needs. So we can select whatever language we have. And yeah. Stopped? Yeah, can you play it? Yes. So we support almost about 22 Indian languages right now. I just want to show you that how it works. So this content is from computers, technology, and softwares. And I can now do a creative business and a colloquial translation on it. So once I use business, it will use very heavy Hindi words so that it can make sense for people in policymaker, so that it don't make changes. I hope you cannot read it, right? It is very small. But, uh, and then if you go colloquial, it will translate into colloquial language. Like every day, how do we speak? So we don't speak वार्तालाप करते हैं. We say बात करने चलते हैं, right? So that is the difference between colloquial and those formal business translations. And then we have creative. आज तो हम बम फोड़ देंगे साथ में बात करके. So something like that happens when we do creative translation. So now companies can define that what kind of translation they need, and it's instant. And how do you want to keep your tone, and how you want to be perceived by our customers. And it can be replicate across all channels of yours. It can be website, application, emails, SMSs, blogs, customer service, tickets, answering tickets, everything. So now this is another demo which voice we created. Is just a demo. I just started.
I'm calling regarding your mattress order. I'd like to share some important usage instructions for your mattress. Is this a good time to talk?
Yes, Sana, it's a good time to talk.
Great. Could you please tell me which mattress you purchased?
मैंने ऑर्थो प्लस खरीदा है.
Thank you for letting me know. Here are the do's and don'ts for your Ortho Plus mattress. Do's. Use the memory foam side for a
आप मुझे हिंदी
comfortable
में बता
sleep
सकते हो क्योंकि इंग्लिश नहीं आती है मेरे को.
बिल्कुल. ऑर्थो प्लस मैट्रेस का इस्तेमाल दोनों तरफ से हो सकता है. जिपर वाला पोर्शन नीचे होना चाहिए और प्लेन सरफेस ऊपर. हर 45 दिन में मैट्रेस को 180 डिग्रीज घुमाए, यानी सिर और पैर वाले हिस्से को पलट दें.
मैं आपका मैट्रेस यूज कर रहा हूँ, बट मेरी कमर में काफी पेन हो रहा है.
आपके मैट्रेस पे एडजस्ट होने में 25 दिन तक लग सकते हैं. इस पीरियड को ब्रेक इन पीरियड कहते हैं. आपको पहले से ज्यादा कंफर्ट मिलेगा जैसे ही आपका शरीर मैट्रेस के साथ एडजस्ट होगा. अगर आपको अब भी पेन महसूस हो तो मैं आपको ऑर्थो प्लस मैट्रेस सजेस्ट करूंगी. कुछ और मदद चाहिए?
नहीं नहीं, मुझे मदद नहीं चाहिए, थैंक यू.
ठीक है, आपका शुक्रिया. यूजेज इंस्ट्रक्शंस मैं आपको व्हाट्सएप पे भी भेज दूंगी. धन्यवाद.
Guys, this made by me, please clap. So anyone like it? So this system can respond in any language, about 10 Indian languages. It can auto detect your language. It don't, if you even speak English, like some words in English and then Hindi, it can detect it. Kannada or English, whatever you have mixed it. So it was speaking in English and then I spoke in Hindi and it automatically detected what language I am in and switch to that. And if you see, the greatest part is the latency part here. It's using 3 stuff. It's using, so I'll go more. Okay. It's not there. Sorry. No, it's coming here, but it's not here. Okay, so it was an architecture diagram there, which was important to show you. Yeah, I can see it on my another screen, but not there. Yeah. Okay, so the most important thing here on this demo that it can work on a telephony line. So our telephony line in India works on 8 kilohertz. It's very, very less. Our computers works on about 44 kilohertz, 44K kilohertz. And 8 is very minimal thing where whatever you are saying is not able to interpret what you are saying. So we have optimized that how it can work on our telephony line. So call centers people can be replaced by a bot and they can do a better thing where the escalations are there and stuff. So it does support, of course, it's having a load balancer and all those WAF stuff, but have a primary node, and you can create multiple primary nodes, whatever, depending on the volume calls, what we are handling it. Most important part is that it have a VAD. We call it as voice activity detection. So whenever I speak, it stops. So it's give a natural way of speaking to the human, because we as Indians always speak in between. And we try to rule the conversation all the time. And we say, no, no, you are not right. Or whatever even we want to say, but we jump on the gun and do it. Right? So it understands that when you are trying to jumping the gun and stops. So it does not make you feel, understand that whole thing, and stop there and listen to you again so that it can answer. VED was the toughest part which we would able to crack. So we used one open source called Celario VAD. It does on real-time basis. Before time, it was like if you speak some sentence like 10 seconds long, it should wait 10 seconds, and then it should wait more than 800 ms to understand that you have stopped. Right? So that was increasing our latency. What we did is we created a ASR which understand real-time transcription. Real-time transcription is by one word by word. So whenever there is a gap, we could send it to the server and send it to the LLM, and it can make sense out of it. Second, it have a RAG, a normal RAG, which tells the process of that particular customer, what lines it should be in and what should it talk. For the LLM perspective, we tried almost about 4 or 5 LLMs. We use ChatGPT, we use Gemini, we use Quen, we used Llama. None of so the major problem what we got, that if you write a prompt, so every LLM you have to write a different prompt. So one prompt will not work for one LLM. And they can make out anything, whatever they want, because they don't understand Hindi. So what we need to do on the real time, we need to translate it in English. So whatever you are speaking, it's translating in the background in English, and then sending the English to a LLM. So what we did, end of the day, we fine-tuned Llama 3.1, and with our data, which we created for translations, it worked very well here in that sense. But that was a very tough part to crack the prompt. We took about 3 weeks for one prompt. Now, still it takes a lot of time to write a prompt. And prompt engineering is very great. Everybody should learn it. Because this prompt will not work for another customer. Another customer, we have to write another prompt. Yeah. So one of the use case which we solved for a bank. So how many of you do a KYC with bank when we open an account? Everybody, right? It takes weeks to open an account. Actual में current account में it बहुत time लगता है खुलने में. They check every document and scan it and check what language it is. For loan processing, they do lots of things, right? So using the tech which we have built, it can OCR the content and translate in real time and can give it to the banks. And so 1 week ka process, we did it in 2 hours. So this is a number of SRs we started with the bank, and it started with 60 and now it's 2,500 per month. And it can goes up to, they have a capacity of 20,000 KYC document they receive. This is only one bank in India. But this not stop here. We have multiple languages, like Japanese passport aa raha hai. You want a loan from ICICI Bank or Axis Bank, and you live in Japan, but you want a loan from here. How do they solve the problem? Indian does not know Japanese. right? So we could make out that problem and trying to solve that at scale, and it is actually helping those people who are applying for those loans or KYCs. Last 5 minutes, okay. So in the automation center, for the customer support, we are trying to help some customers. They receive almost about millions calls every day. We thought, why not we add a bot and try to solve it. We have seen the success rate, like for example, 100%, if we talk about, 70% are simple queries and 30% are complex queries, right? So out of those 70%, we would able to solve 70%. So like in total, 50 to 55% can be handled by a bot. But depending on the nature of that business, but once it's passed through our pipeline and understand it, we can retrain it and we can make it solve other problems as well. But right now we have seen a success rate of 55% on all. That is it. I'm open for questions. Thank you, guys. Yeah.
The Geminis and the other models that we have. I have been trying to do the translations for Southeast Asian languages, and it has been the accuracy. Let's say it's not really that great, right? So you also spoke about the tone of the language, right? It can be casual, it can be fun, it can be formal. And when we are trying to translate something like HR documents, it has to be very formal.
Very formal, yeah.
And Japanese are very, very particular about it.
Yeah.
So I wanted to understand, how did you approach that problem? Did you have human annotators? Did you ask LLM to annotate it?
Yeah.
So that's the question.
So so to give you a background, we started with translating documents with using our NMT model, and we use human supervisors on top of it. We work almost about 5,000 to 10,000 people once we started that annotating the data. And then we segregated that we have to choose few industries. We cannot cover all. So we focused on industries like banking, e-commerce, and publishing. So we thought we will only focus on these 3 industries and try to gather data of these industries and try to get it annotated with human reviewers, so that we can understand the context of that particular industry, how it works. Right, so it was a human effort, but now it's easier because I can add a layer of an agent and can ask कि इसको evaluate करो सही है कि नहीं है, and then again a final term is like what we have seen. Like before time it was about 80-20, 20% is human and 80% was machine, but now it's 95-5, which will always be there. I think I cannot change it.
So to start with, approximately how many documents
it's almost
would you use?
we collected almost about 1 billion parameters in Indian languages and spent a lot of money to get from translators.
Okay, thanks. Yeah.
Hi. Do you have an APIs to
Yeah,
consume
we
it?
have APIs.
And it only, you said only these 3 domains, or will it work for any domain?
We have a general domain as well, but we can customize it with time.
Okay, does it like, now we have a lot of contracts that needs to be translated to local language. Will it
It's a legal contract.
Yes.
We are doing some legal work as well.
Yes.
Yeah. It can support.
Okay, any more questions? Can we please take an outside, because we
Yeah.
are running short of time, Himanshu.
Thank you, guys. Thank you very
so
much.
much,
Thank you.
Himanshu. Please
Take
give
care.
them a round of applause, people. Getting ready for our next session. So the next session, we will dive into the challenges and solutions in building enterprise-grade speech AI systems. We'll explore how Dubverse has developed and scaled speech foundation models, including text-to-speech, speech-to-speech, and speech-to-text technologies. Our speaker, Varshul Gupta, is the co-founder of Dubverse.ai, pioneering the development of speech AI technologies for content globalization. With a background in research from IIT Delhi, he leads the vision behind Dubverse's speech foundation models that serve over 200 million users. Can we please put our hands together for Varshul Gupta?
hey everyone, this is Varshal. I'm the founder of this company called Upwards. We are very deep into speech, so this session is going to be about a lot of technicalities. I'm sure you guys have covered a lot on LLMs, text, some form of vision as well. So maybe this time we can go a little bit deep in speech. Cool. So while they set it up, how many folks have practically understood the transformer sort of an architecture, or dealt with LLMs? Just a quick show of hands would do. Okay. Okay. Great. Great. Helps me do RLHF on this talk. Yeah. So.
We are sorry for the interruption. I think they are trying to fix the screen.
Yeah. Cool. Unless that happens, maybe we can just like do some form of a quick show of hands. Have people working in audio or speech? Anyone? Okay. Okay. Voice. What are you working? If you're okay to share. Right.
We have a platform where we want to build a platform like Canva where we want to translate a script to a particular language and use that text as an audio to create a video using that audio. So that's where I
so largely the content generation space is what we can consider.
Yeah.
Anybody working on voice bots and voice agents over here? Okay. Okay. Yeah.
I mean, not right now, but I've worked on, when there is a telephone call with salespeople.
Okay.
We transcribe those things and then try to detect certain intents.
Right.
Especially in terms of in case of insurance.
Right.
So some of the questions are very complicated. Semantically understand those questions, gather those information, and then respond it
So
back.
it's largely transcription is what I'm assuming.
It was ASR followed by semantic search.
Got it. So like not deep like generative AI.
I mean, these days, my
These
friends,
days
friends are doing it. I
anything
mean,
AI
I'm
is
no
an
more in
AI.
that company, so
right.
I can't comment.
Cool. That's good. I think you had something to say. You're working in voice bots? Sorry? Oh, okay. You use voice bots. Right. So at what space, what scale are you using that?
We just started using it last month onwards. We've done about 5,000 calls, and the conversion has been very bad. E-commerce.
Got it. Yeah. I think that's a part of the early adoption that everybody is going through. Some tips and tricks that we've learned. So maybe I can share that separately. Yeah. Cool. Are we on?
We are really sorry for the interruption. I think it's taking a bit time.
Right. Is this the first time? Who's not attending this for the first time? MLDS. Everybody's first time, is it? Everybody's first time. Who's not first time? Okay, you. Okay, you're a seasoned guy then, out of all. Shall I come? Cool. Cool. I think there's some hiccup because we're trying to play audio. So yeah, I think we'll get started. So yeah, this is going to be largely about speed side of generative AI. I am Barshul. I run this company called Dubbers, where we're largely onto the speed side, where we do text to speech, speech to text, and I'll cover some of that. So a little bit about me. I've been in the intersection of research and building. Essentially, I'd spent some time working with startups. Initially, there was data analytics days, and we were doing a lot of data sciences, data analytics sort of work. No neural networks, no GPUs. So And then post that, I spent some time in IIT Delhi. I was working with a professor, I wrote a paper there in computer vision, and then started tinkering on a lot of AI ideas. I also ran an AI lab with a bunch of AI talent across India, and that's how Dubverse was born. So Dubverse is a product which is basically a creator product that covers largely video dubbing, which is conversion of any piece of video content from language A to language B, C, D. That covers video subtitles, and that covers text-to-speech as well. So we've scaled this to about 2 million users at this point in time. It's a global product with some of the largest YouTubers in India, like Beer Biceps, Raj Shamani, etc., are paying users. And we cover a lot of self-serve use cases where essentially what we wanted to do was we wanted to Canva, the entire experience of generating content, translating content, and that's what we've done with this sort of a product. So this is what we've been up to since last 2 years. Now we've been focusing on building our own models, which is something that I'll cover. Cool. So I think before we go very deep into the speech side, right? I want to cover like what the speech modality looks like. Yeah. So cool. I hope you can see this. So yeah, basically, speech as a modality, I mean, it's not very, very perceptive, right? Because text, you understand whatever you see gets converted in token format, and then you're able to understand how the compression and decompression is happening. But when you talk about speech, while it's very natural that a simple like a biological organ is able to produce sounds and able to perceive sounds, right? But then how does it work sort of mathematically? So if we talk about any piece of a TTA system, so the first piece is that there is some, in very nutshell, right, without going into the deeper levels, there is some form of encoding happening. There is some form of learning happening, which is essentially the synthesizer bit. And there is some form of vocoder, which is basically converting whatever it's learned to a form of an audio representation, right? So this is a very, very high level overview. Next, when we talk about any form of, just to refresh your memory on your audio signal processing days, I'm sure everybody dreaded that, some people liked it, where essentially any piece of audio signal, where you see an amplitude, which is basically in the time domain, gets converted in the frequency domain by using SFT, which is like a Fourier transform, right? So that is what this process is doing, wherein it's converting any piece of audio into specific chunks, and then at the end of the day, what you get is like a Mlds spectrogram. Now, whatever form of the transcoding happens, largely happens on this form of a Mlds spec, which is something that we'll cover in detail. Cool. So as you would have realized that like text-to-speech in itself as a technology has evolved so much. Remember the days when it used to really feel robotic with each and every word coming out, right? Wherein it's highly it's definitely not of use, has a very limited use case, and that too it's not very production ready, right? But now if you talk about it, we're talking about a landscape where content is, and not just any form of content, even Netflix level content is being produced by AI by using these high level text to speech systems. And I mean, your voice agents and voice bots are so real that it doesn't even feel that it's like a any form of AI, right? So how did this happen if you really look at it? I mean, well, obviously we saw with Transformers, there is massive amount of technological breakthrough that happened at a core algorithmic level, which is the transformer itself, 2017. And then the scaling across the last couple of years that OpenAI and others have been doing. Similarly, this kind of parallel has been drawn in speech as well, where the very nature of how do these models learn, which is the entire SSL nature, their self-supervised learning approach, has massively improved, where now you don't need to learn on a given piece of corpus, and that doesn't need to be very high quality. So in the sense that like self-supervised learning can essentially kick in with 90% accurate data, and we'll cover that when we talk about what our data strategy, data approach is. The second is powerful generative AI models, where largely we start talking about GANs, which is the first level of that like 32 cross 32 kind of images started to get produced, and now obviously these have progressed to more autoregressive sort of systems. And diffusion again is a very important component, because when you're talking about any form of temporal coherency, be it in form of image, be it in form of an audio, that needs to be produced with some form of a diffusion model. And obviously like scaling of compute and data, where we're talking about these earlier when we were relying on ASR systems, then we used to talk about hours of data, that any amount of open source data that used to come in a conference, everybody used to get excited about 20 hours of data, 30 hours of data. But now all of that is so archaic that it feels like Stone Age, and we're talking about scaling of these models on millions of hours of data. So that's what scaling in compute has done to largely text to speech. Cool. Since a lot of you have not worked in the audio, I wouldn't go a lot in depth. But this is the kind of work that we do. We've come up with our own foundational model in speech. It's something that we call Maha TTS for the external world. And this is something that we've created with massive amount of scalability on data sets of diversity, quality, quantity. So I'll cover some of that over here. Cool. So when you talk about like a text-to-speech system, right? Forget about all of these algorithms. The very basic way to understand is this, like how baby speaks to, how baby learns when he's speaking, right? It's like it starts with very simple words like mama, papa, right? With simple syllables, and then it starts forming a word, like let's say pani, whatever, kursi, something, and then it starts forming sentences. Then it starts forming paragraphs. So essentially, if you look at it, the learning ability of even a human brain is evolving with more and more context. The ability to have different forms of phonemes is what we call, and essentially able to learn that, right? Now, this is what at large in a text-to-speech system we are trying to replicate. Earlier, these text-to-speech systems were largely based on phonemes. So if you talk about my name as, Varshul, it's V, R, Sh, U, L, like how phonetics, some of us did learn. But currently, I mean, the approach that essentially all of this paradigm has taken is we don't need phonemes per se, because phonemes can be very, very lossy in a certain way. I mean, if you tell you a name, right, then I can just like start to pronounce it, even if I don't know that language in some cases. Why? Because I'm just reading in the letters. I'm not, in my head, I'm not converting that into phonemes. So which is what these systems have been able to replicate. In nutshell, this is what's happening in the pipeline. So you need a lot of text and speech level data. So if let's say hello, how are you is written in English, then the similar corresponding audio needs to be there for that specific said word. So the system essentially is able to learn that mapping. Not just to a level where it's simply pronouncing hello, how are you, but essentially even if you lay out emphasis where hello is always with an excitement, or statistically is 80% with an excitement, then even the system is able to learn that the next time the system has to pronounce hello has to be with a certain amount of excitement, right? So these are the capabilities that have been possible because we prepare some form of a parallel corpora, which is essentially we have a lot of written text and a lot of recorded audios of that corresponding text in multiple languages. So yeah, just I want to cover a little bit about data. This is, I'm not sure who all have recalled this, but this is a slide from a talk by Jan LeCun, which talks about how the entire ability to go from less supervision to more supervision to less supervision is happening. I mean, essentially, data is practically the way that you would look at it like a cake. Okay, so when you look at a cake, you realize that there is a base structure, which is more of a like the bread essentially, that has the most amount of information, but that might be the highest quality of information, right? Because that's just the base. Then essentially comes the layering between the base. That is the second part. Now the third is where that this gets more exciting, which is what people are calling RLHF, is basically the cherry on the cake, which essentially means that this practically requires very less amount of supervision. So even if you look at a DeepSeek, the way that they are able to exploit more runtime level computation, runtime level inference is basically that, I mean, they move from highly supervision to very less supervision, right? So that is where the entire field is moving. So now let's say in a text-to-speech sort of a system, we say that we cover, you know what, we cover 10 languages, and now we want to add an 11th language. So you would not need the similar amount of data that you needed in those 10 languages to enable an 11th language, right? So that is what it allows. And I mean, that's how practically we as, humans also learn to speak. Like if somebody is speaking, you know, let's say Bengali or Assamese, then you would not categorically know that this is what it means, but you somehow know that it's Bengali. Why? Because it's maybe somehow related to Hindi, and that's what you've learned. So this piece is, I think, very important when we're developing these foundation models, because look, we can't always keep scaling our data pipelines very linearly to the new languages, new use cases, etc. that we need to have, which is why there is a certain component of RL that has to kick in. If not RL, then at least some form of self-supervised learning that basically enables all of these models to perform very well. Yeah, so as of now, we were covering, just one component, which is basically the text-to-speech, but I wanted to zoom out with respect to how, this is well suited in a very GenAI context, how this can be added to direct modalities across the different sort of GenAI use cases that have been covered. So one of the use cases, I mean, obviously, when we talk about any form of AI deployment, largely we're talking about LLMs, which is largely text, right? But if you really look at it, then the human communication in general is best when it's more speech to speech. When two people are talking, that's the apex of human communication, which is what a lot of these voice bot and voice agents are trying to replicate from sales standpoint, from a customer success standpoint. And that's where you need these, like, speech as a modality very tightly tied into your entire experience of delivering a Gen AI solution and an offering. If you look at, so there are two ways to go about it. The first way is something that we call as cascading approach, which is basically the output of one system is the input to the next system, right? So this is what this piece means. So when you talk about, let's say I ask a question, right? How many people are there in the room? Now that gets converted to a textual format by an ASR system, which is an automatic speech recognition system, which is something that you see every day on a Google Meet or something like that, right? When you press a CC button. Then is essentially that entire intelligence piece that kicks in, which counts and tells how many people are there in the room, and then it comes with an answer of, let's say, 45. Now this 45 is then converted from a text module to a speech module, and then you get an answer of 45. This is the entire sort of stack of a very cascaded approach. But the problem with the cascaded approach is that, I mean, at the end of the day, it's essentially for some form of error compounding that's happening. And practically, if you look at it, 80% of an 80% of an 80% is 51%. Right? So you started by saying that, hey, I have a system, I have a module that's 80% accurate, but then by the end of it, since the nature of this very application is very cascaded, you end up, achieving 50% accuracy. That's as bad as having nothing, in form of any GenAI application. Which is why you see a lot of this approach moving from a cascaded approach to a end-to-end or a speech-native architectures, which is where you realize a lot of these multimodal architectures, a lot of end-to-end architectures are sort of kicking in. And I think OpenAI on that note would be the first ones to display that with their GPT-4o and that entire voice module that they had. Even there are two ways to go about it. That A, you do some form of a audio encoder. So now your question is directly getting fed into an LLM. I mean, there is basically you're bypassing the ASR component, which means that there is massive amount of accuracy. and then obviously you have a text-to-speech system, right? So this is one approach. The other approach is that you jointly train everything. And when I say jointly, it's not like a from scratch, sort of a pre-training that's happening. I mean, you train one component and then you convert that to an adapter and then you jointly train some of that. It's basically something like very similar to like welding, if you've seen in mechanical terms, pure mechanical terms. So this is something that this sort of an approach, I think, is, if I'm not wrong, Sarvam is taking this sort of an approach because they release this module separately and then obviously a text-to-speech separately. This is something that is a completely GPT-4o-ish approach. There's also a couple of more releases if you guys are interested in this. Qt launched something called as Moshi. I'm not sure if someone tested it out in the voice agent space. But that essentially is more of like a duplex-based system, which is kind of what this sort of an architecture is. Yeah. So again, I mean, the entire idea of taking a text-to-speech sort of a system and then combining into your entire Gen AI sort of a stack is to very categorically look at what part of the use case that you're serving and where is it fitting in. And obviously there are multiple approaches like I explained over here. Cool. I think this is a little bit from a research standpoint, but I'll still cover. There are a lot of opportunities in on the audio, on the speech domain. One of the things that you can right away test it out with a ChatGPT is that if you give it a negative example of shouting, but saying it in a very telling it a very happy and jolly thing, so in that case, that system would never be able to recognize what the emotion of the audio, or the intent of the audio is, right? Because it categorically falls to the text more than just the audio, right? So there are a lot of these audio intelligence level sort of features that have to come in. 2 people talking, 3 people talking, we have guys having a Q&A, it's a noisy setting. So that sort of a landscape or soundscape to be covered with audio with LLMs at large is something that's still open, and that a lot of that work will come out. Yeah, RLHF, like I explained, is something like rather than talking about voice cloning that a lot of us hear and use, that there is this politician that is being voice cloned, that this celebrity is being voice cloned. But rather than that, can you come up with a very sort of a RLHF way to have learning from a sort of a system, and that could unlock very native use cases, like let's say a Hindi in Delhi sounds very different to Hindi in Bihar, right? And that's the same language. And I'm not talking about the dialect even, right? The way that you would pronounce a word, that you would structure out a sentence. So these sort of native use cases get massively unlocked with some form of RLHF, because the need or the amount of data that you require goes down. So as that goes down, then obviously your scalability kicks in better. Cross-lingual transfers is something that's still not very well solved. Yes, and I think use case around translation, where basically the way that you would want to feel an emotion in, let's say, when you're watching a South Indian movie being dubbed in Hindi, right? I mean, a lot of us feel that gap. There's a native gap that exists, and it's not just the visuals, it's not just the action, etc. It's practically what you want to feel from what the actor is saying from a pure vocalization standpoint. So that, I think, is still has a long way to cover, because there you're trying to map not just a vector space of text and audio, but you're also trying to map a vector space of language A to language B, right? Audio adapters, like I explained in the last slide, that as and when, I mean, Llama 4 is going to come up, right? And then a lot of other open source models that are going to come up. So even DeepSeek for that matter. So can you take that and essentially jointly train some form of an audio adapter into your use case? So these sort of use cases will also get unlocked. Someone in an audio domain having call center sort of a domain data, someone having content related audio data, someone having like a lecture sort of audio data. So can all of that be converted can be sort of jointly trained with some form of an LLM is something that is also one area of opportunity. Cool. I had some samples to play for you, so you can get a sense of the kind of work that we do. So maybe you can play the fearful one. Sorry. Yeah, I think they're fixing it. So we deal with more sort of content generative use cases where basically there is massive need to keep it consistent. It's like what I started my talk in the first minute might not be very consistent in the 10th minute. But if I'm a good orator, then I can maintain that for good 60 minutes, right? So this sort of a system is something, I mean, that boils down to the very fundamental properties of these models as well. So one of the things that we are massively focused on is context window. So the difference between taking two 10-second patches and then combining them versus generating a one long 20-second sort of a context is the difference in the delivery or the quality and the accuracy that my enterprise pays me for, right? So these are some of the things that we are working at a very fundamental level. Yeah, sorry. Right. Yeah, no, that's definitely a problem, and that's a problem at two levels. One is just the very setup of that data. The domain of the data is not something that the model has seen. Let's say people, you having a call and standing in the market. I mean, that's not something that the model would have seen, right? So that is the problem. The other problem is that there is a lot of upsampling and downsampling happening as well, because the call is generally, I think, is at 8 kilohertz, right? But these models are trained even higher, 16 kilohertz, etc. So when you're trying to fit that data into these models, then you're doing some form of upsampling, which might not be very accurate. So again, some form of cascading is happening. So hence, you would not get the best of results in this sort of a setting. But what we've seen is off-the-shelf models like Whisper, OpenAI's Whisper, etc. They work decently well, provided it's in English. If it's Indian languages, then you're going to have a hard time. So yeah, just play some of them.
I bought a vacuum cleaner 6 months ago, and so far all it's been doing is gathering dust.
Yeah, so I mean, now essentially, you can just keep playing some of them. These speakers are able to be so emotive that they can even generate a laugh, and we don't have to induce a laugh. You don't have to tell that, hey, you need to laugh after the fourth word, because you can't do that as a user, right? So the model
just I'm trying to process it all, but it's like I'm happy and sad and everything in between.
Yeah, maybe the fearful one. I think that's in Hindi. This one.
कौन है वहाँ? देखो, मैं मजाक नहीं कर रही. अगर कोई है तो सामने आओ.
So yeah, I mean, it's able to induce all of those emotions that you practically feels like it's a human. By the way, it's not human. All of this is AI, and this is something that we've been able to unlock because, like I said, that one of the things that we work on was long context models. So these sort of models is something that we've trained of our own. I mean, the pipeline that I explained, some of our work is out in open source as well. That's not very updated, but you can still check it out. Earlier, I mean, the journey went from that we released our first set of models, started working with some community. We did short context models. This was about, I think, 10 seconds, and then one of her work also went live on Netflix. If you've seen that series of IC814 Kandahar Hijack, we've powered ex-politician's voice, which is now no more, and now the production house wanted his voice, so we created a voice clone version, and then they went live with that. Then we started working on long context models so that they can maintain that coherency, consistency, etc. That went live on for audiobooks, and now we are working on a lot of emotional controls and context, which you saw in the slides. Yeah, so I mean, on that note, we've trained these models. We've sort of spent 100,000 GPU hours. How I get it as a small startup is maybe a talk of another day, and I might not reveal all my secrets. But this model is something that's been practically trained, from scratch. It's covers about 16 languages, works really well on certain domains. This is meant for enterprise, so you would not see a lot of noise about dubbers doing a lot of this. And yeah, this is our little machine. We call it Tomahawk. This is in our office. I mean, this batches about 5 to 8% of our workloads, but then the very ability of not renting out a space, like a cloud, and having of your own is something that I consider as a big milestone in our journey. So we did that sometime 6 months back, and I mean, it's mostly of use. So that way we end up saving a lot. That we end up spending on foreign clouds for GPUs. Yeah. So yeah, that's about us. That's about it. Thank you. Thanks for being a patient audience.
Thank you, Ashul. The question and answer session, if we can take it outside, if you don't mind.
Please. Yeah, happy to catch me outside. I'm still here for some time. Happy to talk about anything audio, anything like startups, creator space, and everything. So yeah, thanks everyone.
Before we start our last session, there's an announcement. Intel workshop on OPA, Open Platform for Enterprise AI, is happening in Hall 1 and 3 by Sriram K. Vasudevan, in case if someone want to attend. So there's one last session that we're going to end the day with. The next session is Building a Strong GenAI Foundation for Lasting Success by Arun Munuswamy at Genpact. Giving a synopsis, GenAI is rapidly transforming industries and reshaping how we work, communicate, and innovate. With its growing influence across sectors like healthcare, finance, and entertainment, acquiring GenAI expertise is crucial for anyone looking to remain relevant in the workspace. This session will provide a concise roadmap to build essential skills and knowledge to succeed in the era of GenAI. Arun Munuswamy managed challenging digital transformation programs across a range of service lines and has emerged as a successful delivery program leader. Arun is the Assistant Vice President Delivery Director at Genpact. He has worked with Infosys Technologies, IBM, and Wipro. He is responsible for the delivery of various transformation programs in niche technologies. Put your hands together for Arun, please. Over to you.
Thank you. Good evening, everyone. So last session, I know that, and it's going to be, let me make it as very interesting as much as possible, because this is going to be for the beginners or like intermediate like me, and especially not for the experts or who are experts in AI, okay? So this, as the name suggests, solidify your AI foundation to be on the success of the roadmap. It doesn't come so easy like a cakewalk, just taking into that. So from the morning, I think there's a lot of sessions happen. We all are trained like an agent with the data coming from experts. So all of us becomes an LLM, fine-tuning our model to increase our predictability. So in other words, I can say the predictability is that increasing our impressions in LinkedIn with all the updates what we have, so that we mock the AI model to be like we are very good in the terms of AI. So with this, so always like we say, the good thing starts with the sweet. So let's start with a small story or kutty story, okay? So here what you see, anyone can, I think most of us, you judge this movie. Can anyone, Troy, anyone can give the context of this story? What is happened to the scene? Exactly. So the context is very simple. The king the princess, and the minister. They're discussing that there is a wooden horse statue which is outside their fort, and they're discussing whether it should be taken inside their territory or what to do the next step. The king says that it's a gift from the god, and ministers acknowledge to that and they don't want to take inside. But the prince says that no, it seems to be a trap. We should either sink in the sea or fire it. The king does not listen to these words. And you know what happened? They took inside the territory and they celebrated. The next, what they see is that, as the gentleman said rightly, it's a Trojan horse where the enemies are inside and they started coming out and they're letting the doors of the fort to open, and at the end you see it's become a very big miserable where the entire territory has been fired. So here's a simple story is that whatever the model we are building, there's a chance that it gets into fire. Agree? Everyone agree for it? So what's the water for it? If anything is the fire, that should be water. Any guess what the water should be? Anyone here? Any guesses? Monitoring, but what to monitor? Absolutely. So data foundation is going to be your water in order to save your model which is in fire. With this context, just keep for next 15 to 20 minutes, we are going to travel on how the foundations is much more important than building a model. With this, what we see next, this is one of the classic example. This, anyone remember this, the first test where India between Australia. You see at the end of the the day 4 session 2, the probability is 99.4 is draw, 0.5% of Australia win chance, and rest 0.2 I think is for India. We all knew what is the result? India won. In the third session, you see India has won on the day 4. The predictability was 99.4 draw, but it is ended in the just opposite of the prediction. There are lots of failure cases like this, so which I like to take a top failure cases and what the lesson learned from those. The one classic example, I don't want to reveal the name, okay? In 2016, an AI chatbot on the Twitter has been built, and it started posting offensive, racist, and inappropriate content after interacting with users. That obviously happens, correct? When we interact with bad people, they say that we also became like. But it learned from the interactions and toxic behavior from the users influence its output. So what's the lesson learned? There need to be a content modernization and safeguard to prevent learning harmful behavior. So this is one of the key learning from that AI chatbot which they in 2016. Similarly, this is from one of the driverless cars which they're trying to make. It was involved in accidents due to misinterpretation of obstacles which is not able to identify and the road signals. The main reason for the failure is that insufficient suffocation is to handle the data and the scenarios are all edge case. So because of this one of the things where the lessons learned is this is the most important thing and is still it applicable to many of the models. The continuous development and human oversight is essentially for any type of critical models which we are building. The third one we see is that is one of the classic example where you might be all known about this. A AI hiring system is a biased for female candidates wherever you see a favoring for a male candidate for a technical role. So the reason for the failure is the model has been trained on a biased historical data and perpetually into a gender stereotype, correct? So many of the models, wherever you go for, even for LLM you try, the more false data or false positive, false negative what you're getting into this, the scenario is mainly based on the biased data. The lesson learned from this is that addressing the bias in data, okay, we need to ensure that the fairness and the transparency in terms of making. So this is the way where you can't build all the models in any of the use cases which you think that easy cakewalk. So the basic thing is that you build a model, you need to understand what type of training you use and what type of stereotype is going to behave based on the data. The next is a classic example. One of the AI was designed to accept the phone calls, okay, in order for booking an appointment. Okay, this caused an confusion and raised an ethical concern. Anyone guess why? Because it did not reveal that it's an AI. The patient thinks that they're talking to a human. And then it seriously raises a concern. That's why the lesson learners, you have to be a very transparent and the AI whatever you do it across. Right now, what are the things you have, what are the things in terms of AI agents? You see that most of the things people are unaware that they're talking to a chatbot. So that is not ethically correct. So it has to be transparent. People has to know. Many scams, whatever you see happens, you will think that these are human speaking, but it can be a machine driven or a model driven. So it has to be ethical is one of the things where the lesson learned. So these are the top 4. Okay. By the by, this all the things I did it through a OpenAI, ChatGPT. I got this from there. And you can also do it in next 2 to 3 minutes. You get list of amazing top failure cases. Next is one, what we see. This is a classic example from my side, I think as an beginner or an intermediate. Where you see the tip of the iceberg, what we see is a GenAI skill sets or model the building. Anyone can guess what is the hidden part of the iceberg? Yes, there are 2 things. One is the basic skills, another is the foundational skills. I will explain the upcoming slide what are these things, but the tip of the iceberg is what we see, but the most important thing for who are aspiring to become a AI developer or entrepreneur in terms of getting into building a product, like what are the things we see in a couple of sessions. So the hidden part is more important. So this translates to my next session for the developers or entrepreneurs who are building to be an AI building block. This has the stages of 7. The primary block, this might be surprising for many of you, but you see the max. You think, what? Max? I have been fed up after reading till 12th standard, then engineering first grade might be first semester. Now you're saying after building it, want to be an entrepreneur or AI, max is required? Yes. Definitely the first step is max, especially in terms of your calculus, in terms of your algebra, linear algebra, in terms of your, what do you call this one? Probability and statistics. For example, take an instant. I am going to hire a person for crickinfo.com. I'm just quoting an example. He needs to create an LLM model where Boomerang is bowling a ball. Okay, we need to create an AI model in upfront saying that how the model will behave when he's going to bowl on a, say for example, Tendulkar Pavilion pitch from the Wankhede Stadium. So the things to be calculated when you want to understand is your linear integrations, correct? How it matters, your bowling speed, the wind, and the in-swinger water we do. These are some of the decision makers in order to understand. A good developer or good in order to develop an LLM, these are the things of like your linear algebra, differential integrations, and your probability makes you a good developer. So this is where important things which you need to understand. The next thing is what? Any coding language. The preferable coding language is your Python program. That's mainly user free, open source, and you have many libraries which are invocable, and then it will be easy for you. Especially you're like NumPy and the pandas for data integration and your number calculations, correct? So these will become a basic skill in anyone you want to integrate into your LLMs. So from my perspective, these 2 are going to be your basic skills. The next skills, what you see is nothing but your data. Like now we are going to talk about the water portion when the model is in fire. So one need to understand what is data sources, okay? Because data source might look like a simple, but they need to understand what are the different types of sources. With the cloud and IoT, whatever we have, you have a massive data sources. Next is the data engine. This is an important layer where your data is getting converted, transformed. Not necessarily that you may think why an AI person need to understand their data engineering. At the end of this model, you know why data engineering become an important in the next few minutes. So data engineering plays an important role where they transform exactly any business. Your soul or heart of the business is going to be a data. This is data engineering is going to do transformation according to your rules. Many LLM models are getting generated into optimize your data engineering. Many service-based companies will prepare their models in data engineering to optimize. Next is what you see is your data platform, the way you store. Okay, the classic example, there might be not necessarily everything to be stored in cloud. Some scenarios where right now we're discussing, the last scenario we discussed about storing in your on-premises. So you need to understand what is the different way of storing data platform. Next comes is your visualization. Instead of visualization, I will say is that this is the first level stepping towards your model level or any AI, because here is where your analytics comes. Either it can be your descriptive analysis, your diagnosis analysis, or your prescribe analysis or predictive analysis. Anything which is going to be the first layer of your LLM models. So either it will fall in either of these four categories, correct? It can't be anything beyond that. Either it can be a descriptive, diagnosis, or predictive or prescriptive. So next is what you see is your layers of your building your model. So here you see is that I am put at a model building, but it can be an AI, it can be an ML, or it can be a GenAI, everything. So here you comprise of LLM, SLM, everything you will be comprised across. The point which I was explaining why data engineering is going to be an important, because you require a feedback loop from your model to your data engineering layer in order to have your increase your predictability or success rate. Maybe till now, the last week, 2 weeks before, anyone knows that OpenAI was going, ChatGPT was going to be number one. DeepSeek came. We doesn't know. A week after, you don't know what type of things will come. And these are the foundations as a person, like as aspiring developers or entrepreneurs who want to, you need to understand all these levels, because these levels is going to be your AI building blocks. You can't jump into the level 7, okay, without understanding this. Yes, you can, but you will not get the fullest of what you require. So it's up to you. It might take a considerable amount of time to scale up you, but there is no harm in getting that from my perspective. So with this, I just want to go to the next one. I think the founder of Devangiri, Harsh Sharma, rightly pointed out, the generation is going to get changed. Nowhere is going to be any search engine. Search engine is going to be not a conversational type, it's just a question type and answerable. But prompt engineering is going to be the way of the future. And that is going to be the key of success, not only for your modeling, but for your learning, for your day-to-day activities. And this is one of the important field. From my perspective, it is going to be a niche skill or need skill for anyone. Whoever knows good in terms of prompt engineering, they might be a better developer, they might be a better performer, they might be a better entrepreneur, or they might be better whatever the roles they're doing. So quick snapshot on what is prompt engineering. See, prompt engineering is nothing but it's art of designing effect. It's like a conversation. Hi, how are you? And how are we going to take this one? So this is something, the art of inputting the prompt and which is like interaction. It's not like just saying hi and just putting a question, what is your name? It is like interaction, it's an art. Then, how the language models will work. Okay, you have vast variety of data. It doesn't comes with just one question. It has to be a structure of conversations. So that is where your prompt engineering helps. What type of prompts or basic components, correct? One, it has to be clarity, correct? If suppose, maybe, if I'm not interested in taking this session, people might be moving out of this one. That's one of the first sign I have. So clarity is what required. And what is the context? The context also is need to be one of the basic informations. And then, even though you know the clarity, but you have to instruct, correct? What question need to be taken in the right order? So this is one of the things where basic components. The next is going to be the more important thing is that what type of prompt you need to use. Not necessarily that. See, there are like 4 right now: informative, creative, problem solving. Informative is like same, explain what is this, blah, blah, blah. It will give you a list of answer. And then if you want to tell you write some short story, you want to narrate it some lines, they'll give a story or it can be done. In terms of problem solving, you can give it what type of problems. Either can be a large number of code to ask him for a solution. And last but not least, the conversation. Okay, conversion is where it keeps on writing. That's one of the things where prompt engineering interact LLM. Correct. This is the whoever is going to be expert in terms of conversation, you get better output. And what type of advanced techniques or what we use, okay, here. One is zero-shot learning. Zero-shot learning is nothing but what we do in a search engine, Google search, that's all. You ask for a thing, they'll get it across. Few-shot learning is nothing but, okay, you give me this detail. I give a classic example. This slide, I prepared through ChatGPT. One, I asked what are the prompt, what are the key skills. It given me the list of content. I asked that, okay, can you give it me a tabular form? It gave me a tabular form. So that is where you comes across your few shot training. So you train them. What is the required? Correct? And similarly, temperature, this is nothing but you limit, okay, for example, you want to limit your, I give a document, okay. I usually do a cross-links. I write article in LinkedIn. The same article can be published in Medium. And the same can be published in newspaper. Everything can be done. It depends upon. I am using effectively AI. I ask for this responsive questions. It gives me. LinkedIn article I can publish with a few pages. But at the same time, I can't publish in newspaper. I need to be reduced. So these are all things which happen. That's what you see in the real world example, correct? Content generation. The people who are like authors, writers, bloggers, content generation. I think many of you guys might be already using your GenAI as one of the effective platform tool. And in terms of educations, I think the tutors, correct? Mostly it's going to be AI tutors going forward. And many of these the case examples what you might be seen. The last but not least, this is what one of the important slide from my perspective. Not necessarily that we need to be producers, okay? It can be consumers also, which is going to be a more revenue generating stream. There are a lot of producers, maybe in the sessions, whatever we see, you might be seeing like GenAI founders, GenAI people coming and explaining all the architecture. They belongs to producer side. There are a lot of avenues to generate revenue as a sub-consumer side. If you're a blog, if you're a YouTuber, you have excellent video generation content. AIs are available where you can generate and definitely going to increase your followers, and it gets a lot of revenues. So lots and lots of use cases depends upon your which side of you belongs to, whether you belongs to a producer side or belongs to a consumer side. So with this, I complete my note. Okay, so this is session, as I mentioned earlier, this is not for the experts or beginners. We have enough sessions on LLMs, what is RAG, what is CAG, and what are the things. This is mainly in the foundation level, who are the people aspiring, what are the things. So any questions on any perspective, let me take it up.
No questions for the day.
I think, yeah. I think
right.
they're all.
Thank you, Arun.
Yeah,
I think it's been a long day. This brings us to the end of day 1 sessions. Thank you all for your support and cooperation. You may now move on for the day. Tomorrow, we'll continue again tomorrow and the day after. Make sure you participate in the competitions and win some exciting prizes that are lined up. The details can be found about the competitions in the lobby area. Thank you. Enjoy your evening. See you tomorrow. Thank you all.
Thank you.
Thank you, Arun.
Have a good day. Thank you.